Hello everybody, welcome to the AWS DevOps full course by Intellipaat. In 2023, Deloitte reported that almost 90% of companies are using the cloud for developing and managing their softwares. And there is no surprise that a big chunk of that workload is over the AWS cloud. Reason being, AWS is thought leader in cloud space and holds the major market share of 33%. Since the adoption of AWS is higher, AWS DevOps has been gaining more traction in the DevOps space. AWS itself has reported a 52% increase in job listings for AWS DevOps. That's why AWS DevOps is something you should learn if you're looking to become future-proof in the software development industry. Gone are the days when engineers used to have one specialized skills and worked it throughout their careers with blinders on. Now, the IT world is levitating more towards interdisciplinary work where the team who creates the product will also manage the deployment and other operations-related tasks. Companies like Netflix, Adobe, Walmart, Capital One have already adopted and benefited from AWS DevOps. And many companies, be it large-scale MNC or startup, are implementing DevOps into their development practice. That's why if you want to be future-proof, you must think about learning AWS DevOps. To help you exactly do that, we at Intellipaat have designed this free AWS DevOps course. This course has been taught by our top 1% industry experts associated with Amazon Web Services. And I am pretty confident that if you stay until the end of this video, you will understand AWS DevOps all the way from what it is to its practical adoption. Because towards the end of this course, we do have one practical AWS DevOps project for you, which will enable you to practically understand all the necessary tools and how to work with them. So guys, make sure to stay tuned with us till the end.
DevOps. What is it? Why is it essential in today's work culture? You'll be getting an entire idea as we proceed. First of all, let us understand what led to the DevOps movement. And to know that, it is essential to learn what sort of difficulties came across while getting a software out in use. Development versus operations. Yes, development and operations are two different entities in an organization that never get along, though they ideally work in close coordination. You might often have heard about the frictions between the two teams due to this siloed mentality. Many times what worked on developer's side failed when got on the operational flow, and hence the never-ending conflict arose. To operations, developers always build code that are oblivious to real-world constraints, and developers are under the impression that ops are resistant to change and hence becoming an obstacle to get a perfect product out. So, they tend to lack a synchronization that affects and definitely delays the process of development and ultimately deployment. Another reason for this big delay is the traditional waterfall model most of the organizations operated on. Testing is done only after the entire code for a product is written, just like that, and every component of the process is dependent on each other. So, how does it hamper the overall performance? Let us understand in this way. So let me give you an example for that. Suppose you have got 4 phases to develop a whole product. So now you have developed phase 1, then phase 2, phase 3, and finally phase 4 is also developed. And after the phases, it go for the testing. And testing team finds a bug in the phase 2 itself. That means all your efforts in coding phase 3 and phase 4 went in vain, since phase 2 itself was faulty and needed correction. So the logical building of phase 3 depended on phase 2 and so on, right? So what will happen? Again, you need to rework from phase 2, which killed your time, your efforts, and of course, delayed the process of product development. One of the major reasons of delays. And as a result of that, your productivity decreased because of the dependency on each other, and it increased the cost and timing required for the product to be up and running. So to address all these issues, to solve the conflicts between development and operations, DevOps was introduced. So what does it really mean? Let us go in detail. So it was introduced in year 2009. Let me tell you one thing. that it's not a tool, a software, or a language, but it is a culture, a philosophy, a change in mindset that encourages everything which is required to improve the way you do your business, to increase the productivity, lower the cost, and smoothen the process. DevOps requires a change in the mindset of how people work. In a DevOps environment, development and operations work in collaboration with each other and not against each other. It firmly believes in eliminating manual intervention, for it takes time, and automating the process and continuously integrating them. And most importantly, it works on agile methodology, means different phases of a product are developed and tested simultaneously and not sequentially. Since you now know and you have the knowledge of what is DevOps and which methodology it operates on, let us talk about the phases it incorporates. So, it majorly has got four phases. Continuous development, that is continuous coding. Just like I told you that a software coding is divided into several phases to make the task easier. Continuous testing means whatever code is being generated is constantly being tested and hence doing the testing in a few minutes or hours, which would otherwise might take days or weeks if done manually. And flaws are immediately detected if there's any and sent back to the coding team to rework. That means development and testing keeps on happening simultaneously and not sequentially as happened in waterfall model. Then it has got continuous integration. That is to say, whatever code is being generated or different versions of the same product is being saved in a local repository for future footprint. You can always review your work by using this continuous integration. And finally, development phase. So the coding is developed continuously and operated on the operational floor to check the efficiency of the product in real time. So these are the various and essential phases of DevOps to create a smooth environment for the organization. Now, as I said, that DevOps is not any technology or tool or a language, but a culture which emphasizes on using various tools, automation, close collaboration, synchronization, so as to help the organization, thus benefiting the complete software development to deployment process. So let's discuss some of these tools. Let's start it off with Jenkins. Yes, it's an important tool in DevOps culture. It is a tool which supports continuous testing of the code, continuous integration, and deployment of the code. Basically, it automates all the processes. Then we have got Ansible, another tool used for application deployment and software provisioning. Using this tool, you can deploy your applications in n number of systems at one go. You don't really have to do it again and again, and hence saving the time. And then we have got Docker. It creates perfect environment for your applications to run. For example, if one applications run on, let's say, Windows and the other one requires iOS, so instead of having two different software codes, you simply have one Docker. Yes, and it would take care of all the requirements of your applications. Then we have got Puppet. It's a configuration management tool which enables system administrators to work faster and used for server provisioning. That is to say, it allocates the works to server and hence taking care of the management of your entire server infrastructures. Then we have got Chef. It is used for automation of infrastructure. With Chef, your infrastructure is defined as code, ensuring that configuration policy is flexible, versionable, testable, and human readable. It measures the load on the server and distributes it accordingly. Then we have got Nagios. It is a computer application that monitors system, network, and infrastructure. And what does it do? It alerts users if anything goes wrong, rectifies that, and again informs the user about the same. It also informs the user when any human intervention is required. And then we have got Git. It's a distributed version control system and one of the most important tools used in DevOps culture. And what does that mean? The distributed version control system means it is not dependent on any server. Even if your server fails, you'll be able to work. It maintains all the versions of your software with all the features. Like if you have written, let's say 1.1 version of a software and then 1.2. So it'll keep all the versions. So anytime you can have a look on that and use accordingly. Also, it allows the users to work on different versions of software simultaneously. And finally, we have got Maven. It is very simple. It is used for compilation of source code and running tests. So these were a few of the tools used in DevOps culture shift to make your organization run smoothly and effectively. Finally, let us also talk about the advantages of using DevOps. First of all, it improves the collaboration between the two essential teams in the organization, development and operations. It encourages a change in the mindset to get the maximum profit out of your business. As a result, when people work with each other in collaboration, productivity definitely increases and eventually it decreases the cost, which you since you take less time in getting the product built. And finally, you maintain a good position in the market since your delivering rate of product is increased. And because of all of this, you have got happy and satisfied and smiling customers. You are all sorted. So let us now see how cloud complements DevOps. So now you know DevOps is a process to improve your way of doing business. And cloud connects and facilitates use of technology and services while taking care of provisioning of infrastructure. So cloud computing allows developers more control over their own components, resulting in smaller wait times. This application-specific infrastructure makes it quite easy for developers to own more components. And by using cloud tools and services to automate the process of building, managing, and provisioning through infrastructure as code, service teams speed the development process, eliminate human error, and establish accountability. And hence, cloud gives everything that is required for the DevOps to flourish. And finally, let's have a look which companies are following the DevOps culture. Many industries are already doing DevOps like Amazon, Walmart, Visa, Sony Pictures, Adobe, Facebook, Netflix, to name just a few. And after all that, let us discuss the most important part, career opportunities DevOps has for you. As I said, it's not a technology that can be replaced by some other technologies. So any organization, if they want to grow big and work smoothly, they got to have DevOps in place. They don't have any other option. So employment for a DevOps expert is never a problem. As far as money is concerned, you'll be earning a handsome amount. In the United States, a certified DevOps professional can earn somewhere around $120,461 per year, according to Indeed.com, which is quite promising and quite, astonishing as well. And after all this, you can get 360-degree knowledge about DevOps at Intellipaat with the best industry experts and witness your career grow. So these are the courses we here provide you at Intellipaat about the DevOps. Like it's designed by industry professionals, then you'll get hands-on projects and case studies, self-paced training videos, instructor-led videos, and finally Intellipaat DevOps certification.
Just a quick info, guys. Intellipaat offers AWS DevOps certification training course. Through this course, you will learn EC2, EBS, Elastic Beanstalk, Lambda, Jenkins, Puppet, and more from the top 1% of industry experts around the world. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of AWS DevOps.
Now we're saying what is version control with Git, right? The word that you see on my screen, it says version control with Git. Now there can be three different questions in this. First of all, what is version? Now then what is version control? Then what is Git, right? Start the discussion here now with a question called what is a version basically in a general way with respect to a software. Yes, what is version? The version is just a number that is associated with the software release into the market, right? Associated with the software release into market, isn't it? That's what you see, right? iOS 17 dot blah blah or 18.1.2 something, or say Android, you have it. That's what you see it, right? 11.0.2, 12.1.1, something like that. So any software that you are releasing into the market that is always associated with certain number. Now that numbering is nothing but we call it as versioning of the software. Now, why is that versioning is mandatory, right? Because why are we doing it? Now, remember, as I told you again, we are working in the incremental model of a software development. We keep changing the software code which is written. Means what I wrote yesterday may not be the same tomorrow. I might add something, I might delete something. So technically, we need to understand the changes we are making to the software over a period of time. So this versioning, right? The numbering that whatever I'm trying to do, it basically that helps to track the changes happening, right? Happening to a software or a code over the period of time. Means technically every day there is a change. Every day I'm tracking it. So that is a simple idea you need to keep in the mind. So that's what is the purpose of the version. As simply it is to track the changes that you're doing to a software every day. Simple as that, right? Now version is simple definition. Now you understood. Now the question here is that we're saying that the versioning is helping me to track the changes, but how do I track the changes? Or say in a way how a developer, and if you're not a developer, don't worry again, how a developer would track these changes every day, right? How he make a note of it. He made a line change in a file that he has to remember it after a month. So how he track that? He needs to, or he or she needs to write it on a notepad and say that something. No, right? Every day they might be checking, developers might be making n number of changes onto the files where the code is written. Now they can't keep track of every change, right? How do they track it? How do they have to note down on a separate file? Hey, I made this line change today at this time, blah blah. Not that possible, right? For a developer. So that's where we talk about something called they need the help of a tool, right? Some tool that help them to track the changes. So that is where we say that developers will use, right? Or developers will track these changes using version control tool, or you may call it as a version control software again. This is what all we are talking about it. So what is the meaning of, let's say, difference between a version 4.0, 4.1 and 5.0? You need to diff the changes, right? In 4.0, there might be certain files I've modified. 4.1, I might have modified some other files. I might have added new files. 5.0, I might have added some more files, some more changes have done to the files, right? The code is written in a file. Whenever you're making a change on a file, you update a file, you delete a file, you add some new files. What is added, what is deleted, we need to know. That's all we're talking about it. So depends on the change. We can have major, minor, patch, that we'll talk again, but this is the simple idea. Okay, so how a developer is gonna track all these changes, if you ask me simply, and that's where the version control tools comes into the picture, right? Again, I'm saying that these are nothing but your version control system. In short, people may call it as a VCS. Now, these are also called as your source code management tools. management tools technically. Understand here, team, there are different names that may be given by the people. In short, we like the short words always. So technically, the version control system or the source code management tool or source code management, they are one in the same thing. Now, what are these tools? Was do basically helps developer to track changes made to every file or a code, you may call it, right? So that's what you see it. Now, the second thing that helps developer to look at the history, which means so far from the last 1 month, how many changes I made it, when I made what change. All those things are being tracked by the tool. Developer can look back into the history and go particular position and then check it what was done at that point of time, right? They help us look at the history. That is the main thing. And we can also think about it, not only helping us look at the history, but we can also roll back if you want, right? Or it's nothing but your reward changes. Whatever the change I made it, I want to delete it, maybe revert back to a previous version. Then I can easily do that with your tools. All right. If I have to do it manually, open a file and delete 10,000 lines in it, might be a difficult task. If I have the tool to do it, maybe in a snap second, we can do that as well. So that's the main advantage, team, you need to understand here. The version control tools that helps the developers to track the changes they are making to a software development code every day, right? That is, again, these tools are used mostly by the developers. As I said, as a DevOps engineer, you need to have an idea of end-to-end process. So that's wherein we are trying to understand how a developer is working today, right? And remember, here we are not going to learn the development of a software, but rather we're trying to understand the tools used by the developer and then how he is tracking the software code and where he will track it. Basically, these things are necessary to know if you are going to be a DevOps engineer, which is as apart from a developer role. Good then. So let's say that we will talk about now something called version control tools or softwares. When I say tool, team, I consider it as a software here, right? Now, if you talk about any category, team, you might find some different vendors, right? For doing the same job. Technically, I'll say that. Means if I take a car is a car at the end of the day, right? But the same car is provided by the different people and different vendors with different features with it. Now we talk about the version control software, version control tool. So there are different types of version control tools offered by the different vendors. Again, we may use different tools accordingly. Now, when we talk about the version control tool types, team, mainly the categorization, we talk about it. So we have something called a local VCS tools. I'll explain them. Example, the type of local version control software is called SCCS, which is called source code control system. Again, SCCS meaning is that it's a source code control system. That's it. Now, the second category we have is called centralized, right, version control tools, right? Now, the examples of these tools you might have heard mainly, that is called like SVN or maybe TFS or CVS, etc. You have multiple vendors again who's providing the centralized version control software for us. Now, the third category, that is the one which we use in the current market mostly, which is called as the distributed, right, version control tool or tools technically. Now, the examples here, this is where you might come across something called as the GitHub or say Bitbucket or let's say GitLab, etc., etc. Right? Now, these are falling under the distributed architecture. Remember, each tool has a different type of architectures followed it by them. So this is what the idea about what are these things basically, right? Now, I just told you what are these tool names only, team, but how do they actually work? What is the meaning of local? What is the meaning of your centralized? What is the meaning of distributed architecture is what we need to be more clear about. So let's talk about them. Anything before I go to the local VCS tool? What do you mean by local VCS? Now, technically team understand that every developer uses a laptop or maybe a desktop to write some code, right? Because without a laptop or a computer, developers cannot develop a software usually. Now, assuming that in an organization, right, in any software company, whoever joins it, right, they always have given a laptops. So say this is my developer one laptop, right? Consider that way. And say that similarly a developer two laptop and so on, right? So this is the simple idea. Now, when I say a laptop team, technically it must have an operating system on it, right? It can be Windows or maybe OS X, usually the desktop versions we use it, Mac or Windows. So let's say that this is what every developer has the same thing. Now, when I say a local version control software, which means it is local to the developer laptop, right? In a way, what we are trying to say is that every developer would have to install a software in their laptops. That's called a local VCS tool, right? The example is here SCCS, right? The software name is SCCS. That's called your local VCS tool. So here, technically, that every developer has to install on their local machines itself. If they have to install such tool in their local machine, that's called a local VCS. Now, the purpose they're installing this tool on their laptops is to track the changes they make to the files every day. Means remember that every developer would work on a project, right? Say project X or something. Some project they're working on it. Remember, you don't split all the files across your computer, right? If you're working on a project, you place them into a single folder. Assume the project X is just a folder here. Now, under the folder, you start writing the code as files. The file one, it can be any programming language, doesn't matter for me, right? Now, initially when you create it and save it, say it is saving that as a version one. Now, tomorrow you modify the same file one more time, it becomes version 2 of the file, then so on, right? Every time you edit the file, that becomes a new version for that file. That is how the systems will track it technically. So every file will have its own versioning maintained by the software. How it is done, we'll do it practically. Don't get to it right now. Understand that the purpose of this software is to track the change happening on every file under the project X folder. That is the main purpose of this tool, right? So they have to technically, or every developer will do the same thing in their local machines. Assuming that they might be working on a different project, maybe the same project as well here in this scenario we're talking. So we understood that this is the idea. Now, what are the challenges with a local VCS basically, right? What is the challenge? The first challenge, which I would say, is that the version control is done. A version database is maintained, version history is maintained, is done only on local dev machine, developer machine. I mean to say that it's there on the developer machine. Then what's the problem here, right? What's the problem here? We can lose all version tracking when the developer machine. What happens if the developer machine is crashed? Machine or a laptop crashes. Can I recover it from somewhere? Until unless he might have had some other backups, there's no possibility, right or not? The one thing, there is a high possibility that the system may crash sometimes, right? And then we can lose the data on my hard disk. Definitely there is a possibility of that. That is one challenge we can look into. Now, the second thing is that the collaboration. Now, what do you mean by collaboration? So between multiple developer is not possible. Now, what do we mean by collaboration between the developers is not possible? Now, based on the scenario team here, both are working on the same project called project X. Now, let's say the developer one is working on feature one, developer two is working on the feature two. They wrote the code independently, right? Without knowing what's happening on the side, definitely. They tracked the versions of each feature independently. Now, when I have to release the software, I have to merge the code from both developers. Yes. Should I take the code from both developers and then only I can release the whole software with feature one and feature two? I don't know. That's not needed, right? Now, when I merge the code from both people, what version it is again? How do I track the version when I merge the code files from different people? How would I merge it? That's the biggest problem here, right? So the code or the collaboration between the developers is highly impossible, right? All of them have to do some approach then. If you are a single developer, then absolutely fine. But if you have multiple developers from the same project, then it's going to be very difficult for tracking changes again. That's the kind of challenges you get it. You might see it when you work with a local only version control server, a version control software, basically. Right. Initially, yes, when we started with the IT industry, everybody is evolving it. We invented and then we understood challenges. Then later we fix them. That is the main idea. So this is about the local VCS and its challenges. How do you understand and how do you look into it? So any questions on the local VCS here? Now, to address the challenges we found with this architecture or software model, basically, then we introduced a new thing. What's that? It's basically the centralized architecture. Centralized architecture, VCS, basically. Now, what do you mean by centralized architecture? You may call version control or a source code control system. They're both in one same thing, more or less. Now, when we talk about the centralized architecture team here, all we're talking is that we have a remote server, right? Consider that I have a server which is remote. Now, what do you mean by remote? Remote server. In current scenario, do we implement local VS in a project? In the current situations, no, we don't. We do have something like that. Copy of the code more than one place, globally situated, right? Absolutely. Now, in a simple nutshell team again, we maintain a remote server that is not part of your developer machine for sure, right? Now, of course, we still have the developers who will be connecting to a remote server. So think about the simple architecture like your Google Drive, right? Everybody is able to access the Google Drive, which I gave it to you, right? That is something central, right? Everyone is looking at one storage, one remote server where the data is stored, first of all. Now that's what is your remote server. So technically here, again, remember it's a computer, somewhere it is hosted, right? It can be say Windows or Linux, again, whatever it is, you have it. Now this is where we install the version control software, right? Say that we will install the VCS tool or a software. The example of that, you can install either of it, either SVN or TFS or CFS, CVS, etc. Now I'm saying not all of them to be running on the same server here. They have to be in one of them, right? Either you choose SVN or TFS or CVS, one thing, and then you install it. That's on the remote server. Now, once that is installed on the remote server, say again, you will still have the project created, right? A directory again, wherein you have the files with their versioning, right? V2 and so on, file 2 with V1, V2, V3, etc. Right? Now, the idea here is that all the developers, if you talk that, okay, this is my developer 1 again, or this is my developer 2, all we need to say that developers now need to connect to this remotely, which means that over a network, they will connect to the remote server, right? And say that they get the data to the local. They can get the files to the local, they check out the files to the local, you call it. Only the files, say that file 1, file 2, etc. Remember, in this scenario, the version history of that file or the actual version changes of that file is not going to be available on the developer machines. They might have the files, right? The same file is available in their local machine. They may download it. They can keep it, a copy of it. They edit the file locally, not in the local developer machine here. That's the idea, right? The local developer machine, there is no version for that file. All they do, they check out the files, they modify the file, right? And once they modify the file, they upload it, right? They push it back to the remote technically, right? Push in the sense you just upload it. right? They upload it. Now, when you upload it to a remote server, say I have modified, the developer one had modified the file one. Now, when you update the change, the remote server recognizes the change made. Now it creates a new version for that particular file as v3 something and records it for you. That is a simple idea. Until you push it, the change will not be happening. Now, if the developer one needs, or say the developer two needs the latest change made by the developer one, he can say simply the pull. Download option, again, we call it pull. Pull error nothing but equal to a download, basically. That is how it works, right? So the developers will keep, modify, update the code on the local. They push it. When you push to the remote server is what responsible for tracking the change, right? And then creating the history for that change, version history for the change in the server itself. That is a simple idea. Okay, so that's how you understand a centralized architecture technically here. Now, one thing here, I mean, not one thing here. So to understand what exactly is the, solution we're talking. Now, first thing is that here, the challenge we had with the, if you talk about the version control, right, is done only on remote server. Just like in the local, it was only on the developer machine. Now, all the version database, version history of each and every file is maintained only on the remote server, right? So everything is there on the remote server itself, completely maintained there. Now, one challenge that we addressed with this architecture is collaboration problem, right? Collaboration problem is, right, solved here, which means that now developers are updating their code into one central repository. Now all the files are being tracked there. So I have all the code from both developers. Feature 1, feature 2 is updated at one centralized place, one central server, a remote server, where all the versioning is done for each and every file. So I have a clear picture, right? Then I can simply take the code, what is on the remote server given by the developers, all developers, and I can go and release it. Merging all things are done on the remote server itself, right? So remember again, the version control is done only on the remote server here. No version database, no version history on the developer machines. The second point is that the collaboration problem is solved with this approach. Whatever the collaboration problem we had with the local is completely addressed here. Now, what is a challenge again we have with this kind of architecture? The version control in this architecture is very great. It was working good. But what can be the challenge again here? If you lose that, if we lose the remote server, right, then we still have a choice. We still have a chance, right, to lose all the version title, version history, right or not? Now, until unless if you have the backups of your remote server, you can recover from a backup. On a big bad day, say that I lost my server and I lost my all backups, then you're still gone, right? That is the possibility available for you. Okay. The one thing is that again, the remote server can be lost. The version history maintained on the remote server can be lost if you do not have backups. If you had a backup but you're also having the backups lost, then I can't help it. So everything is lost. That is still a choice, a possibility we have it. Now, is there any other challenge we see here apart from the remote server being lost? Anybody would like to say it quickly? Any other challenge apart from the remote server being lost? Comparing two versions in dev machine, push-pull. What is a push-pull challenge here? We can push, we can pull. We have the same name. The conflicts you're talking about, it's there everywhere. There is a possibility of conflicts if you are updating the same files. Absolutely correct. Conflicts can occur. There's nothing that I can avoid about it. So I have to look into a conflict and I have to resolve it by myself again. Any other challenge, generalized challenge, not about the code. So if you understand team here, if I say that developers are dependent on network to make a version change, right? To create a version, to make a version change to that file, recorded basically on the server, they're dependent on the network. Now, while I'm pushing it, what if the network is not available? Can I push the change? Yes, team. What do you think? Can I push that? Definitely not. Not possible. Until that is pushed out, until that is pushed to the remote server, developer may not be able to continue because before he give that, he can't work on some other changes there. So he's completely dependent on the network sometimes, right? Nowadays, you're getting the very good speed network team, but think about 20 years back. What is the network speeds we had it? I know they are simple files again, but think the idea of how faster network we had 20 years back, right? Because we are evolving with every tool technology here. Nowadays, you get a very good speeds, right? Also can't get list, can't get it, can't push it. Both the same, right? Saving changes is not possible. Getting the latest changes is not possible, right? All those are challenges. So completely dependent on the network situation here, right? If the network is not there, developers' productivity is gone because until the network become available, they wait. So you're losing time. That will in a way impact your delivery time as well. So all those things are cascading effects. We can say that, right? Something or the other way, it is going to affect you in the whole delivery of the software itself. So that is the idea, right? So yes, we had this challenge with centralized architecture. It is working great. It works really great. If you're already working with it, I can say that. But these challenges also needs to be addressed. Now that's where we introduced the last one that is widely used in the current market. I will say that 95% of the industry right now is using the last architecture, which we are discussing right now. The last one is nothing but your distributed version control softwares, right? Now, what do you mean by a distributed here? Say, distributed version control system. So now, what is distributed? So I call this is a hybrid model, right? Now, what is hybrid model? You know that, right? Decentralized, we can say that, of course. So the hybrid model theme here, if you talk about in general, which offers multiple solutions in one piece, right? So technically, we can say that it is the combination of your local VCS plus the central VCS, basically. That is how you understand. The centralized server, a remote server, is always necessary for us to collaborate or for the collaboration purposes between the multiple developers. That's the idea. You can't skip the remote server, but at the same time, developers should also have a flexibility to not dependent on the remote server. That's where they need a local, right? So that's the kind of solution given by the hybrid architecture or a distributed architecture, we call it. Remember here, we're still going to have a remote server for sure. The remote server is still necessary and mandatory. So I'll say the remote server. So as simple as it again here, you might have an operating system with something like Windows or Linux. And on top of it, we will install what? Install either GitHub or Bitbucket or say GitLab, whatever you want it, right? Remember, the remote server is basically something that is bigger, which offers kind of a UI mechanism to see, organize the things on a UI, basically. That's the idea. Now, first thing is that basically you take a remote server, you install the tool like the GitHub, Bitbucket, GitLab, such as anything which is a distributed architecture version control software that we install on the remote server, right? Now here you can create the version again, means that the project X to be created, like each files, and their version is maintained here, right? File 2, V1, V2, V3. Now this is very straightforward so far, like the regular centralized only, right? Now in this scenario as well, the developers still need to connect to the remote servers, right? Say here, I'll go. So think about it. Again, the multiple developers will be contributing towards the same remote server into a single repository or a single project. Think about it, right? Let's say this is your developer 1 and this is your developer 2, right? Now here, understand it on their local, right? OS can be Windows or say OS X maybe mostly, right? Now, in this scenario team, the developer need to install a tool called a local VCS tool. Install a local VCS tool which is called as your Git client software, right? Understand here. This is very much important here. In a distributed architecture, the developers would install a client software on every developer machine. The Git client software must exist. Now, this Git client software here is going to act as your local version control tool that helps the developer to make versioning of the changes in the local server itself, again, local to the developer machine itself, right? So what I mean to say here again, the developers can pull the changes, get the changes from the remote server, but this time, along with the file, you also get the version history of that file maintained in the developer machines, right? In the centralized architecture, you do not see the version database, the version history of each file in their laptops. But when it comes to the distributed architecture, version control, wherein you have a local Git client software, we call it, that is the one which is called a local version control tool, which offers or which helps developers to track change locally, maintain every version locally, create every version locally in their laptop itself, right? That is the main change that you see from centralized to the distributed architecture. Let's say that here we talk version tracking is recorded, right? Recorded or maintained, you may call it, or done on remote server and also on every developer laptop. That is the main thing you need to understand. Okay. Now here in this scenario, how a developer will do the changes. Remember, the developer may change locally or on local instance their laptop, and create a version in local laptop itself, right? That's what you see it, laptop, and then push to remote server when required, right? That is what you do it, or need to be shared with others technically. That's how you need to look into it. The idea here is that, say the developer one is modifying a file called as file one on his machine. He create a version of it in his local itself, right? He don't need to depend on the remote server to create a version for that file and record that in the local itself completely. And if he needs to change or share this code with anybody, he will go ahead and then push the changes, which means upload, right? Now, when you upload it, whatever is done in the local gets updated here. Remember, remote server is not creating a version, rather updating whatever is in the local there directly. That is a simple idea. Okay. Now, this is how you understand it. Now, if the developer one gets the change or needs the change, he will pull it, right? When he pull, he get all the change. These are the three different things that you need to know when you're working with remote. Simple. Okay. And we also understood about how do I update changes to the remote server as well. This is the simple idea.
Just a quick info, guys. Intellipaat offers AWS DevOps certification training course. Through this course, you will learn EC2, EBS, Elastic Beanstalk, Lambda, Jenkins, Puppet, and more from the top 1% of industry experts around the world. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take the first step towards career growth in the field of AWS DevOps.
I think you're probably doing the same thing. This is assuming that this is one of the server or a laptop where a developer one may be working on it. And that's what you see on my command line on the left side, which is the Ubuntu machine. Now, the right side is my local laptop terminal, which is like your, if you're using a Windows machine, think about it's like a partial terminal, you have it, right? Or if you're using a Mac, then it could be like your Mac terminal. You can see my name and my laptop name here on the right side. So think about these are the two different computers, right? Where you're accessing the two different terminals. The left side is developer one, the right side is developer two, right? I think both has the same project, like so the project X is what the developer one is working. Both developers are working on the same project. I think we got the project here under the Git repos and say project X. Okay. So assume that the developer 1 on the left, developer 2 on the right. I'm just showing you the scenario here, the two different computers working on the same project like project X, right? So that is what the idea is. So technically, if I really want to get some changes, remember the project is on the GitHub for us. Where is this? Did I? Okay, maybe so. Okay, let's go here and then check it. Right. Under the Nareshwar T account, the project X, right? This is the project. So this is a project that we have on the remote now where every developer will contribute, which means both developers working on their individual laptops, they will be pushing the changes to the remote. And if there is any change available on the GitHub pushed by some other developer, they have to pull it to their local, right? It's simple as that. Maybe if the third developer is updating here, something in the GitHub repo, assuming that the developer 1 can pull it by simply running a command called git pull origin main. We talk about the main, which is a branch basically. Now you can see the response that it says, okay, already up to date, which means it says whatever is there on the GitHub is already available in your project X folder. There is no differences in it, right? That is how you understand. Even if the developer 2 does the same thing for it, say git pull origin main. Now for him also, it would say that, hey, it's already up to date. That is what the simple idea that you can see it, right? Which means both developers and the remote has exactly the same content. Any developer would change something on their local and push it. Now other developer has to get that change, the pull operation. Now assuming that the developer 1, say in his local, he is creating a new file called today.java something, right? And he says that, hi there, welcome back. Some code, assuming that he write. Now he's saving the file, assuming that, he has the file now called today.java. Now which Git needs to understand it and then create a record for it. For that, in the local, we do something called git add dot changes in the current directory. If I check the status, you will see that it says new file. Now this can be created as a commit. Say that today. As I said, developer 1 is now making a change in his local as usual, right? He comes to the daily work and then he starts working on his local, like where he's creating some files and code writing maybe. Now, whenever he's done with his work, say he will add the change, letting the Git know what changes he made it. And he's also doing a commit. The commit in the sense, Git will create a record for the change made by the developer into the system so that it can be referred later. And that is what I'm trying to do. That says git commit. Okay, the new commit has been created basically, which is like I can validate using a command called git log. If I hit a log, now you see today, which is Saturday, March 1st. Now remember that Sunday, Feb 23rd, we made some changes. That's the date and time frame you can see. And today there is a new change committed by the developer here. Now what he's done is that he made a change in the local. Now he needs to share his code to the developer. What he needs to do here basically is that he needs to go ahead and then put it to the remote. Git push origin main, which means I'm saying that, hey, push to the origin. Now what is origin here? How do I check what is origin? If I say git remote -v, like we configured last week, if you remember, right? You see, when I say origin, you're actually pointing out to this project on the remote, right? Remote server URL, basically, where you're trying to upload your changes. Remember, origin is just an alias name for your remote server address here, right? That's what I'm saying. Every time I can't type this big URL into my command, so I just made an alias name called origin. That is what are we trying to do it. And say main is a branch again. So technically this is what it is. So git push origin main. Now I need to enter the username, so which is say lead DevOps, and the token, remember, I'm sure I should have it here. Probably I think I lost the token team. Maybe Remember, if I lost the token, I would have to go and recreate it because I can't get the same token again. Let me check if I close that maybe. Yeah. Sorry, team, I have lost it. I have stored just into the Visual Studio Code. When I reboot it, I think it's gone. You can't have multiple aliases. There can be only one alias. Okay. So let me recreate the access token using which I can push my changes. Without that, I can't push my changes. Remember, that's what we're trying to do. So I'll go to my account settings to generate the token one more time. So go to the settings. And on the left, you can see the developer settings option. Now on the left side, you see the personal access token and say token classic, right? Now, this is what we have done. Okay, this is a different account team. So I think I need to log out of this account. This is my other account. So let me log in within a Nareshwati account again. I'm just entering my auth code team. 1, 2, 3, 5. Done. So this is the other account, which is the project X where I'm logging in right now. Let's say I'll go to the account settings again. Okay, so here it is, the iPad, the Feb22 token that we create. So what I'll do, I'll not delete this, but rather I'll generate a new token for it, regenerate the token, right? And regenerate it. Okay, this is my new token with the same kind of credential. So what I'll do, I'll make a note of it again here. Sorry. Okay, I've done. Now what we can do is that once we have done that technically, right? Now this is where we need to push the change, right? So here on my command line, I'll just paste the token. That should go ahead and publish the change, right? I can see that whatever the change we made today, which is the today.java file, which is along with its code and the commit, is now being pushed into the remote successfully here. This is what you can see. It says it successfully did. Now what I can do, I can quickly validate here on the remote, right? Now you can see that the today.java is just now created and is available on my GitHub, right? That is what we did. So which means that here, scenario again, the developer one made some change today, then he also uploaded his change, pushed his change to the remote server. Now that's what is actually missing on your developer 2 machine on the right side. So what is missing in developer 2 machine right now here? The file called today.java. That is what all is missing it basically. Now how he gets it from the remote to the local, the operation he needs to do is that now do a git pull. So git pull origin main. The same thing he will try to do. Then the file would come from the remote and update into the local developer machine. That you can see it says successfully added the today.java here. That is what the idea, right? So if I look into it, now you got the today.java here successfully pulled in. So technically, we're trying to push to the remote, and then the other people will pull the changes as necessary whenever they want it. This is a regular operations done by the developers. Push, pull, right? Upload, download. That is what all the developers will try to do as necessary. We were trying to do the git clone operation, if you remember, right? I was doing some other things. Now you see that. So we were cloning the project from the remote to the local. Then we went inside. Then we were performing a same thing. We downloaded everything from the git remote. That's what we did, right? And simple. So when I do a pull, it just pulls the changes now. That is what the idea. Okay. Yeah. As soon as you clone it, it comes to your local, and then go inside the project folder and start doing the pull operation or any changes to it accordingly again. That is the idea. What is a git push? What is a git pull? Right? All these things you have a clarity. And whatever I'm talking team, everything is available here as well if you look into it. Now this is what all we're trying to do it. Developer 1, developer 2, and then git pull, git clone, all these things. Okay. The next topic that I would like to talk, which is a simple one again on the GitHub itself. Not sure if you have heard about it. In front of your laptop and you created your account. Is that right? Okay. So if you have done, right? Now, if you're already logged in, then say that you open this URL in your browser. Forget about what you logged in, but open a new tab after you log into your GitHub account. Open a new tab, right, of your browser, and then put this URL inside your browser tab window. Hit it, right? Say in my case, say I'm opening another browser for your scenario. Say I'm opening a browser called Safari here. Other browser is this one. So here it is. Now I just open it. Okay, so now you see an option, right? Everybody might be seeing an option, something called a fork, right? If you see the code button in the green color, above that you might be seeing some options like security insights. Just above that you see something called notifications, and you see an option called a fork. Are you all seeing the option called fork? So you are seeing an option called fork on the screen after you open the project URL that I gave you, which is under my GitHub account, right? So you can click on the fork option, right? Again, if you haven't logged into your account, it will ask you to log in. So technically, so let's say that I log into my another account called Lead DevOps, right? Assuming that there's some other account, right? So let me put my MFA code. Okay. Again, this is my Nareshwar T account, right? Now, if I click on the fork after login, now if you haven't logged in, it will prompt you for a login actually. That's what happened just now. I logged into this with a different account called Lead DevOps, not Nareshwar, but Lead DevOps is opening a project of Nareshwar. Now I'll click on the fork here. Now this is what the page that you will be seeing it, remember. If this project name is already taken, you can say I'll just keep it as project XYZ something. Now you can see that the lead DevOps, now it says create a new fork. A fork is a copy of a repository. Forking a repository allows you to freely experiment with changes without affecting the original project. That is what the idea is, right? So when you're cloning or when you're forking, basically you just give any name that you wanted here. But remember, this is the project name that you will see under your account, not under the Nareshwar account mode. This is what you see. Now, if you go below, it says copy the main branch something. Now just simply click a create fork. Now what exactly happening here is that it is technically copying, right, whatever under my account, my project, into your account as your project. That is what simply cloning it. Almost you took a fork copy of my entire project here, right? Now this option is called as forking team. Remember, this option is called as forking, and I believe that most of you are able to fork as well. Do I see? Yeah, I can see people forking. There are 9 people or 10 people who forked my project now. Now, do you understood what is a forking meaning here in a simple way? So how do you define the forking now? And remember team here, right? So there is something called a GitHub, right? Which is the remote server for us, github.com something, right? Now here under this, there is an account called Nareshwar T, right? He owns a project called Project X. Just for others understanding team, I'm telling it, remember. Now, whatever the code he has inside it, say files, right? F1, F2, whatever it is, F3, file 3, I'm saying it. And along with their commits, basically commit 1, commit 2, commit 3, something. Now, assuming that here, the Nareshwar is maintaining something called as an open source project or a public project, public data basically, then it can see what's inside the Nareshwar account project X basically. Now you have gone through that and then you liked it, right? What do you mean that here you have some useful information, right, to you, or it's kind of a project you might want to contribute towards to it. Now what you can do is that, remember, if you want to contribute towards this project, you may not be able to push your changes, whatever the code you write, directly into the Nareshwar account, right? That's where GitHub gives you an option called fork, right? Now, when you do a fork on the account of Nareshwar, the project, basically what happens, basically there is another account called as Lead DevOps in my case. and say that project XY. Now remember here, you can keep any name under your account as your choice. Now what simply happens basically, it copies all the code from the Nareshwar account into your account. Basically, that's what you just observed it technically, practically as well, right? Now this is called your forking. As it says that once you fork it, it's a copy in your account, so you can freely experiment with it anything without affecting the Nareshwar project or a code written by the Nareshwar here. Correct or not? Can I say that now? Since it is under your account, you may modify any file, you may delete a file, you can try doing anything, freely experiment whatever you want on the code taken from the Nareshwar. And then, yeah, if you're done with your changes, then you can propose your changes. That's a different case. But the understanding here is that technically, this is what all you're trying to do. So fork means that I'm trying to make you a concept understanding here called forking in Git. The fork is a concept, or a fork is something that allows you to copy a project from someone else's account into your own account so that you can experiment on that particular project if you wish to, if you would like to. That is a simple idea. Okay. The forked copy here, say this is under the lead DevOps account. Understand the concept, team. Remember, now this guy is a lead DevOps. Now he is getting this one. Cloning is something from remote to the local laptops, right? Forking is within the GitHub, within the remote server, forking, right? If you want to get something from a remote server from GitHub to your laptop, you need to do the clone. Okay. The difference is that the forking is only on the GitHub, which is in your browser itself, somewhere you can say. And cloning is something from GitHub to your local laptop that you can do it. That is the difference in the clone and the fork. Now, keeping that aside, right? Now, assuming that the lead DevOps, the other guy who took my project, he started adding the code. Now, remember, he can clone to the local, he can make the changes and he can start pushing it. That's absolutely okay. But say that I'm just adding the file on the GitHub team. Say there is a button called plus here beside to this code button. There is a plus button, you see it. Now let's say the lead DevOps is adding a new file, right? Let's say that the file name is lead DevOps.java or something. He develops some code, lead DevOps code here, something, right? And say that once he write whatever he wants it technically, let's say he will go and commit the change. Commit in the sense, say commit. So here it is. Assuming that the lead DevOps, the other guy who took a copy, he is actually going and making a change to the repo on his account. Remember, that's what you do it. Okay. Now here, let's say that there is a new file came up here. That is good. Now, which means that remember the lead DevOps has made some change in his account, which is not going to affect the Nareshwar project here. Now see that does Nareshwar has the lead DevOps.java here? Yes, team. Does lead DevOps has Nareshwar has a lead DevOps here? The lead DevOps has that. Now the lead DevOps wants to contribute the changes he made to the original project, which is the Nareshwar. What he needs to do here, what he needs to do is that he can't push Bhavani. The pushing, he made a commit already. Remember, when I created a file, the commit is already happened. You say that this branch or this is one commit ahead of the Nareshwar T project X main, right? Since he made the change on the GitHub directly, right, it is directly committed. Like there was a button which I looked at, it's called a commit, right? I did a commit already on the GitHub, assuming that the lead DevOps can push from the local as well. But understand that we just committed directly, made a change as well as committed. If you want me to do it one more time here, there is no pushing here, okay? Because I'm making a change directly on the GitHub. If you make a change in your local laptops or your systems, then you need to push from your laptop to the GitHub. Since I'm making a change directly on the GitHub here, right? So GitHub, which is a lead DevOps project X account, if I look into it, now the option here we have is like you can edit a file. Say I'll open it to .java, right? And there is an edit pen button you see here, right? Edit this file or something. If I click on edit, it will open up the editor for me directly on the GitHub itself. So which is not local. Now, after you're making a change, remember that as you add and commit, then push, right? Here, I'm directly making a change in the GitHub. There is no meaning of push again because it's already there on the GitHub. But the only thing is that add and commit. Now that is what happens when I click on this commit changes button here. So I'm editing a file called 2.java. I enter my text here, something, whatever it is. Then I do a click on commit changes. If I click on commit changes, it says that, okay, I'll commit with a commit message, something, and whatever you want, right? Commit directly to the main branch, something. So commit it. Now we already committing in the GitHub here. Now, since the change is already on the GitHub, do I need to push again? The changes are directly made on the GitHub. Is there a meaning of pushing again here? No, that is what I was saying. Now, the understanding here is that the changes were done on the lead DevOps account. The other guy who took a copy of my project makes some changes, right? That is what he did. Now, once he did with that change, now he need to publish or he needs to give those changes to the Nareshwar. How he can give it, right? Now, this is where team, this is called lead DevOps wants to contribute to the Nareshwar project basically. So he needs to give whatever the changes he made in his account to Nareshwar account now. Remember, the changes needs to go from lead DevOps account into Nareshwar account, right? So can lead DevOps push changes directly to Nareshwar T? Is that allowed? Can you all push changes to my account? Is that allowed? Should I allow it? No, right? It's that individual accounts are secured with your own password, usernames, everything. So technically, nobody should be able to push to your account. Similarly, the lead DevOps can never push directly to the Nareshwar account, but he made changes in his local, right? Now that is where the GitHub gives us an option here, right? GitHub is giving an option that, hey, lead DevOps, you can contribute your changes to Nareshwar by raising a request to him, right? It's not a direct push. You need to request the Nareshwar, hey, I made these changes. Please accept my changes. Understanding the point here? Since he's not directly allowed to push to him, he needs to request, hey, Naresh, I made these changes. Please review it. And if you're okay, please add the changes to your project. Now, this is what we call it as a pull request. Remember, on the GitHub, if you observe, there are many options, right? Under the lead DevOps project XYZ, you see multiple options like code, pull request, actions, projects, wiki, security, blah, blah. Now, one point we are interested in here is that called a pull request. Now, what are we trying to do? We are asking Nareshwar to pull the changes. We are not pushing it, but we are gonna request Nareshwar, hey Naresh, I made these changes. Try to review them and pull them into your account so that you get the latest changes I made. That is what the meaning. So the concept here is called a pull request. So I'll click on a pull request here, right? I just click on the pull request tab. Now you see something. There is an option called as a new pull request under the lead DevOps. Remember, lead DevOps is requesting or is going to request Nareshwar to pull the changes. That's why it is called a pull request. So I click on the new pull request. Now here it will show you clearly that you see this, right? On the left side, the base repository says Nareshwar T Project X. Now to whom you are actually raising a request, I can raise to many people, right? Ankita or Joy or Akhilesh or whatever it is I can. So whoever is on the GitHub, I can raise it. So technically I'm going to raise a request to the Nareshwar from where, which is from the lead DevOps account, which is this one, right? So once I see everything is doing it here, now these are the changes I'm proposing it. The commit IDs, the lead DevOps made it, the files he changed, everything is it. Simply create a pull request. Okay. Give a title. Okay. New landing page changes something. I'm just giving some random data here. That's it. Whatever it is you did. And then say below you have an option called a create a pull request. Now remember, lead DevOps can only create a pull request, right? He's going to make a request to the Nareshwar saying that I've done these changes. You can review it and then pull into your account basically. So now the lead DevOps job is done, right? If I go back to the Nareshwar, which is on the Chrome, right, on the same project X. Now you see the pull request here, it does not show anything. But if I refresh the browser here now, right, you see that the pull request, there's somebody else is also raising it. So there are 2 pull requests is appearing here. If I click on a pull request, let's say I've done this one, new landing pages. I think Ranganath did one, a lead DevOps did one. Now remember, it is just the review process. It's not merged yet. It's not actually pulled into the account. You can still don't see the changes of lead DevOps, like lead or job something, right? Now what Naresh will do is that he will review one by one. Whoever is requesting it, he will go one by one. Say, I'll click on the request. I'll see the commits. I'll see the files changed, the code changed, everything I can see it, right? Now, once I'm done with this, if I'm happy with all the things, basically, the conversation page, if I come down, there is an option called as merge pull request. Merging in the sense I'm adding the changes into my account now. Nareshwar is accepting changes and merging into, pulling into his account. So I'll say merge, confirm the merge, simple, right? Now this is how Nareshwar reviews the changes and then you can start doing it. Now you see the lead DevOps.java file is now present under the Nareshwar's project Excel. That is how you do a change basically. Okay. So just to give you the clarity on that point again. Okay. How do I close this? Okay. Now, just to give you the clarity on that, basically, let's say that now we had initially the Nareshwar T has a project X, right? Now, what did the lead DevOps guy? Fork did by the lead DevOps. So it becomes the lead DevOps project X, right? Project XYZ is something. Now, let's say that the lead DevOps added changes in his account itself. That is what it. That is what it, right? Or pushed or pulled or whatever it did, he added some changes into it. Then what happened here? Lead DevOps will need to request, which is the pull request for me, right? Request Nareshwar to pull changes. That is what the meaning of it, right? He will raise a request, right? Lead DevOps will need to request or raise a request. That is what they do, right? A raise request, that is pull request, to Nareshwar to pull the changes. That is what. Now, Nareshwar, right, will review and merge. Sorry. Nareshwar will review and add, nothing but merge changes to his account. That is the idea. That's how you can contribute towards any open source project that is available on the GitHub. Remember, team, there are many open source projects out there. The developers across the globe are really contributing towards the n number of open source projects by using this concept. So everybody takes a fork of the original project, develop something, add them to the account, and then contribute them, or let's say that you request the original guy basically. Okay. So that's the idea. I believe that I made it clear now what is called a pull request and what is a purpose of forking basically here. Okay. Able to understand the fork, take a copy, right, and then make some changes and then request back the original project to approve your changes. That is the idea. So forking is a copy from X account into Y account on github.com. Do you agree? Now, cloning. What is cloning basically? Cloning is a copy again from X account on github.com to a local computer. Right? You getting the point now? So when you want to get changes from your remote to the local, then you do a cloning basically. The first time when you have nothing on your laptop, you want to get something from the remote github.com to your laptop, your local computer, then you perform something called a clone. Now we are all clear with something called as forking in GitHub, and how do I raise a pull request as well. Now you also understood something called a pull request concept here, which is one of the important topic that every developer do every day in their job role. Okay. So again, if you're not knowing also, that's fine, but knowing it is always going to make you a good DevOps engineer to understand a few things. Right. So since we are clear now with the pull request as well as the forking, now what's the next topic we want to talk? So now let's start talking about something called branching. Now, what is branching, and why do we need a branching? Okay, the question is, what is branching in Git? Almost forking, but in local machine. Not exactly in local, that also happens in the remote, and then you, hey, within the project, you can say that. Within a single GitHub project, the remote project, you do the branching basically. The branching can be in the local project folder as well. Branching is restricted within a particular project, not between the two different accounts, two different projects again, right? So I have a GitHub. Now we'll discuss the reason why the branching is necessary or how the branching will help me. So think about it. You have something called as a GitHub. Basically, that's what we were seeing it, github.com. So there is a github.com basically. Now inside the github.com, there is maybe account, and then under the account, you have your code available. Say Nareshwar T is the owner of the project, and say that he has the project X, some project basically, right? It can be assumed that your my org repo something, right? My project something, my organization, and then under the organization, you have a project where you're contributing basically. Think about the scenario I'm saying it. Your organization is the owner of the project basically. Now inside it, remember, so far, whenever we create any repository team, either in the local of your laptop using a git init command, or either in the GitHub, which is by using the UI options you have it, you see something called a default branch, right? Now, if I do within my project folder in my local, say that git, right, branch command, which is local, right? Now you see the default branch named called main. That is what you see. Now, in any developer scenario, they will have the branch as a main. Think about it, it's just a pointer, or it's just kind of a subfolder inside your project folder where the code is written basically right now. That is how you keep it in mind. It's a very simple point. Now, the same thing is there on the remote as well. If you go to the github.com, right, under your project, now you see that there is a main again, right? You see here one branch basically you see. This beside this, go to search about this, you say click on branching. You see that there is something called a branches page. Now you see the default branch is main. Now where we were trying to push the code. So every Git repository always has one default branch mandatory. Without a branch, there is no Git repository. In fact, you can say that that's mandatory. So assume that the branch is like a subfolder under your project folder, wherein you saved all the code so far technically. That is what all happened. But again, this can be tedious as we go with the bigger project development, which means that assume that in my organization project, right, where I have the code, right, it says that there is a branch called main. Now, whatever the code that I saved here so far is the like commits. Remember, team, each commit referring to a multiple, changes happen so far. Now, this is what we are saying it. The code that you have done so far is saved under the main branch. The commits are referring here. Now, assuming that team, now think about it, when I want to release this code into the market, say version 1, think about I'm releasing my software into the market with a version number called version 1. Now, can I say that the version 1 of my software is a changes made by n number of developers and made n number of commits, which I mean to say again, C1, C2, C3 commits together, I call it as a single version for my software. A single commit cannot be the version 1, right? Can I call the each commit is a version 1, version 2, version 3 like that? No, right? It is not that how it looks like. Remember, each commit refers to the changes made to a files. Now, in a single version release, you might make n number of files changed. Is that a fact or not? When I release a single version into the market, there is a possibility that you might modify n number of files. You might add multiple files. You might delete some files as well. you might be making them as a multiple commits. So understand, in your Git repository, right, the multiple commits together will become one release for me, one version release for me in the market. That is how you understand it, right? So understand here the C1, C2, C3 is my version 1, right? Now, just to make you understand, team, here, how is this actually made in the GitHub again? Now, remember, so far we have multiple commits here. How many commits we have it here? Say there are hardly around 10 commits. I see it. Now, below the code button, you see something called 10 commits, right? The 10 commits means n number of files we added, multiple times we committed, something like that. Now, I want to make these 10 commits, or up till whatever the code I have done right now is going to be version 1 for me. So how do I make this version 1 release? How do I refer it as a version 1 in my GitHub? That's where there is a concept called releases comes into the picture, right? Now, do you see something called a releases on the right side, team? On the right side below this code button, you see some option called releases. Do you see everybody on my screen where I'm highlighting right now, right? Now, what is this releases? Basically, understand that once we develop certain code with all the changes necessarily done, and whenever we're ready to release the software into the market, or whenever you're ready to deploy it into a server, basically to point out the versioning, right? To make the versioning convenient for a human being, not for the systems, remember? For the computers are relying on the changes made is commits. But for a human being, can I rely on this commit ID as a version number for me? As a human being, is it easy for me to remember the commit ID as a versioning something? It's not that easy, right? That's where, for the human convenience, we created something called releases, right? So if I go click on this releases, basically, it says, okay, you create a new release here, right? Now I'll say create a new release. Now it says you put a tag. Now remember, we are going to put a tag as a v1.0.0.0 something. That is what you can do, right? So I'll say that this is my version 1.0.0 is my tag. Tag is just again alias name for your release. What I'll do, I'll create a new tag. Now it is easy for me like this. Now I'm targeting the main branch, means whatever the code available until now inside my main branch is my version 1.0.0 as I'm tagging it, right? And if you want to say generate release notes for it, based on your commits made, changes made, it gives you something called the release notes that, you might be releasing the release notes for a software, right? Something like that. Then I publish this release. Now, when I publish this release, now you see that technically this is my version 1.0.0. Now, if I go below, I can even download the source code of that version 1.0.0. Okay. This is the simple idea that how we actually start versioning in the GitHub after we have a certain changes for a particular version is done. Particular feature development is completed technically, right? Now you have version 1.0.0 released. I can download the code and then go for it. So the V1 here, understand that V1.0.0 code has the changes till the 10th commit. Remember, from the first commit in your repository till the 10th commit, which is this one, whatever it is, say, the last commit is something called merge pull request. And before that, we have multiple commits. From the first record till this particular record called merge pull request here, Git treats it as a version 1.0, right? In single version, there can be n number of commits will be there. Understand here again, from the bottom of repository up till this particular commit is my version 1.0.0. That is how it is pointed out. Okay. You can also make a particular commit. Say that I'll show you one more thing here. I want to create another release. Say that means I don't want to create that way, right? So I'll go and a new release. Basically, again, I do it. Draft new release. Now here, I want to say release a previous version, right? I want to mark it. So I'll say that v 0.5.0 means it is before the version 1.0.0. We have something called v0.5. But again, which commit it is? Target main, right? Sorry, first let's create this tag. Now, instead of creating a tag here, let's say that I point out to a commit. Say this is the latest commit. If I don't choose the latest commit, will be the one. But say that up till this commit ID, which is BD something, is my version 0.5, something like that. So we tag up till certain commits as a particular version, something like this. Okay, I do it. Then I say come. Okay, so publish the release. Right now, you see that technically under the releases page, we have multiple releases, right? I had a 0.5.0 first release, which is up till this particular commit, which you see on the left side. From the bottom, remember, from the first record in your Git repo, up till this commit ID is your 0.5.0. Now, after that, you see another commit here. From that 0 record again, the first record, till this one, which is 8B7E commit, which is the version 1.0.0. Now, this is how we keep recording in your GitHub so that it will be easy for me to understand what I released in which version of the software. That is how we make releases on the GitHub after every developer pushes their code into this one, right? Can we make versions in different branches? Yes, you can make it, as you see an option always, right? You can point out from a different branch as well. It doesn't need to be main. Right now you see the main here, but you can select another branch if it is available here. Okay. Right. So we haven't talked about branching yet. I'm just making you sure that understanding this release concept well, so that you can understand what gonna cook in the branching as well. So now you're clear with what is a release here. Understood like why I said C1, C2, C3 become a single version here. Everybody is clear, right? So every release, every version is basically a combination of multiple commits. Can we pull a different file to a release in main branch? Again, there are tactics for that, Indra. The answer is yes, you can do that. How a specific file can be pulled out, that you need to understand. That's it. In any software downloads you see a different version. This is how it is created and released into the market. Okay. So now you're clear with the versioning, right? How the versioning happens. Now, assuming that I say that now I've released this version 1 into the market, which means that the end customer, which is maybe a production server, something, right, where my V1 is running, right? Understand here, team, I'm saying that the version 1 is released into the market and end users are using the version 1. Like, for example, right now you say that you might be using the iOS 18.3.1, something like that. If you're on the iOS or iPhone devices, you are using 18.3.1 something. Or if you're on the Android, you might be using some other thing called 13 or 14 or something. That is what you see, right? That is the end user using thing. Now, once that version is released, did the Apple company stopping the development of iOS, or it's still continued with maybe new features pointed out for version 19 maybe? Correct or not? Still continues. The development still continue. In the next releases, Apple may be bringing you some new features that the customers may like it. Is that how the software development is going on? Like every 2 weeks, the incremental model development, we call it, right? So every 6 months, every 2 months, every 1 month, you might be getting some new features added to the existing one. So assume that the version 1 has XY features. We're going to have a new feature that will be developed and then released into the market maybe later. That's where I'm saying that I want to go and develop the features, right? And say this is one I'm targeting for a release in March 1st. Say we are targeting this release on March 15th, right? Release on March 15th. That is a deadline to release the feature Z to the end customer. That is what your client is requested. Now, there is one new feature we targeted for customers on March 15th that we can see that. So development need to be started on it. And say that meanwhile, there is a possibility that in the existing version, there can be some defects, right? So there can be some other feature you targeted, say feature A that is targeted for 30th March, maybe, right? Something you plan the releases accordingly as per your development going on. Now, let's say that like Apple is planning the version 19 of iOS in the next September, maybe something, right? Every year they get a new version. That's how you do it. Now, there is a possibility that in the existing version also there will be some defects, bugs will be there that also need to be fixed. But since the bugs and defects are affecting the live customers for me, we might have some urgency to it or the priority is different for it. So this is targeted for only 6th March, right? Which means the defect that is found in the V1 needs to be fixed and then released into the market again by 6th March itself. So remember team, this is how the development team is planning their releases technically, right? They have the sprint planning meeting and they discuss what all the requirement we have it. And then technically they start making the release plan accordingly. That is what happens. There are multiple features needs to be developed and defects in this one. There is a possibility that now the parallel development will start. The defect needs to be 6 March and feature Z. There's a possibility that you work on a different things here in parallel now. Defect needs to be started development, fixing code. The feature Z needs to be started development and then say that you need to start writing code and all that stuff. Is the parallel development starts now? High possibility that everything has to be done in parallel to meet the deadlines, to meet the release goals the development team has it. Now this is where, assuming that the overall strategy that we are working in right now, remember it is single project, right? That's how I'm looking at. Now every developer, assume that if multiple developers are working on the same project, this is how you see the multiple developers. So far with the ideology that you have, how you're working it, this is how it is, right? Connected to the remote and say that they got the same project into their local with the code they have it. Say that this is how the developer one has the code. Now all the code is available on the remote main branch itself, right? Think about it. The sequence may be different here and all that stuff. Okay. Which means that let's say that whenever they're pushing it, say developer might be pushing it differently, right? So say then it can be like F2, then the D2 came in. Like the sequence of the commits can be different. The developer one may be pushing first and feature code pushed it. Assume that that is how it is. All the code is there on the remote main branch. Now this is how it is shuffled as well for me on the commit history if you look into. Now assuming that the developer 2 said I testing in my local because he just took the only development of the version 1 and development code, defect code only. Assume that he completed testing in his local. He said I pushed everything there, but other developers also pushed it, right? Now can I take from the remote GitHub and then release into production the next version? I want, let's say that on 6th March, I want to release only the version 1 plus defect that says that it is going to be version 1.0.1. Can I do that? Yes, team. Can we do that? How can I mark a release basically in my GitHub having only the C1, C2, C3, D1 and D2? Is that possible for me? Since the order of the commits are different, remember, if I create a release on D2, it includes F1, F2 as well. If I create only D1 up till, then it has only a less code, right? Not complete defect code is available. Then how can I do it? Now, this is way team to allow some parallel development without affecting the code of different releases basically, right? This is where the actual concept comes into the picture. Okay. Technically, how can I make this is simpler and easier to look at it? Basically, for every developer can work without conflicting the other developers' work. Technically, we start creating branches. Now, what is a branch here? Remember, the branch is technically a copy of the main code you have it. So I'll say that I'll create a branch called feature Z, which means that technically I'm just copying whatever is in main and then doing it. Now I also create another copy called a defect, which also has the copy of C1, C2, C3. That is how you do it. Means you're taking, instead of disturbing the main copy now, since it is already released into the market, right? Technically, we ask developers to take the other copy now, instead of working on the main copy, hey, you work on the feature Z copy, which has the necessary code, what you needed prior to the one. And this guy has to take the defect copy, right? Say C1, C2, C3, something, right? This is how you see it. Now it is clear and very clean that both has a different sets now. Now what this guy can do, he can simply go and add the feature code. Of course, he can also develop his own code, something, D1, D2, something. But they upload it into their own copies here without impacting the without impacting the main copy, right? So let's say that this is where the copy is. Now here I have a clear picture that on the defect copy, I have only the master version 1 plus defect copy. So I can easily create a release of version 1.0.1 on March 6 and say that I can release into the market. Is that clear picture now that I have it? That from where I can go and release a version 1.0.0 or version 1.0.1 maybe. That is the simple idea. Now here the idea is that technically you can take the code from the defect and market release 1.0.1. But at the end of the day, we need to have one main copy maintained as well. So technically we can merge the code, which means whatever the code inside the defect branch, we can add it into the main copy as well. That's your choice. Like say that when I'm releasing it, when I want to release my defect code, I can go and add all the code in my defect branch into the main branch, main copy, and then make it release it, right? Now, when you start going for a release of feature Z, so let's say he will get an update from the main, it is moved ahead. So technically he'll test it. Then finally go and update the feature code as well into the main after the release of the feature. Then main looks like this, right? So F1, F2 something. So it's just that you need to add the code, get the code from different places to mark your final copy, to get your final version that you want to release into the market, right? So this is the understanding team. We're talking about why the branching is necessary. Branching makes a clear segregation of a code from developer to developer so that he can test it the way they want it. It also helps us to do the parallel development without affecting the other developers' code and make a easier, clean and releases into the market. This is very much important that we always work with in the real time. So just a quick understanding of why branching is necessary here. If you're clear with the theoretical part of it, then I'll get on to the practical. I'll show you how do we create branches, how do we get branches to the local, then how do I make all the changes basically. Okay. So the first thing, team, remember the branches can be created in remote GitHub, right? In GitHub directly. Recommended. I'll say that, right? Always we create on the GitHub, right? We can also create in your local project folder. Not recommended, right? That's what I can say that. So it's better that you always go on and create something in GitHub, then take that to the local, okay? Don't create in your local and push it to the remote because that can lead to a lot of confusion. That developer 1 may create with some other name, developer 2 create different names. The naming convention can go wrong, right? Maybe a duplication can happen from where they're taking copy, it doesn't understand. So it's kind of all a lot of confusion things will happen. So it is recommended that as part of your sprint plan, we know what is the next release, and based on the next release, that the GitHub, we create some specific branch based on the release names. Then let's say that the developer will take the copy of it and then technically go and work on it. Again, remember, I'll show you both. First, we'll work on the GitHub part, then we can go on show in the local as well accordingly. That's one by one we look at, okay? So we'll focus on the GitHub part first of all, so we can understand the real-time strategies, what we do. Okay, so now saying that I'm on my GitHub, right? On the GitHub here, right? Once we done understanding, so you can see the branches here. You can see there are multiple ways you can do. So you can see the drop down of main here, just below the project X name. Under that, you see the default branch called main, and there's also a text box here. You see it, find or create a branch, right? Now you can enter a name here, say defect something I do it, right? Just enter a name that you want to. Now, when you do that, below it gives you an option called create a defect from main, which means it is going to make whatever is in the main, creates a new branch called defect. That is how it works. So I'll create it. This is one approach of creating a branch in the remote. That is on the GitHub itself. The second thing, like you see on the defect branch I'm right now, but you can switch between the branch by just selecting it here. A simple idea of switch between the branches. The other way around is that you can also create a branch by going to the branches page. Just beside this drop down, you see the branch link, 2 branches available, right? Click on it. Now you do see that the branches page. On the top right, you see an option called a new branch. You can do like this as well. New branch, enter your branch name, feature Z something. Now you can source is a main branch again, which means I can take a copy of main and create a feature Z. So create it. The 2 different options that you saw right now. How do I create a branch on the GitHub? Okay. Now, if I go back to the project X, now you see under the drop down, there are 2 branches. One is the main, 3 altogether. One is a default main branch. One is a defect branch. One is the feature Z branch, basically. So this is how we create branches on the GitHub, which is recommended to do it, basically. Okay. Now, once we create a branch in the remote, now it's time for developers to get the changes. Right now, how a developer get the changes happen in the remote? How does developer get the changes happen in the remote to the local? I have some changes in the GitHub remote server. Now I need to get that. So yes, you can do a simple pull. So technically, let's say that I'll do a git pull origin. I'm not mentioning the branch this time. Remember earlier we were mentioning the branch. I'm not mentioning the branch. When I say origin, okay, give me all the changes, maybe on all the different branches on the remote to the local. That's all the meaning of it, right? Now you see that it is not only getting the branches stream. Remember, we also created some tags earlier. So it is also pulling the tags that you did it on the remote. So everything that is basically did on the remote now has come to your local. You can see that, right? That you see the different things. Now, if the developer 2 wants the same thing, you can also say that git pull origin something. He's also going to get that information to his local, basically. That's how you can see. Now, understanding is that by just pulling it, it won't create a branch locally. Say that, sorry. I do a git branch. You still see only the main branch in local, not the defect or not the features, you remember. The pull will fetch all that information, updates your local repository, which is .git. But if you still want to create the branch in the local, understand here, if you still want to create either a feature Z defect that points to the remote feature Z branches again, what you need to do is that I can do something called a git switch, right? And you need to mention the branch name, which is going to be, let's say I want a feature Z. Checkout or switch, one in same Bhavani. You can do a checkout or you can do a git switch. Both are exactly the same thing we are trying to do. Okay. Right. So now you can see that the git switch feature Z, right, says that a branch feature Z set up to track with the origin feature Z. Now you can say that it also says switch to a new branch called as feature Z, right? If I clear it and I do a git branch now you see that there is a new branch in your local called feature Z, right? Whatever the feature Z that you wrote. Now the same thing, the developer 2 on the right side, let's say he might be working on the defect. So he switched to the defect branch. First you do a git pull, then you start performing the git switch of the branch name that you created on the remote. Remember, it has to be exactly whatever the name you give it on the remote, you do the same thing in the local. Git switch of that name, so it will create the branch locally for you. This is something that you see now. The developer 2 has defect branch, developer 1 has a feature branch, right? That is how you do it. So once this is done, let's say that, assuming that I'm doing from the right side, the developer 2 working on the defect code, right? So for that, say he might be modifying some existing files, say now.java defect fixing here, something like that, assuming that he writes the code necessarily. Now, whatever the thing he did, say git add dot, right? He commit in the local git commit -m, say d1 something. He can also do some other changes. He might create a new file as well. Git add dot git commit -m, say d2, something like that. So Assuming that the developer 2 working on his own branch now on his laptop, right? He made some changes to the existing files. He might have added new files as well. Then he committed in the local, which is like 2 new commits he made, D1 and say D2, that is there. You can see that these 2 are the 2 new additional commits available. Now, what developer 2 can do is that he will start pushing the code. Say git push origin. Remember, this time he does not want to push to the main branch. Instead, he will be pushing into the defect branch. That is what is going to do it. So I'll say defect, something like that. You already did git switch, correct? Why the command prompt still shows project X? That's the project name. Within the project, you have the different branches, right? When you look at the git branch, you see the star mark point in the project. It is the same project which has 2 different branches, Bhavani. The project name does not change based on the branch you created, right? That is how I do it. Project X, inside the project X, we pointed to a defect branch itself. It does not show the branch name technically on the screen, always, right? It is always pointing out by the star mark here when you do a git branch. That depends on the tool to tool. Basically, since we are working on the command line, it might not be. If you're technically looking at the tools like git bash or something, that is depends on the UI tool you use it. Okay, it's nothing related to the git here. The designed basically the tool is designed in a way that whenever you switch, it will show you that name for you. That's it. It's not related to git. But what you need to do, you always check git branch and check the star mark is pointing to which branch. That's how it shows to you. Right, team. I think I need to push it, but says authentication data is storing somewhere, keychain access. I just need to remove my credentials here, the GitHub one. Do you see some GitHub? I missed it. Where did I miss it? Yeah, here, sorry. Yep. Okay, I'll delete this GitHub. Okay, delete it. Thank you. So now let me add it here again. Okay, it is prompting me, so I'll say that Nareshwar T and the token which I'm using it right now. Okay, now you see that it is actually posted successfully. Okay, now if I just check it on the GitHub, now let's say that here you see the defect had a recent pushes 10 seconds ago. It is clearly telling you that the defect branch has some new changes which is not there in your main branch, right? If I see it main here, remember team, there's no defect or Java at all. Now if I go to the defect here, now you see something related. So defect D1, D2 is, you can see it clearly, correct or not team? Which means that what happened just now is that basically the developer 2 made the changes on a defect branch in his local. He then pushed the changes to the remote defect branch as we discussed earlier. He was able to push it. The understanding here is that technically the defect, assuming that the defect development is completed, defect fixing is done. Now I would like to update whatever the changes in my defect branch into the main branch. How do I do that? Right? Understand here team again, whatever the changes, whatever the new changes we did added in the defect branch only, those changes need to be updated into the main branch again. Now that is where we have to again, it's like getting the data from one branch into another branch. That is also goes on the GitHub via a concept called pull request. Now since we are within the same account here, right? If I go to the pull request tab on the top, some other coming from a different account that I'm absolutely okay with it, but say I'll create a new pull request. Now here, now since I'm creating a pull request within the same project here, it shows me the different branch here. The base branch is main, and from which branch I wanted, say defect branch basically, right? Now I'm saying that, hey, whatever is in the defect branch, you go and update into the main. That's a pull request, right? So what I'll do, I'll create a pull request. That is very much important. You need to understand. So create a pull request. Now, once you create a pull request, again, somebody has to review it. It is necessary that, again, we can't corrupt the main code without validating what is being updated here, right? So a pull request allows us to review the changes by your senior developers. If there are certain mistakes, they can actually go back to the developer and ask them to make the necessary changes before you actually adding the changes to main, which is already a working copy, which should not be corrupted always, right? Kind of a review approval process done through your pull request concept always. So if I want to get that, so I'll open this request, peer review, that's right. Now I'll open that pull request raised by the defect branch developer. I'll review it as a senior developer, whatever it is basically. If I am actually liking it, then say that I'll merge it. If not, then I'll say that, okay, go ahead and do it. So I'll say quickly merge, confirm merge. This is the concept that how branches are created in the remote, how the branches are taken into the local, then how we again push it back to the branch itself, then raise a pull request from your branch to add the changes into the main branch, which is usually the process. Okay. Now this process, if you want it, you can delete it, but it depends on the project to project. You can just create or keep it basically. If I think that I don't need a defect branch anymore, I can delete it here. That's okay. I can also delete in the local as well. But it's not necessary that you must delete it. You can keep the branch as well accordingly. That now we understood the two things, right? The way we are actually updating the changes from one branch into another branch via a pull request. Now, whatever the approach we are talking is also something called as a workflow stream. I'll just give you a topic understanding here. There is something called workflows in Git, right? Now understand there can be a branch, a default branch in every Git repository that can be either a master or a main nowadays, always can be. So master is equals to main, main is equals to master, understand that way. Now we're talking about a concept here, simply give you the understanding. That's called workflows in Git, right? When you start working with projects in Git, version control software, this is one thing you do. Now, one thing is something called, the first one is called a centralized workflow. Now, what is centralized workflow? Before we starting branching, we were doing the centralized workflow. What I mean to say, you will have one remote main branch or a master branch. So you get to the local main branch or master, you make changes in your local, push back to the remote main and release from the master into the production. This is what we were doing it before we creating a branches, isn't it? That is called your centralized workflow as per the Git terminology. The first one, which is a centralized workflow, which is straightforward, which we did it multiple times just before we started branching concept in theoretical. Okay. Now the second thing, from the time we started creating a branches and then start working with your branches, technically that's called a feature workflow in Git, right? Now what is a feature workflow in Git? Now you have one remote main branch. From that you create feature defect branches as necessary. And the developers will take those branches and work on them. And the developers will push back into their own branches, which they worked on, can be feature defect branches. Then, of course, you can start releasing your code from your feature defect branch into the market. Then finally, merging into the main branch via pull request is mandatory. Okay. So you can release code from the specific branch, then merge it into the main, or the same concept, right? So first you merge it into the main, then release into the production. So how you want to do it, that's your choice. It's just an adoption from the development team, how they release the software into the market, or from which branch they would create releases and then release into the market. That is the concept here. That's what you can see here. One more time I'm doing it. Let's say the developer one is now working on the feature, right? Feature Z is a branch he's working on, as you can see it. Assume that the developer 2 is making a change on his own branch in his local laptop. Say now.java feature Z code added here, something. Just that some data he's writing it. That's one change he's making it. So he add git add dot git commit -m, say F1 something, right? And I say that vi feature z.java something, hi there, feature z here. Okay, something like that. So say that again, git add dot git commit -m F2, something like this. The developer one is working on the branch called feature Z, right? Feature Z, right? And then he made changes in this branch and then say that he add commit everything in the local, done. That you can check here by git log. You see these are the two new commits made by the developer one here on his local. Now, once that is done, let's say he will push it back to his remote feature Z branch. Like if I go back to the here, if I go to the feature Z branch, now do I see the feature Z file here or changes related to feature Z? The answer is no, right? We can't see the changes here. Now, what does he do? He will push, say git push origin feature Z, simple. Last the username, sorry, other one, right? Nareshwar T and the code, which is this one. Now let's say that the changes are pushed into the remote, correct? So if I refresh it, now you see that the feature Z file came up, the now or whatever the other one, the now.java modified, all the code is up here. Now what the feature Z, now it needs to update into the main branch. What it needs to do basically, create a pull request, right? So go create a pull request. It says that can't merge automatically something, because remember that the main branch was having some defect code that's not available in the feature branch. So what does developer one needs to do before he does that again? He might have to pull the changes from the main branch, isn't it? Isn't it or not? Because the main branch has some additional changes basically. So what he can do in the local, so git pull origin main, which means that I'm saying that, remember the developer is on the feature branch, but I'm saying that, hey, get me the changes available on the main branch, git pull origin main basically. It is giving you some option like, okay, there is some errors coming up. Okay, I'll go with the default option. Just say that rebase false, a default merge. Run this command before you re-execute since it failed it here, right? Now I'll just go ahead and do the git pull origin main again. There is also conflict coming up, right? Which is because, again, we haven't talked about the conflicts. I'll be explaining the conflicts again in more time clearly. It says that there is a change in the now.java, which other developer made. This guy also made the change in now.java. It's kind of conflicting it. I'll explain conflicts in more detailed way, but right now I'm going to fix this conflict quickly, right? Say I have something code. There's a defect code as well, right? We want everything. So let's say that I'll add and commit it. Something like I'm doing it, right? Now let's say that I'll push it back those changes too, because it happened only in the local. Now my remote feature also needs to have the same data. That's why I'll say that git push origin feature Z. Okay, copy it. Done. Now it's updated here. Now this time GitHub will give you no issues. Let's say that now you see it is able to merge successfully, means whatever the changes in the feature Z now can go to the main. Simple, right? I'll create a pull request and let's say merge the pull request. Simple. Now this is what all you're trying to see, which means that now technically once the changes are added into the main branch, I can go and create a release. Remember that, right? I'm ready to go and create releases. Whatever the changes I'm there, I can just new release, right? I'll point out the main branch here, as you can see that. From the main branch, you can check specific commits, what you wanted, right? So technically, if I want say till the D1, D2 is defect, now let's say that F1, F2, this one is basically the feature code. I can mark it releases accordingly. That is how you do it technically. I'm not creating one right now, but I'm just showing that I pick whatever I wanted and then I create a release for me accordingly from the main branch as my base, or the branch from where I would release my code always. This is how the feature workflow can be adopted by the teams to have a more cleaner parallel development without conflicting the work of the different developers here. That is nothing but your centralized workflow, feature workflow. Now you're getting to the point, right? Now you understood with Maven, the task is repetitive for me. Now that's why we say that use the Jenkins. Now what is Jenkins here is the question, right? Now what is Jenkins here? Again, a build tool. So if you look into this one team, I know I have something pre-written here. You can simply read them so you can understand it. So the understanding here is a team, how many times we build code stage execution in a day, multiple times can be 10 or 20, right? So repetitive work should be automated. So technically we need an automation tool. Now you can write your own automation. So you may develop your own automation strategy using your own liking tool, right? But in the market, we do have certain tools which are already developed and given to us. That is what we're talking as we need some automation tool. Now there are n number of automation tools that are given in the market. One such tool is called Jenkins. But is it the only Jenkins available in the market for automating? No. We do have something called TeamCity, Bamboo, you have GitHub Actions. If you go to the CodeBuild, Azure Pipeline, something like that. So Ansible is something different purpose, Vinay, right? Ansible does not come under the build code automation. It comes under the infrastructure automation. Of course, that is also an automation tool, but it has its own different purpose. Okay. These tools have a different purpose. So understand, right? So we need a tool that can help us automate the build code process. Again, I'm telling you, we need some tool or some automation tool that helps us automate the build code process. Upon a change in my source code repository, right? Upon a change in the GitHub, now I need to execute all the steps in a sense. I should automatically clone, pull the changes. I should automatically run the validate, compile, package, test. Everything should be automatically executed in a sequential manner. Now I need to build that logic. Now to build that logic, Jenkins will help me, right? Remember, the Jenkins is a tool that helps you. I'm just writing out, zooming in a little bit, you can read it. Jenkins is a tool that helps us to automate the build code process. Understand that. Now, in a way, we call that Jenkins is known as a build automation server. Now, if somebody asks you in the interview questions, what is Jenkins? The answer should be straightforward in a single line. It's a build automation server, right? It is also called as your continuous integration server. Now, why is it called continuous integration server here? What is a continuous integration? Remember that we're trying to integrate the code from various places maybe, and also you're trying to integrate the various tools such as the Git, Maven, and Jenkins are integrated together, and you repeat the same process n number of times, right? Repeating the same process n number of times is a continuous process. That's why we are integration and continuous operations are happening here. That's why Jenkins is also known as your continuous integration server, or a continuous integration using Jenkins is what we're talking technically. So understand here, Jenkins is known as a build automation server. In other words, it also can be called as continuous integration server. because it helps us integrating the code from various repositories, integrating the various tools like Git, Maven, Jenkins together to perform the build code process stages, right? Like I said here, we will integrate the various tools with Jenkins to perform the build code. Remember team, if I'm going to use the build code process now with Jenkins, it doesn't mean that we are replacing Maven with Jenkins here. Don't come to that assumption here. Jenkins is just a dummy tool, right? Now you need to tell the Jenkins what it needs to use, what it needs to done. Now what I'm saying it, earlier I was executing this command like mbn validate, mbn package, mbn test. Now we are not replacing Maven with Jenkins here, understand? We are gonna do the same task with Jenkins, which means instead of I am running the mbn validate command, I'll say, hey Jenkins, you run this command for me on behalf of me, right? So we will configure Jenkins with these commands here, right? Understand? We'll install Jenkins and we'll configure Jenkins in such a way that it will run these commands for you. It will run a git clone command on behalf of you. It would also run mbn validate, mbn package commands on behalf of you. And it's a tool, right? It's a software. Basically, it can repeat the same commands n number of times. It won't be bored. But if I run them, I'll be bored. That is what the whole idea is here. So are we replacing Maven with Jenkins here? Yes, team? No, right? We are not replacing it. Don't think that. So Jenkins is known as a build automation server, but it's not the one actually doing a build. It uses the various tools behind it to perform the build again. So that is how you need to understand. Okay. So again, I'm telling you the build code process can also be called as your continuous integration process. In short, it is called CI process. Continuous integration, in short, is CI. So you might be hearing something called CI CD pipelines. So with Jenkins, now first we'll construct a CI pipeline. Okay, we'll talk about the pipeline in a minute again. We will do the CI process with Jenkins, right? That's why Jenkins is known as your CI server, continuous integration server. With Jenkins, we can also perform something called CD, which is called continuous deployment. So for us, the focus for now should be on the CI. If you complete the CI process, then we'll go back to the CD, or we'll go to the CD process later in the future session. Until then, keep the CD aside, focus on CI. Okay. I hope that is clear. Now we're also talking something called a pipeline. Now you might be hearing CI pipeline, CD pipeline, or maybe a CI CD pipeline, something. Now what is pipeline here, right? What is a pipeline? In simple words, again, I'll tell you. Now we understood the build code process is also CI process. Now within the build code process, we have multiple stages, multiple steps, right? Like you have a cloning task, validate task, compile task, unit test task, package task, something. Remember, these are different tasks we have it. Now we will be running them in a sequential manner as we thought, right? So I'm saying it, a multiple steps or a stages in build code process are executed in an order or a sequence to reach from start point to end point, right? So there is a start point, there is an end point, basically we talk about it. So if you are running the stages involved in a build code process, right, and executed without any manual intervention, then we call it as a pipeline. Remember, there are multiple stages I have it. Now, if I run all those stages in the build code process, one after the other, without any manual intervention, everything is fully automated. Now that's called a pipeline, right? A pipeline has a start and also an end. So you start from a start point, go step by step, and then reach your end point. So if you attach all these stages one after the other to run automatically, that becomes your pipeline. Okay. So technically we're saying a build code process is nothing but your continuous integration process, in short, a CI process. So the build code process itself is nothing but your CI pipeline. Okay. Now I hope you are also clear now what is called a CI pipeline or pipeline meaning to you. Okay. So this is what it is. Now, what is the next task we need to do here? Now it's that we need to start using the Jenkins to do every task we were doing manually. So thing is that we need to install the Jenkins, right or not? Should we install the Jenkins now? So let's start installing the Jenkins. Again, go back to the GitHub repo. You also find the Jenkins installation instruction here, as you can see that, right? So it says the install Jenkins blah blah, right? So let's go ahead and do this. I'll run the same instruction here available on my same EC2 instance. I'm not using anything new here, right? Go here. I'm just running. Okay, done. Finally, you can say apt get install Jenkins. Say yes. Now this will start installing the Jenkins team here. So once the Jenkins is installed, remember, unlike the Maven, Java, Git team, they're all CLI tools. Now Jenkins is basically a web-based application. You need to open it in your browser. It's not a CLI application or a CLI tool. Jenkins is basically a UI application, a user interface application. So you can open this in a browser. This is like your web application. Again, I'll talk. So you can open Jenkins in a web browser and then start working in the web browser directly. We don't work on the command line. We work with Jenkins on the UI part. Okay. So once we install Jenkins, as you can see, there are certain commands I have given to validate. So don't restart directly, team. Just check if you're able to see if the Jenkins is installed, first of all. Right. So this is a command to check if the Jenkins is running on your system, installed on your system. You can say it is active and running it 42 seconds ago, blah, blah, blah. Okay. Right. So now that we installed a Jenkins team here on our server, and we have checked the Jenkins working or not by running a command called sudo systemctl status Jenkins. So this is what you see it now. It's active and running it. Okay. Now understand, team, as I told you, Jenkins is a web-based application. Again, it's a UI-based application. So how do I access web-based applications? Usually using a URL. Now this is how, team, if you look into this on the right side, I'll zoom in a lot for you so you can understand it. Now this is what you see, right? So basically on your EC2 or the server, we have Git line, Java, Maven. And remember, Jenkins is also being installed on the same thing. So technically this Jenkins is an application that runs on a port number called 8080. As I told you on the day one, any web application that you access through the IP address of this server where you have that application installed with a port number of that particular process running on that machine, right? On that particular thing. So this is what it is. Now you can see the default port number as well. It appears here on the screen. See the HTTP port number, which is the 8080, as you can see on my screen, everybody. I'm highlighting on the right side corner so you can see that, I believe. So if you hit the sudo systemctl status Jenkins, it is also showing you the port number on which your Jenkins process is listening. Now, which IP address would I use here? Where we have installed Jenkins, it is on your EC2 instance, right? So you need to use the public IP of your EC2 instance, which is like if you go to the AWS console, you see that there is a public IP before address. Take that and give the IP address in the browser with the port number is 8080. And by default, it will be HTTP in the front, but you can also say HTTP something like this, right? Now this is how, if I hit it, now you should see the request goes from your laptop to EC2 instance and launches your Jenkins like this. And again, I'm telling you, in order to access the Jenkins, you need to know the port number of the Jenkins. By default, with your installation, it is 8080 always. No, it will not change. And there is an IP address of the EC2 instance, you know it always. So in your browser, you always have to hit something called HTTP //ec2ip with port number of the Jenkins. Now that's what we just did it here. You can see it is responding back to you. But again, by default, you can say it is unlocked Jenkins, which means by default, it has a security administrator password to log in. Now it is giving you the idea like where this password is already available. The screen you see, it says /var lib Jenkins secrets. There is something called initial admin password. So what I can do is that I can simply copy this URL or the path on your UI itself and go back to the server where you install the Jenkins, which is your EC2 instance. Now, how do I open a file? You can use a cat command and then give the path or paste that you copied on the screen. Now you get it, right? If you hit it, now you will see some random numbers here, or with the alphanumeric characters, we can say that. Now you can see this is your password by default. We'll change it now anyway. So let's say that the first time when you installed it, you always use the initial admin password automatically generated as part of your installation. So you copy that password and then getting back to your browser and then paste the password in the administrator password field and then say continue. Okay. Now it will take you to the next page automatically if the password is right. Now on the next page, it gives you something called customize Jenkins. Just follow the same steps I'm doing it, team. Now as a beginner, you always need to go with something called install suggested plugins. Now what are plugins with Jenkins? I'll explain later. But right now you just need to click on this something called install suggested plugins. Ensure you do that. So don't miss that out. It is very much important for us. So when you click on install suggested plugins, it will continue to the next page and it will try configuring a few things automatically for you, right? All you need is a internet connection properly set. So it will try to do this. Okay. So understand again, just click on the install suggested plugins. So it will continue to the next and it will start configuring a few additional configuration for Jenkins automatically. And this is all part of your Jenkins installation setup itself. So let it continue and then we will try to do. Okay, so let it finish. Now, once you see that page is done, team, and it will take you to the next page. And you also can see it is asking you to create your first admin user. Means you can use these credentials to log in later again to the Jenkins UI. Whenever you stop EC2 instance and come back later, you need to use this credential. So whatever you give it on this page, please remember accordingly. So let's say that I'll use an admin and some password for the admin, right? And say that my name is whatever the name you want to configure. You can say admin or Naresh or anything that you want. So I'm just keeping the same thing name here, gmail.com, something like this. Now you fill out the form. Remember, please do remember, if you forget them, you can't log into the Jenkins later again. So I'll save and continue. On the next page, it might give you something called Jenkins URL, which is same thing as in your browser. You can keep it as it is if you want to, and save and finish it up. Right? And then once you do the save and finish and say it says Jenkins is ready, now you can say start using Jenkins. Okay. Now if I click on the Jenkins, start using Jenkins, now this is the UI that you see it. Okay. Now this is the UI that you see. This is how you install Jenkins and launch a Jenkins UI so far. So I believe, team, I'm clear so far on the setup. Now, if you're having this UI in front of you, now the next task is to start build code process using Jenkins. We automate everything using this UI itself accordingly, step by step. Okay. And before I start using the Jenkins, team, I want you to be clear on something as well. Remember that you are installing the various tools on your EC2 instance. Do you know the installation path of your each tool you install so far? Remember, team, why I'm asking it is very much important as a DevOps engineer, right? If you are working with Jenkins, if there is a problem, troubleshooting scenarios, you need to know where they're installed. So technically, we installed Git, we installed Maven, we installed Java, and we installed Jenkins as well, right? So every software has its own installation path. Like in your Windows team, usually it is always that you go and C drive, profile, something, right? That's where you install everything. So remember that every software that we install on your laptops or on a system has an installation path. So just to show you that basically the way we understand, so the default installation path of your Java, which is user lib jvm something. I mean, if you follow the instruction which I gave you on the GitHub, these are the installation paths. But again, these can be configured when you're installing it. We haven't configured anything, so using the default paths, right? So this is your default installation path of the Java. Remember the path. This is where your Java is installed. That is /user lib jvm something. Now the Maven is installed under opt Maven. This is again, if you look into it, this is your Maven installation path where the Maven is available. And your Jenkins installation path, or we also call that as a Jenkins home. By default, it is called a var lib Jenkins, right? This is where you see all the Jenkins related software binaries as well as Jenkins related logs. In case if there is a problem with Jenkins software, you can come back here and check the logs of the Jenkins to understand the problem of the Jenkins. Based on the findings, you can troubleshoot further. That is the area. So three important things to know here: the Jenkins Java installation path and the Maven installation path and the Jenkins installation path. The Jenkins installation path, Maven installation path, Java installation path are also referred as your Jenkins home, Maven home, Java home, something like that. Okay. When I say Java home, it is a Java installation path. When I say Maven home, it is the Maven installation path. If it's a Jenkins Java home, it is Java installation path, something like that. Okay. So keep these paths in mind always, and then you have to work on the terminal sometimes to understand the problems as well. Okay. I hope that is clear, everybody, knowing the paths. Anyway, we will be configuring the paths again with Jenkins right now. So this is your Jenkins UI, as you can see, right? Now on this particular page team, right, on the top, you can see logout and login as usual, just like any other applications you see it. Now I can log in with my credentials, right? Log out and log in. Now you see this page. Now on the left side menu, you see something called dashboard. Below that, you see some options called new item, build history, manage Jenkins, my view, something. One important thing here is that your manage Jenkins. This manage Jenkins is same as your settings on your phone, for example, right? In a simple nutshell, if I say it, if I have to configure my phone, if I have to customize my phone configurations, I go to the settings of my phone and then I choose what I wanted. I configure what I wanted. Similarly, on your Jenkins, if I have to configure something, if I have to customize my Jenkins behavior, I always go to an option called manage Jenkins on the left menu, right? And if I go, you see the n number of options like system configuration, security, status information, all these options you will see. Choose the necessary options to configure, customize Jenkins behavior accordingly. Okay. Now, why I have come to this page, remember, the first task in Jenkins is to integrate the Git and Maven to the Jenkins. Remember that I want Jenkins to run a Git clone operation. I want Jenkins to run a Maven validate commands, right? So technically, we need to tell the Jenkins where I install Maven or where is the Jenkins Git available, all that stuff. Because Jenkins does not know, right? Does Jenkins know that I installed Maven here? Does Jenkins know that Maven is available in that particular folder? May not be, right? So it is your responsibility to tell the Jenkins that, hey, Jenkins, the Maven software is available in this folder. You may use it when I ask you to do something with Maven, right? That is what is called integration, right? We are integrating Maven with Jenkins. Similarly, the Git. Say Git binary is available under say user bin Git something. So I need to tell that, okay, this is where the Git is there. Similarly, this is where the Java is there. So user lib something. So Jenkins will use all these different tools to perform the build code process. We need to configure them. That is where I've come to the manage Jenkins, and on the system configuration, see system, and the second thing you see is the tools, right? Tools, that configure tools in their locations and automatic installers if you want to, right? So I'll go to the tools option here, click on the tools option. Now, under this, you might find the default options already available, like say tools like Maven configuration or the JDK installation path, something. JDK is nothing but a Java, right? If I click on add JDK here, it will ask you, okay, give me the Java home, right? I'll say this is Java 1.17. You can give any name here, remember? I can say any name, that is also going to work for me. It doesn't matter what you write it, but write some meaningful names. Java home is nothing but the installation path of your Java. So where will we install? Now this is the path, right? Copy this path. I paste it here. Simple. If you want to install automatically, Jenkins can do, but I don't want to do that. We already installed Java. That is the idea. Now the Git, second one, as in Git installation, it is asking you, okay, this is default, it is giving it something, okay, and says Git. Something if you want to configure the absolute path, say user bin Git, just give it as it is. Okay, that's how you can do. Now below, if you say something called the Gradle and Maven blah blah, but by default Jenkins supports the Java project, so it is by default giving all the Java related build tools here. But you can also add the build tools of .NET, Python, Go, anything you want. I'll tell you how to add them as well. But right now, let's say we configure Maven. So I'll say add Maven, right? Okay, 2 times added. So let me remove one. So add Maven, and I say Maven 3.9 something. I don't want to install automatically because I already installed. So I'll untick this install automatic option, and I give the Maven home path. Maven home is opt Maven. So I'll go and I give it. Simple. Apply this, save it. Right? Now this is how team we need to configure the required tools according to your build requirement, according to the programming language builds you do it. You configure the required tools here always. Okay, so from this, go to the Manage Jenkins and go to the tools to configure various tools. Now here under the JDK installations, we already have configured these paths, something you can see, the gate, blah, blah. Now, how did I get these paths here, right? From the command line, I'll show you if I do a history. Now, this is your Java installation path, right? And this is your Maven installation path. And this is your Jenkins installation path. And to get your Git installation path, you may run a command which git, something like this, you get it. Right, Neha? This is something which you will get to know as per the installations you do it. Okay. Now, once you configure your tools, now we are ready to tell the Jenkins to do some task. Which Jenkins does it work? I don't think so. It gives a different path. It's not the installation path, it's the executable path, you can see. Okay. Right. So now that we have configured successfully, the next thing is that we tell the Jenkins a task, right? I want Jenkins to do some task. I want Jenkins to do some job on behalf of me. Understand here, team, I'm saying it. I want Jenkins to do a job on behalf of me. Whatever the job I was doing it manually, I want to give it to Jenkins. So Jenkins does it for me whenever I ask to do it. So to do that, basically, or whenever you would like to give a task to the Jenkins, we use an option on the left menu called a new item, right? Always use the new item on the left. If I click on the new item, it will give you a page where it will give you some options. Say new item, you give a name. Say, for example, I want to give a sample app, right? This is my sample Java app, right? As I simply call sample app, right? Underscore or dash something, validate. Means depends on the goal. Now remember, this name can be anything as your choice. I'm just giving what I'm trying to give it. Now, once you choose a name for your task, I want to do a validation first of all, and I'll say select item type, which is a freestyle project. Now, as a beginner team, you always go with a freestyle project, which will help you understand the basics of Jenkins and configure whatever you would like it. So I'll choose a freestyle project here. Then I say OK to it. Now, when I select a freestyle project and I say OK, it will open up something called a job configuration page. We call them as a job or a project in Jenkins, remember. I simply save if I want to, remember. On the dashboard, if I go back now, you see what you created. Now, this is simply called as a job in Jenkins, or this is the same thing we can also call as a project in Jenkins. It doesn't matter what you call, but this is what it is, right? Once you create and save it, it's an empty job right now. There is nothing given in this, but if I want to re-edit it, I'll click on the job. It will open up the job page again. Now on the left, you see the various options, like you can delete it, rename it, can find the changes. There is one option called configure it. Configure in the sense you can configure what you want again with Java. So I click on the configure, it will go back to the same page. Now on this page, on the left menu, you see the various options. Now you can tell the Jenkins what it needs to do, what this job needs to do, what task it needs to execute. We'll see that. The general, you can give just description of the job if you want to, and choose the various options here. We'll come across them later. The main thing we want to do here is that basically clone the source code, isn't it? What we want to do technically, where is this? Sorry. Right, so here, right? Now, what we want to do here is that first thing is basically to clone the source code, isn't it? Right. So we want to clone the source code, then go and run the various tasks on the source code. That is what we want to know. It's doing too much thing. That's okay. Okay, my mouse is really bad. Okay, anyway, you understood, right? So technically what we want is that cloning it. So on the left menu, there is an option called as source code management. Now on the source code management, if you look into the page, it says connect and manage your code repository to automatically pull latest code of your builds. So it says, okay, there is none by default. We can choose Git. Even if you have a source code in SVN or some other tool stream, we can add them as well. By default, it is supporting Git for you. So let's say select a Git. Now, if I select a Git, it simply asks you the repository URL, right? What is repository URL here? Your Java source code. So I'll take this URL, copy it, and then paste it in the box. That's it. Now it automatically detects it. Now it is also giving an option team credentials. Now, when should I use the credentials here? When do I need a credentials probably to clone a Git repository? Basically, when the project is private, isn't it? Basically, when your project is private, you need to give the credentials, remember. Now, since I can't provide the credentials every time, Jenkins gives an option for me to store my credentials in the Jenkins itself. Say, for example, I'll add the credential Jenkins. It will open up this page, right? Now, where I can say the credentials, the username and password or something else, we can also configure SSH and everything. I'll use my password. So username of my GitHub, say this one, it is, I think, lead DevOps, some username of your GitHub. And let's say that the password is nothing but your token team. Remember the token that we were using to pull, right? This is the token, right? Clone, push, basically you use that. I'll say this is my GitHub credentials, for example, right? So you save it with a proper name. That what is this? Now I'll say add. Now, once I add it, basically you can see from the drop down the right credentials to clone this repository. Remember, in case if this is a private repository, I must provide the credentials like this. If it is public, you don't need to actually remember. This is a public basically. Even if I select none here, it will still clone it without any issues. But if in case it is private, ensure you add a credentials and store your username and password here, and then map it accordingly. Otherwise, the clone will fail. That is the idea. Okay. Now, along with that, you can also choose a branch you want to clone or any specific branch that you want to work on, the master or a main or something. By default, there is a master branch here, so I'm using a master branch itself technically. If you want to build code on a different branch than the default master, then you use it accordingly. Okay. So this section team just tells you that Jenkins is going to clone the Git repository on behalf of you. Just configure the URL. Jenkins will take care of cloning it, pulling the changes from the repository automatically. That's the idea. Okay, done. Now, first thing, Jenkins have to clone it. This is done. We configured. The triggers we'll talk later. Environment also we'll talk later. One important thing in this job is called a build step. Remember the build step, the building, right? We talk about it. The build step. What is a build step? Basically, what Jenkins needs to execute on behalf of you after cloning the repository. Remember, the build steps are something after we clone the Git repository, we run some build steps like MVN validate, MVN package, right? Those are called the build steps, the process. So the build steps is where you can actually configure whatever you want. Say if I have to run some Windows commands, I can run Windows execute shell, something like with the different options. Remember team, whatever the commands that you're running on your terminal, now these are all called as your shell commands, right? So shell terminal where you run it, that's why it is giving something called execute a shell commands basically, like we were running. So I'll say which git, I can run it, right? I can say touch nourish.txt. It's like, remember team, all these regular Linux commands that you are running so far now can be given to the Git. Sorry, Jenkins, right? Sorry. So in this case, if the Jenkins is going to execute a command called which-git, Jenkins is going to execute a command called touch on behalf of you, and so on. So since I'm saying it, now you can also say, hey, Jenkins, run a command, say opt maven bin mvn validate something. Understand here? I can run simply mvn validate also. I can also give absolute path as you want. Remember, there is no absolute path basically, but this is an absolute path. It's your choice, whichever you want to give, a short or an absolute path always will work. So this is how I give it. So remember, the mvn validate is what we ran manually to validate the source code earlier, right? In this case as well, Jenkins will clone it and also perform all these tasks you have given in a single go. So I'll say apply it, save it. Now I have told Jenkins what to do, right? Within the job configuration here, I have told Jenkins, hey, you need to run all these tasks when I asked you to do it. That's all. But when do I ask to do it? That's my choice again. If I click on the job, on the left side, you see an option called build now. The build now is like you execute now, right? Those commands, whatever it is, git clone, which command, all these commands you need to execute now. Whenever I click on the build now, when I say build now, which means I'm asking the Jenkins to execute them now and get me the results. That is the idea. You can also automate it further. We'll do it later. But right now I'll click on the build now option manually. If I click on the build now you see below there is a builds get started. Once it is trying to execute, you see the build is in progress. Just below this rename team on the left, you see that, right? The build is in progress. It is trying to execute. Whenever it says it is successful, you can see the green tick mark. But how do I see the results of it? The build number is 1. I click on this build number, like this, a link it will. I will open up that link basically. Like you see here, it is started by the user called admin and it is running time and blah, blah. On the left side, you do see the various options. Git, build data, blah, it says something. Some timings, how much time it took to execute this whole task for you, all the timing. Now you can say the console output. The console output is where the results can be seen on your UI. Like whatever we're seeing on the command line earlier, like the build output, right? The build success message, right? Where is that? This one. Say this build output, right? You see build downloading something. The same output is now available on your UI. I say the build success, blah, blah, right? So you see this, the same output, right? You see, first of all, it says, okay, let me zoom in a little bit for you. It says that using the GitHub credentials, blah, blah, and says cloning the repository for you and so on. So whatever it is, trying to write some data, right? If I try to look into it, it tries to clone the repository successfully. Once it tries to clone the repository, then say it is running a command called which-git. Then it is trying to print that output. Touch nourish.txt writer. Then it is also trying the opt maven validate. Same thing output again, right? Downloading something. All the output that you saw earlier on the command line now is available here. Like you see at the end, it would say that the build is successful. The build success, right? Now you can see that now, since I configured once, now next time onwards, I don't even need to remember those commands. I click on a build now again. Means when there is a new change available in the source code, I can simply click on the build now. It will again start the tasks for you. It clones the latest task, latest changes, and then executes the same validate command. Run again, right? Whenever you are making a change in the source code, just click on the build now. It will keep building the same thing for you. That is the simple idea we're talking about. I'm hoping that I'm clear on how do I create a job on the Jenkins and how do I execute them whenever you want it so far. Right. The commands are under the job. So if I say configure, I can just go and check the build steps. I want to modify them, I can modify. Say I want to run only the validate instead of those things, I can save it. Apply, save, simple. You want to remodify it. Otherwise, okay. Every build will give you some output for you. So remember, Jenkins is also preserving the output of every time you build. Now, this was not possible on the command line, correct or not? So you can go back in the history and check when a job is failed, the reason for failure, everything can be checked on the Jenkins UI. If I run manually on the command line, how do I get track of how many times I failed? What is the reason for fail? Can I do that? Now, isn't that easy basically, team, everybody? Configuring something and asking Jenkins to do something here. Okay. Right, so the first thing we understood is called the validate. Now, the next thing we need to understand is the step 2, which is going to be a compile. What are the option as SW in the dashboard? Oh, this is the status, right? Status of the build, whether it is a successful or a failure. Now, the second thing is called weather, like whether the build is good, like sunny means it is a very good build. Build is stable, stability, no reason build failed something. If you fail multiple times, that becomes a thundering, like just a notation Jenkins follows it. Sunny means a good build. Thundering, like cloudy comes up, then the bad build means the build might have failed, something like that. That is the idea. This is called weather. This is called status. And this is like the icon sizes, small, medium, large. That's it. Okay, so the next task in your build code process team, I think we haven't written the build code process steps. I will write it now for a second. You can understand them. As I said, we will be doing in a sequential manner. It's not that you will be doing inside, this one. So there are certain stages we follow mandatory for every code. So technically, the validate you did right now, that is may do it or may not do it, that's fine. But there is something called a compilation. Then we have something called as a code review. Then we call it as a unit test. Then you may also do something called a code coverage step. I'll talk about all these steps. What are they one by one? Then finally package. Remember team, the final goal is to package it, right? Package is the step where you get the executable or a deployable format of the source code. But what are these stages before? What are we trying to achieve by using these stages above the package? Again, remember the sequence I wrote is the most of the time we follow the sequence, but it's your choice that you can alter the sequence before one, but keep the package as the last step always. Now, what is the meaning of each stage here? We'll try to understand. You already know the validate. Let's say that what is compile, what is code review, what is unit testing, what is code coverage. We'll try to understand now. Right, so understanding is a team. All these are of certain validation and testing process, right? So assume that, say, the simple scenario, right? Think about it. Whenever you try to produce a product as such, it can be anything, right? In this case, a product is a software. But if you talk about the product like maybe a car or a bike or maybe an AC or a computer or something. Now, do you think that, or is it a good practice that you think that without testing, without validating, should I give the product to an end user? Without testing something, without doing some basic validations, whether the product is going to be functioning properly or not, will you give the product to end user? No, right? Technically not. It is not a good thing at all. Now understand that team, before I package, means if I package it, which means that I'm ready to install the package on a server, which is used by the end user. So understand all these stages are certain validations and testing, right? Whatever we're trying to do about the package are certain validations and testing of the source code to ensure the quality of the software, right? Remember, in this case, the product is the software technically. Now we need to ensure that quality of that software product is absolutely good, right? At least some validations to be done so that the product functions well when we try to install it on a server, and the end user should not see the problem. That is what the purpose we are running all these stages above the package always. Now, since everything is a validation, now different type of validation is what we're trying to do. Now, what is a compilation meaning? Have you ever run a compiler? Have you read about the compilers in your graduation sometime somewhere or anywhere outside? What is compilation meaning? Convert source code into a binary code, source code into machine, convert data into machine language, right? Now it is also validation team. What we're trying to say is that we're asking Maven to compile the source code. Now, what is the reason we are compiling it? Remember, there is a lot of source code programs are written here, which are in the human readable format. Means as a human beings, we are the one who understands the lines of code here written and we modify it. But at the end of the day, these programs needs to be executed by the machine or a CPU computer on your hardware. So those things should understand these lines of code. That's where we need to convert the source code into a binary code, right? Whether it is convertible or not. Means sometimes if you make a mistake in the program, that cannot be executed in the CPU, right? On the binary side. So whether these programs written by the developers are or can be successfully converted to a binary code or not, that's the validation we're trying to do as a compilation. Means we ask the Maven, hey Maven, go to the source code, whatever is available, you try to compile and see whether the compilation is getting successful or not. Means whether these programs can be compiled, can be converted as a binary code or not. We're trying to ask the Maven to do that. If it is not compilable, does it make sense to package? If the source code is not compilable or it's not compiling properly, does it make sense to package for me? Definitely not, because it will error out anyway. Even if you package it later when it's trying to run on a computer, it will error out. Some errors will be given. That is the reason we perform a compile step or a compile stage basically. So what do I need to do in a simple nutshell? That I'll build a new item. I'll say, okay, sample app, right? Sample app, compile something. I'm just giving a name. I'll say select a freestyle project, say okay to it. Then I give the source code which needs to be compiled. So I'll select the Git again, right? I'll just give the project URL. Same steps team. If required, give the credentials and choose the branch from which you're trying to compile the source code. And then go to the build steps, right? Right now we use build steps and source code team. Later we use other options. Let's say now execute a shell. Then I ask Maven, say opt maven bin mvn compile, right? The compile is the option. Apply it. Now remember, this command should be properly written here, otherwise it may fail, right? Save it. Then say execute. Execute in the sense build now. When I click on the build now, the Maven will start compiling the source code, right? Then it will generate the results. What is the outcome of the compile stage? If I click on the build number 1, see the console output, it is trying to do something, whatever it is. It says build success, which means it is compiled successfully, right? There is no issues while I'm compiling it. There is no issues while the Maven is trying to compile the source code. One thing you need to understand before we go further anyway, team, understand it. Where are the results generated by the Maven? We talked about it already. Where does Maven generate the results? Maven puts the results into a folder called as target folder, right or not? We already talked about it, right? Maven puts the results under the here, right? Earlier we have seen this. If I cd sample app, now where does Maven put the result always? Target folder. Good. But the question here is that where did Jenkins clone the repository? Now remember, as we're seeing it here on the stage, what is Jenkins doing first of all? Jenkins is cloning the Git repository, right? Where does Jenkins clone the Git repository on your server? I know you're seeing on the UI, but the operation is happening on the backend, right? Execution is happening on the EC2 instance. Can I say that, everybody? Whatever you're executing here is maybe on the UI you see it, but the actual execution is on the EC2 instance, correct or not? The actual execution is on the EC2 instance, right? Where the Jenkins is running and everything. So I'm asking the question, where is Jenkins cloning the Git repository for you? It says cloning the Git repository, but where is exactly cloning it? Now, this is very much important as a DevOps engineer team, where you see all the data. That's something we see above building in workspace. Do you see this message here? It says that, hey, I'm trying to build in a path of workspace called var lib Jenkins workspace and your job name. Understand, team, this is very much important with Jenkins. Jenkins executes all of its projects, all of its jobs under a default folder called Jenkins home workspace. Now, what is Jenkins home here? The Jenkins home is your var lib Jenkins, the default installation path. Now, under that, it creates a folder called workspace. You see at the last, right? So cd workspace. Under the workspace, it creates the jobs that you do it on the UI. Remember, there are two jobs created here. One is the validate, one is the compile. Now you see that it is generating the appropriate folders here. Now this is where it will try to clone the Git repository. If I go to the sample app compile, this is where you see it cloned all the code for you, right? It is cloning the Git repository under the workspace directory of the particular job. Now that is where Maven generates the target as well. If I go to the target is where you see the binary code. Remember, the outcome of your compile is the binary code of the actual source code, right? So what is a binary code in Java? It is called classes. If I go to the classes here, you see the same folder structure as DevOps Demo utilities. Now here you see basically the binary code of the Java files. Usually that is the extension of .java. The binary code is the .class file. Remember, here you might see not understand something blah blah, something like this you see. So this is basically the binary format of your actual Java source code that's available on your GitHub. Okay. Remember, the outcome of your compile step is the binary code of your Java source code. Now that's, if it is compiled successfully, you'll see all these things. If it is not compiled, any one file has an issue in certain line. If there is a problem, then it will not be successful, right? In that case, you have to ask the developer to check the error. Hey, this we are not able to compile. Please correct it and then push the code to the GitHub again so we can recompile and check it again. So I hope, team, I'm clear on this step called compile. What is compilation meaning and how do I perform using Jenkins as a step inside the Jenkins UI? Okay. Now, if you're good, let's say we'll continue on to the next one, which is called code review. Right now, what is this code review? What is the meaning of a code review in general, if you understand it? Think about it, right? For example, forget about the code for a minute. Forget about the what we're discussing so far for a minute. Just get into more generalized topic. So for example, say that I have written an essay in English. I hope everybody uses English, right? English as a language we're talking. So think about it. I have written an essay in English and then I have given that to you to review it. So what are all the things that you will review and give me the feedback on the essay which I've read? Grammar, spellings, the way format. Yes, of course. Grammar and spelling. Okay. Okay. Now you understood, right? You are doing something easy and standard. But tell me on what basis you are validating all these things? What is the basis of your validation? It's a predefined process, right? Because you're learning the English language from your childhood. Now you've come across, right, the various things throughout your lifespan. And you know now that there are certain standards of writing that English essay. Can I say that? There are certain standards that are used for writing spellings, punctuations, and all that stuff basically are defined or that are in your brain. So you're applying the standards in your brain against the essay which I gave you, then you are giving me your feedback. That is what all the understanding is. So that is what. So it is always validated based on the predefined standards, right? That you might be knowing it or you may not be knowing, right? So now you apply the same logic to the code as well. Now, initial days team, there was no code review process, right? Initial days in the sense, say, if you go back in time, say 30 years back or 3 to 4 decades back, where everybody started coding freshly, there was nothing like that, right? There was nothing like a code review process we went. But over the period of time, there were many developers who wrote the code, who made mistakes, who corrected those mistakes, right? And they have written some guidelines on developing a software, right or not? There are certain standards that are given by the developers to develop a new software always. Can I say that? Because that is all coming out from their experience that the future developer should not do the same mistakes again. So they have developed some standards of writing a coding and then applying it into the process. Because we are in 2020s now, 2024, 2025, right? N number of developers have gone through N number of issues already. We should not make the same mistakes, which means you know that there are certain standards you can follow to produce a better software. So what are we trying to say here is that team, when we say code review process, right? As a developer, as a fresher, right? Think about I'm a fresher that I've joined in 2025, 2024 as a developer. Then I started writing the coding. I started developing some coding, right? Code something. Now, once after I develop it, did I really follow the standards that are written by many people already? Did I make some mistakes? How do I get to know them? That's where the code review comes into the picture. Okay. The code review is something that you check your code against the predefined standards and tell the developer that, hey, developer, you might be missing the standard that can cause issues in the software that you developed, basically. Understand here, team, again, I'm telling you that the code given by the developer is validated against certain set of standards given by experienced people, which are given accordingly. We validate this code and we highlight some issues from the code to the developer saying that, hey, developer, you're missing the standards in this code. Maybe better you follow the standards to have a better quality software delivered out to the customers again, right? That's what the process is called as a code review. Review the code against the standards and provide the feedback to the developers accordingly, right? That is what all you need to understand. I hope that I'm clear on what is a code review process, right? So again, in this scenario, we're going to use some predefined rule set, something called a PMD. A PMD is basically a program mistake detector, we call it. I mean, it's a very lightweight, certain predefined standards given by certain things, right? So I'll say PMD here, sorry, code analysis. Now, if you try to look into this PMD, Just an example, team, you can also use something called SonarQube or some other tools. There are many tools. Again, there are many different standards available in the market. For our scenario, I'm just using this particular basic thing. Okay. Now, what you see here is a PMD is an open source static source code analyzer that reports on issues found within the application code, basically, right? Now it says that PMD includes a built-in rule sets and supports the ability to write your custom rules as well if you need to. PMD does not report compilation errors, remember, it just does only the code reviews, right? As it only can process well-formatted source files. So understand here, PMD includes the built-in rule sets and supports to ability to write the custom rule sets as well. So we'll rely on the built-in ones only right now. So which means that whatever the source code available in this particular SRC folder will validate against the PMD rule sets, right? And again, who will do that? Okay, we'll ask Maven itself. Okay, Maven, go get the PMD rule set, then validate the source code against the PMD rule set, then give me the results. That is what all we're going to do it here. Okay. Am I clear on the step that we're going to perform right now? I'll create a new item, right? Say maybe code review, freestyle project. Say okay. It says good. The code review. Now I'll open and configure it. Again, I'll give the source code repo where I have my source code. Just copy the URL and give it in this one. Require configure it and say use the branch accordingly. Then build a step. And I use again the execute shell, right? I'll say opt maven bin mbn. Now here team, I'm going to use something called -P. This is a predefined syntax again. I'm not using anything on my own. Say PMD colon PMD, right? What I'm saying it, hey, Maven, use this PMD rule set. Try to get me the metrics out of the PMD and then try to validate the source code. That is how I'm telling it. Okay. So this is what all the syntax which is predefined to perform the code review with Maven and with the help of predefined rule set Maven PMD. I'll apply this, save it, build now. Just that you do it. So I'll click on this console output. Now it is trying to do something, team. It says build success. Okay, it was quick enough. It was able to get the PMD rule set and then able to validate everything. Now it says build is success, but you need to see the results, isn't it? Yes, team. Do we need to see the results now? Yes or no? Do I need to see the results? Where are the results? Where does Maven generate results by default? Where does Maven generate results by default? Under the target folder, isn't it? The target folder. Now, where is the target folder here? Under the Jenkins workspace again, right or not? Yes, team. Where is the target folder? Under the Jenkins workspace. If I go back here on the command line, I'll show you that there is a code review available, right? So if I go to the workspace, then you see the clone happened and there is a target folder. Now, another target folder is where you see some results, say pmd.xml, blah, blah, something. Say Java unused code, imports, basics, some kind of a results it is generated. Okay. But again, the same workspace team, so far I've shown you on the command line, but the same workspace can be seen on the UI as well if you want to. Like under each job that you see here, on the left, there is something called workspace. You see this? If I click on the workspace, you see the same thing. Now, if I go to the target folder, that you see the results. Now, all the results generated by the code review process here team, it's a PMD. Now it generated something called XML. Now this is the output. Now there are some issues maybe reported in this, but how many of you are good in reading this XML file? Can you tell me the issues found during the code review by reading this XML file is a question. Okay, now I can't read the XML. So what should I do then? To understand this problem, so what should I do? What do you do? Usually if I give you this XML, find out some issues. Okay, you are not able to understand it. So what do you try to do to fix it or read it properly? The question is that I'm unable to read the XML data properly, so I want to understand what's in XML. So how do I make it understandable from the XML I have it? Better you convert into understandable format, right? Instead of debugging everything here, think about a solution. How can I make this understandable? So this is where team now the power of Jenkins comes into the picture. Let me tell you. Convert into a JSON or any other format, convert into another format. Now the question is that who will convert into another format again, right? Maven is generating XML. Now I want that XML is converted into a HTML and maybe convert into a nice visualization format. Now this is where team, you need to understand why we are using Jenkins for the build code process. So understand Jenkins is a very, very powerful tool, right? It will help you to do anything that you want technically. By default, it has some basic functionalities only, but you can extend the Jenkins functionalities to do any task you wanted. Now, what do I mean that? What do we mean by that? For example, team, I'll take again a general example. Let's say that, right? Everybody using a phone. Which phone are you using? Android or iPhone? Maybe anything, right? Either it is an Android phone or maybe an iPhone basically. First, suppose whatever the model you purchase it, when you purchase your phone from the vendor, what you get in your phone is a basic applications, right? But do you stop with those applications only? Or let's say if I want to purchase something in Amazon, what do I do? If I have to purchase something on Amazon, what do I do? Amazon may not be the default application available. So what you do is that you go to a Play Store, you go to an app store, try to install what is needed. If I have to play a game, I'll install the game. So remember that the basic phone has a basic applications only, but you extend your phone capabilities by adding the additional applications as and when necessary. Can I say that, everybody? That's the basic thing, right? So you always extend your phone capabilities according to the requirement. Whenever there is a necessity of certain application, I'll go to either Play Store or App Store, download that, install it on your phone, and use it accordingly. That's by extending your phone capabilities. So think about it, team. The Jenkins software that you install is like your basic phone so far. We are trying to use whatever is default given. Remember, the Jenkins application that you're using so far is the basic Jenkins software. You're trying to use whatever is given as a default. But Jenkins functionalities can be extended as you like it, whenever you want it, in any direction you want it. Now that's where there is a concept called plugins comes into the picture. Remember, the application that you're installing from your Play Store or App Store are like plug and play applications, right? You plug it and play it with them whenever you want. So kind of plug-in, you do it. Now, same thing we're talking about the Jenkins as well. Jenkins also has something called plugins, right? Now, whichever the functionality you don't see in Jenkins, but you want it, you try to look for a certain plugin that will extend your Jenkins capabilities. So if I go to the Google and say Jenkins plugins, something. Now you go to a place called plugins.jenkins.io. Now this is like your Play Store or App Store. Understand, team? This place is like your Play Store or App Store for Jenkins only, right? It says that here you have over 2000 plus community contributed Jenkins plugin to support building, deploying, automating any project, right? Somebody said, I want Selenium integration, right? I hope the spelling is right. So technically you see the Selenium plugins available. So what you need to do, you just need to install the Selenium plugin on the Jenkins. Now, if I have to work with Python based projects and I say Python, then you might find Python related plugins accordingly so that you can build the Python code using Jenkins. Maybe a .NET related. So if I search for .NET related, you will find all the .NET related plugins available. Remember, by default, Jenkins was showing you only the build tools of Java because Jenkins is built on Java basically, right? Then you want some Python or Go or anything, there will be an essential plugin available, developed and available for Go. So that is what I'm trying to understand it, that you can extend the Jenkins capabilities, functionalities as per the requirement. Now that's why Jenkins is so famous out there, right? The kind of vibrant community that Jenkins has, you get a solution for everything that you look using Jenkins. Okay. You get all the newer plugins, updates to it very regularly. You can completely rely on this one. So it is an open source, completely free to use it, but you also have a very good community who supports everything on the Jenkins very properly, right? So yes, that is what we're saying it. Now we can start installing the necessary Jenkins plugins inside your Jenkins. Remember, initial also you did something called install suggested plugins, right? There it is already installing a few basic plugins which are required. Now you extend them as you need it again. Okay. Now I'm hoping that I'm clear on what is called Jenkins plugins and how do I understand them. If you're clear on that point, now why am I talking all these things is that I have certain plugins that will convert this code review results into a nice visualization format as well, right? Remember, there may be n number of build tools generating, right? There may be n number of code standards, different tools are available. You might get results in different formats, but again, not everybody can read this formatted files. So Jenkins is there for us to help in converting this code review results into a nice visualization format, more understandable format. So for that reason, I will install certain plugin here. So how do I configure something with Jenkins again? Always you go to a manage Jenkins on the left. Now on this system configuration, you see something called plugins, right? Add, remove, disable, enable plugins as you need it. So click on plugins. Now here on the left, you see something called updates to existing plugins, like your updates to existing installed applications, available plugins, like you're searching your Play Store, right? I can search here for existing Play Store like this one. Already installed applications, you can see that as well, right? These are all the installed plugins already. So if I go to the available plugins, and there is a plugin called warnings, I'll see, right? There is a plugin called warnings, or you can even search here something called warnings, right? This is a warnings plugin I'm talking about. Now see that here, it says the Jenkins next generation warning plugin collects the compiler warnings or issues reported by static analysis tools. Remember team, your code review is also called as static code analysis. The another name for this is static code analysis basically, right? So you may say static analysis tools or a code review tools, both are one and same thing. Code review standard basically, right? Says static analysis tools and visualizes the results. It has a built-in support for more than 100 report formats among all the problems it can detect technically, right? So it can be used with any type of programming, again, it doesn't matter. So that is the idea. So what I'll do on my Jenkins, right? I'm searching for this plugin, I select it, and then I say install on the top, simple. Now, when I install it, it will try to install whatever other dependencies if it is requiring again. So let's say it is trying to install some dependencies as well. That's okay for me. Now, once you install this plugin, then I can start configuring to visualize those results as well. Okay. So, okay, now you see it is successful. So what I can do is that I go back to Jenkins dashboard. I'll open my code review again. Now I reconfigure my job. Now remember team here, we understood a source code section where we give the source code URL. Build steps, what Jenkins needs to perform after cloning the source code. Now after executing the build steps, we need to take the results of this particular step and then perform some other action. Now that's why it is called a post build action here. You see that? Under the build step, there is something called post build action, which means After the build steps are executed, everything is successful. We take the results of this post build actions and then perform some other action. That is why it is called post build action. It says define what happens after the build completes. Like maybe you want to send notification, archiving, trigger other jobs, blah, blah, right? So I'll drop down, you see the various options available. But one thing we are interested in is compiler warnings and static analysis results. We want to take the results and do something else with it. So I'll select that option. It will populate some page for you. Then if I check the tool we are using is PMD, remember? The PMD sets. Now the report file pattern is nothing but your pmd.xml, the results we had it. Take this out. Okay. Then you can just leave the other options as they are. Apply, save. Then rerun it this time. Now, when I rerun this time, team, it will also perform the post build action for me after generating the pmd.xml. It takes that and then converts into a nice visualization. How do I know? Okay, second build is successful already. If I click on the build, now you see some option called PMD warnings, right? On the left side, you see something called PMD warnings link, or this one. I click on this PMD warnings. Now you see directly the results of those XML in a more better way, right? You can see here. Okay, that's good. If I come below, it says files that has a problems, the issues that you see here, right? Now, what issues it shows to you? It says that, okay, there is a properly loaded Java has some issue called unused code, empty code, like this. If I say property loader.java, 96th line having some empty code, something, right? If I click on it, it will even show you the code on the UI itself, basically. Now it says that a suggestion, avoid the empty catch blocks. Now, remember team, developer is trying to do some exception handling, but it didn't fill the code completely. Does it make a proper coding here? No, right? It identified. Can I identify by reading the code like this? No, right? The tool is identifying for you. Now you can tell the developer, hey, it's better you write a proper code, catch the exception as well properly, technically, right? So we ask the developer to fix such silly mistakes here. Maybe he might have thought I'll write it later, maybe forget about it. So it's better that we identify such issues at the early stage of the development before we deliver it, so that we can minimize the end user issues. Correct or not? Right or not? If I identify now, I can ask the developer to fix it. It shouldn't be identified after delivering the product, right? It should be identified at the early stage. This is how the code review will help us, right? You can see the code review will highlight all the issues available in every different file. Go with that and ask the developer to fix it. Simple. So this is what is the meaning of code review and how a Jenkins is helping us to perform the code review and visualize the result. If I simply use Maven, this is not possible. Jenkins is extending the way you actually perform the build code process as well. Okay. So this is the idea about your validate, compile, and code review, right? I want all of you to do the same things, right? By installing Jenkins and you all these things. Don't worry. Okay.
Okay. Now for this case, what we have done, we have used code commit from AWS point of view, right? From AWS point of view, we have taken code commit is one. We can use it for version control system. And the second one is about, we can take it up about what? Code build. Right? Am I right? So as part of the code build one, what we can use it? We can use build spec.yaml file. Agree? We have used build spec.yaml file. What it contains, guys? Build spec.yaml file. It contains steps. What prerequisites required, what commands you are going to execute, you can able to give it anything. It can be a Maven, it can be a .NET, it can be a pip, what you call as npm, anything we can able to use it. Yes, build spec.yaml file. Then apart from that, what is there? So once your build is ready, then I can able to take it up, code deploy part, how we can take it up. Then all these three options, I can able to run it through what, guys? Code pipeline. Okay, now let's move on. So code pipeline, it is pretty straightforward. Am I right, guys? Code pipeline is pretty straightforward to create, but it can use code commit and all. If you come down here, right? So see that here, code commit. You can have a look. You can get it here. So you can see we have a collect application. Here we have used this build spec.yaml file. You can have a look. Am I right? Yes. See, after that, what we have done, we have taken build section, right? Build projects. See, we have a demo project. So if you click on it, you can get to know, even we can able to perform independently. I mean, here itself, start a build, it can start the build like this. And we can able to see the status here. See, everything is there here. You got it? Everything is here properly is managed. See that here. Build success. Okay, phase complete, phase context status code, expanding base directory, assembling file list, expanding all this stuff. Okay, good. Next, what we have done, we just created a pipeline here, but the deployment option is also there. See that here, deployments. But you can see that pipeline, we have used this pipeline, but I think it's not there right now. I think we have deleted. All right. Now we'll try to do that one more example so that we can get to know. Okay, I'll take another example and then how we can able to take a code pipeline with the deployment options. Okay, in the last time we have picked up code build. Now this time I'll take a code deploy options. How we can take it up a deployment options. Okay, cool. Now I'll take two ways we can achieve it. Okay, we can able to create a deployment group. Where do you want to deploy your application? That is nothing but a deployment group. You can create a deployment group, nothing but a platform or Elastic Beanstalk. You can use it. You can use Elastic Beanstalk, or else you can go for EKS clusters. Anything you can pick it up. Okay, deployment group is nothing but your EC2 instance. Elastic Beanstalk is nothing but a platform as a service. EKS is also a platform as a service, or ECS also you can use it. Whichever you want. Okay, platform, you can pick it up. Okay, guys, cool. So once it is getting this right, how we can able to achieve it? Okay, let's see. So first of all, how to do that is I'll just come down here. Either you can create a code deploy group or by using option here, code deploy. See this here, deployments. This is one option. Okay, this is very easy. Yes, you have to follow the instructions to do that. See that here. So you can create one deployment groups. So you can go with the getting started and you can see create a code deployment. Same like a code build option. Or another option is if you come down, see for example, I have Elastic Beanstalk. See guys here, I'm just setting up the platform. Okay, quite interesting. Okay, you can get to know that. What is the difference? Okay, guys. Now see that here, easily deploy your web application in minutes. But it is providing a platform straight away. Instead of creating a virtual machines, installing something on top of softwares or packages and all, I'm just doing straight away. Okay, let's see that. See, can you read about this? Amazon Elastic Beanstalk, end-to-end web application management. Amazon Elastic Beanstalk, an easy-to-use service for deploying and scaling web applications and services developed with all these Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker and familiar servers such as Apache, Nginx, Passenger, and IaaS kind of servers it can be used. Apache server, Nginx server, Passenger server, IaaS servers, you can use it. Okay, guys? Yeah. Now let's see that. It's very simple. See, create an application. Okay, what is saying that? Web server environments. Run worker application that process long-running workloads on demand and perform. But this is run a website, web application, or a web API that serves HTTP requests. And then application information, application name. For example, my web demo. Simple web demo, I'm just getting. Okay, just come down here, guys. You see, automatically, whatever name you have given name, automatically it is creating environment. So what is environment, guys, here? What is environment? Why we are going to use a different environments like production, staging, pre-prod, dev. So to maintain your platforms, right? We are maintaining different platforms to deploy your application. To run your application, you need a platform. That platform is nothing but an environment. We're just naming us environment, dev environment, stage environment. As part of that, we are going to create a resources by using AWS services like EC2, ECS, Elastic Beanstalk, EKS, RDS kind of services, or DynamoDB tables, multiple resources we are going to create it. Perfect. That is one thing. Next, once it is done, you can see that you can my domain and environment description, something you can use it. I mean, just test environment. Okay, management platform, see that here. So which platform you're looking for? Node.js, Java, Docker, Python, Ruby, Tomcat, anything you can use it. Okay, I'm just taking simple one, PHP, a simple file, HTML file, I'm just picking up. You can use Docker, you can use anything, Python, Java, any platform. Okay, now let's see. Sample application or upload your code. Straight away it is providing the facility, but just taking sample application right now. Okay, just see that and simply say, I'm just giving single instance, free tier eligible, single instance using Spot instance, high availability, using Spot and on demand, custom configurations, you can use it. Okay, I'm just taking the first one and say next. Okay, just filling up, just like EC2 instance, guys. Okay, I'm just automatically creating use existing AWS Elastic Beanstalk service role and key pairs. If you want access, you can use it. See, you can able to get to know that if you want to use it. Okay, so simply next. And if you want to activate public one, you can do that, or else it will automatically generates. See that here, all this stuff, and simply next. Okay, guys. Simply, I'm just saying that next. Okay, and next. I'm going that everything is normal one. Okay, see everything what you have chosen. You can choose it, you can explore it. I'm just creating a platform, submit it. Got it. Right, guys? Good. Now it's going to create your environment. See, Elastic Beanstalk is launching your environment. Nothing but it is providing a platform. See, indirectly in the backend, it's going to use managed EC2 instances. You can have a look. Right? See, just observe this. Once it is done, it will automatically create. See. Once it is done, see, pending. My web demo, E8 IPB, something you can use it. See, created security group named using Elastic Beanstalk 1, create environment is starting, something like that, you can use it. Right? You can see that here. My web demo environment EBA, something you can use it. You can have a look. If it is everything is run, you can able to get it here. A simple application, sample one, it will get it. See, still is going on. Creation part, not yet completed. Right? See, pending, healthy. So once it is pending, is healthy, this domain automatically creating. That's what you are getting URL straight away, public IP address. See, it's okay. View access, it's done. Healthy. Now see, creating environment is creating, Beanstalk API, created security group, created EIP, Elastic IP address, waiting EC2 instance to launch. You can have a look here, refresh. You can see, automatically created my web demo environment. Indirectly, EC2 instance created. Okay, now environment health is transition to pending, instance deployment, all is done. Now you can refresh. Just refresh it. You got it done. A simple sample application is deployed. But now I need to deploy my application on top of it. Nothing but I need my own page here. How can I do this? Okay, so for that case, same like how we have used here. See here in the source section, repositories, we have right this part. You can have a look here. build spec, Docker file, pom.xml, source, all these we have. The same way, we have to pick it up another one. But this one, we can edit it. See, whatever it is coming, if you log into this host, yes, we can edit it. That is not, we don't want, right? Manually. All right. If I log into this environment, if I go into a particular location, I can able to get index.html. But that is not our intention. So whenever something is happened, modified in our code side, in our repository, should automatically change here. That is nothing but a deployment. Okay, so how can I do that activity? How can I do that activity? So for that case, we need a code here, appspec.yaml file, and some scripts we need. Okay, see that, guys. Okay, here, sample code, can you check it out? What is there in that? Okay, have a look here. Build spec.yaml file. Just a moment. Can you go into one particular branch called dev? Can you have a look? Different examples are there. Out of that, can you see this here? Index.html. If I this HTML page, I want to print it here. I want to display it here. This is my target. Something, if it is modified this page, automatically need to deploy here. I mean, on top of your Elastic Beanstalk. How can I do this? So for that case, what I'll do, I'll pick it up this code, for example. I'll clone into local, okay? Instead of using, even I can use a GitHub also as a version control system from CodePipeline, but I don't want right now. I'll take our CodePipeline, okay? So CD and AWS DevOps. Here, I hope already there. AWS, VCS and all, it's not there, okay. CD 10, we have kept here, right? Here we have, right? AWS collect. I'm just going to say make directory, or else I can clone straight away this CodePipeline, guys. Okay, I'll copy this. I'm just cloning. Just have a look what I'm doing right now. I'll go into this AWS CodePipeline. Okay, AWS CodePipeline, you can have it. Index.html, ECS deployment, dist and EKS, build spec.yaml file, cat, build spec.yaml. You can have a look, right? So what is doing that? Can you see that here? Not build spec, sorry, not build spec. What I need to do is, I need to use git checkout dev. Okay, I'm just switching to dev branch. You can have a look. You can see that appspec.yaml file. This is I'm expecting. Same like a build spec.yaml file, but what is doing that? It is stage by stage some task can perform. So what it is doing that? Source index.html file is copying into this location. After that, it is hooking like it is running these scripts. Start server, stop server, application stop, before install, application start. And it automatically starts according to the requirements. That's what step by step can perform. Now I need to pick it up this code. And then I need to run it. So how can I do that? So if you see that in the git remote -v pointing to the GitHub, now you can come down here, guys. Go into code commit section. Okay, right now what we have repositories, collect is there. I can create another one. Okay, you can give same name here. What we are using, what is the name? It is used AWS CodePipeline, for example. I'm just picking up same name, repository name. Okay, just create it. Done. AWS CodePipeline. This is one thing we can able to use it. AWS CodePipeline. Now you can just come down. So what you have to do in this scenario, you should be able to clone the URL, right? So you can take it up, clone SSH, copy this URL. All right. So you can just come down. So what we have used even for collect, git remote -v. Using SSH only, right? Same way I can use it here as well. AWS CodePipeline and git remote add. I'm just giving, for example, code commit CC instead of origin. I'm just giving the name CC this URL. Okay, guys. I'm just named it as CC. You can see git remote -v. Pointing right. So I have to use, instead of origin, I have to use CC. Then I need to push it. Okay, I need to push this repository. So what I'll do that git checkout. Okay, not required to do that. So git push straight away. Everything is up to date. Okay, git push CC and dev branch. Good. Right? We just pushed it here. See that? Come down into this code repository, pull request commits and branches and code. You can have a look at code. So it is, we have dev, all these points we have. Right? So we have this all test, task definition, license, index.html, ECS.yaml file, abstract.yaml, application.yaml file, everything we have. Now I need to use this as part of the pipeline, guys. Let's see. We can create a pipeline. Okay. So what you have done, just clone the repository from GitHub and I pushed into the code commit. Okay, nice. Now you can just come down here. What should I do now? I should create a pipeline, guys. Create a pipeline. Pipeline settings and pipeline name. So what should I give? Just a demo, a web demo pipeline. And then service role or existing service role. You can, your wish. How do you want? So automatically it's going to create a new one. Role. Role is nothing but IAM role to run your pipelines with permissions. Okay, next. Okay, just have a look, guys, here. So what it is saying that add source stage. Because if you want to perform some task, we need a code. So that code I can pick it up from these options. You can go for code commit, you can go for ECR, you can go for S3. I mean, according to your requirement. Bitbucket, GitHub, GitHub Enterprise Server, like that we can use it. I can go for AWS CodeCommit. Okay, I can go for AWS CodeCommit and repository name, AWS CodePipeline, and a branch name, dev. Right? Done. See, we are pointing that source and with the dev branch. You can have a look, guys, here. Change detection options and output artifacts. See, AWS Amazon CloudWatch events. Use Amazon CloudWatch events to automatically start my pipeline when a changes occurs. When change occurs, nothing but whenever you do something in the code commit, whenever you push something, automatically it will detect to trigger. Same like a webhooks concept. Or else, see that here, use AWS CodePipeline to check periodically for changes. But that is not correct. So first one is the right option. Even if you go for GitHub also, we are doing same thing. Straight away, this here options will be there. See that here, webhooks. So this webhook, see this, webhook allow external services to be notified when certain events happen. When the specified events happen, we will send a post request to each of the URLs you provide. This is the way we can able to handle it. Right. So now I'm just choosing this point. You can see next. So if you want to build an application, yes, you can also do that. If you have a Java-based application, if you have a .NET application, you can choose what we have chosen last time. So yeah, code build like this. And automatically project name will come. So like this also you can use it. Or else you can skip it. In this case, I can skip it because we don't have, not required to build it. So if you have another pipeline, you can use it. Skip it. That's what I just skip this build stage. If you want, you can add it, what you want to perform. Okay, good. Now you can see add deploy stage. Now what I can do that here, see guys, multiple options. To deploy, code deploy section, add deployment stage, you can see multiple options, you can choose it. You can see Elastic Beanstalk, S3 Publish, S Service Catalog, ECS. See, ECS is nothing but Elastic Cluster Service or S3 Bucket Content. Whichever Cloud Formation templates, you can run it. App config, code deploy, Cloud Formation stack set, apps work stack, anything, even code deploy. Anything you can use it. Out of this, for example, in our case, see, Elastic Beam Stack. Why? Because it is ready-made stuff. I'm just choosing this. See, nothing but I'm choosing the platform to deploy my code, my index.html file. I'm saying that as part of this stage, my HTML file going to be deployed as part of this platform. So here, application name is my web demo, and environment name is equal to my web demo.env. And what will happen is whenever something is happened here, right, you can see whatever code we have. All right, here, whatever we have index.html file, it's automatically copy as per these instructions. So index.html will go into copy here in this location, where www.html file. Now, once it is done, right, you can see, guys. Okay, next. Done. See how simple it is. So you have to add a number of stages. Then you can simply say create a pipeline. Now let's have a look. Now we are good. Congratulations. The pipeline web demo pipeline has been created. Okay, it is just created. Now it is starting, see this, in progress. Because by default, it is going to whenever you create it. So it is saying that failed insufficient permissions. Can you rerun it one more time? Release change, release it. Okay, let me pick it up. In progress. It is trying to cloning the repository. Good. The next step is, see, automatically deploying the stage. So AWS Elastic Beam Stack in progress just now. Now it is doing that. See, in progress. Now still, see, succeeded. The pipeline is completed. Source updated readme.html file something. See, 2D24, 2D24. Can you see that here? Code commit. Right? Code commit. You can just come down. So what is the commit right now? If you take it up here, right? Commits. Right? See, 2D24. This picked up or not? Latest one. Yes, 2D24. Now it's done. Deployment. You can see the history also. You can see that history. See, right now it is failed. First one. Second one is success. Execution ID. It will automatically show up what is you have done. So these two tasks, it's perfect. You can see the deployment options. What happened is get to know that. Okay, now you can come down here, guys. See, right now it is there, right? They just refresh it. See, automatically it is copied. Your content. Okay, in the same way, if you come down here, okay, see, index.html file is there, for example. If I modify something, see, for example, here, I'm removing this part, for example. I'm just giving only demo, for example. Okay, I'll just save this. Okay, guys, cool. Now you can see git add dot git commit. Okay, updated code for demo something. Then you can say git push. Sorry, it's wrong. So you can use git push cc dev. Right, I have to push into a code commit. Now let's see. Done. Right, you can see the pipeline is triggered or not automatically. You can just come down to the pipelines. Okay, 3 minutes ago it is executed. Can you refresh it once again? Can you refresh it? Okay, now you can see just now started. You can see automatically it's triggered. All right, automatically pipeline execution ID, AWS Beam Stack, done. So like this, we can pick it up. Now see, once it is done, in progress, right now is going on. It's pointing automatically Elastic Beam Stack. And it's going to update here. And now see, it's succeeded. You can just come down here, sample application. See, previously it is there working something here. Can you refresh it here? See guys, change or not? Your code is deployed, nothing but copied. How it is copying? Indirectly, it is referring this code base. You can see code and see appspec.yaml file. And here it is copying the things straight away. Right? Install dependencies, start server, stop server. So this is the way we can able to achieve it one thing. Okay. For example, another option is also there, right? As part of the pipeline section, see this deployment option. See that getting started. This is also another one. It is completely manual. See this here. AWS CodeDeploy automate code deployments to maintain application uptime. See here. See how I'm created Elastic Beanstalk. Same way, AWS CodeDeploy is fully managed deployment service that automates software deployments to compute services such as Amazon EC2, Lambda, or your on-prem servers. And AWS CodeDeploy makes it easier for you to rapidly release new features, helps you avoid downtime during the application deployment, and handles the complex stuff updating your applications. This is one thing. And even not only that, as part of the pipeline, if you pick it up, right? See, you can have a look here and just select it. You can edit it anytime. You can modify something here. See, for example, you said edit deploy. You can add another stage. See that here? Edit stage, add stage. See, for example, add stage here. So what I can do that, for example, CFN deployment. Nothing but CloudFormation deployment, for example. Now you can say add stage. Stage name is invalid, valid characters are A to Z and all. Say, for example, CFN, I'm just giving CFN_deploy. Capital letters, right? Okay, I think it is coming space. That's the reason it's getting. Okay, cool. Now add stage. Right, correct. Okay, now we just got it. Right, see, another one stage is adding here. See, CFN deploy. After this stage, I can use it here. Now here, whatever activity you want to perform, you can perform. See that, add action group. What task you want? We have used Elastic Beanstalk in the previous stage. For example, CFN and action provider. See, manual approval, AWS CodeBuild, add Jenkins, CloudFormation stack insets, CloudFormation stack sets. See, for example, CloudFormation. See, ASA specific, input artifacts, source, nothing but from CodeCommit, action mode, create or update a stack, delete a stack, replace a change set, execute a change set, create and update stack. Nothing but a CloudFormation template. Hope everyone know about CloudFormation templates and Terraform. And what is the purpose of using CloudFormation templates, ARM templates, or Terraform? Infrastructure as a code concept. Am I right, guys? CloudFormation templates or Terraform is nothing but a infrastructure as a code. Okay. Infrastructure creation as well as your deployment also you can do that. Right? Cool. Now you can see now custom resources. See, stack name. You can give some stack name. Say, for example, AWS SEB, something it is already there in my case, I think. Let me pick it up. CFN. Is there anything already? Can I check it out? Hey, update completed sometime back in 17. Elastic Beanstalk today. Today it is automatically used this stack. Update completed. Right. So, but even you can use different one as well. You can come down. Okay. You can see stack name, or if you are updating an existing stack, choose a stack name. Okay. Or else you can go for template, file name, and template path you can give it. Okay. For example, artifact name, source, file name. You can have a look here, guys. Code commit section. You can see that source, repositories, AWS CodePipeline. So can you have a look? What is this CloudFormation template? This is an ECS deployment. You can take it up, ECS, EKS, Elastic Beanstalk, anything. See, it is creating a cluster, ECS cluster, and I'm deploying this task definition called Nginx. But I'm deploying one Nginx container on ECS cluster with this service. If you read about ECS, you can get to know that. Okay, ECS is a cluster. On top of it, I'm going to deploy a containers, nothing but Docker containers as a service. So that service is pointing to the task definition. The task definition is what image, what port number, all will be taken up, and where it's going to deploy on this cluster. Okay, so pipeline section, what you have to do, you can simply say ecs.yaml file. Yes or not? You can have a look here. ecs.yml file. You can use this option. Okay, cool. And then capabilities. You can use by default, choose is all. No problem. That's what you're giving some role. You can see ECS role. You can use these options, fair enough. All the optionals. Then I'll choose the name for the output of this action. Okay, ECS. Then done. Right? You can say done option. So what is there? Is this missing anything? Okay, stack name. You can use ECS deploy. You can give some name. Automatically, it will take it up. Say done. Okay, guys. So this is done. We have done. Okay. Yeah, just save this. Nice. Now, this is one thing we can use it. See, nothing but what indirectly you have to choose the option. What task you want to perform as part of the deployment, as part of the build. You can add the stage and you can perform it straight away. Now succeeded, right? Now you can run the stage, release change, for example. Straight away I'm running manually. Now let's see. Now the code will get it and it will deployment will start. After the CMN deployment also it's getting success or not, we'll see. Okay, cool. Now this stage also you can skip it. If you don't want, you can delete also. Straight away you can add it. So that's your choice. Right? Okay, let's see. It is failed. Maybe something, maybe errors or anything, but see the view cloud formation template. Just now execution started. You can see the cloud formation template section. Can you refresh it? You see ECS deployments. Maybe permissions not sufficient. That's the reason it may be failed, but see rollback completed. But it's executed. See that. You can just come down. What is error? You can also get to know that. See what is an error? Events rollback. ECS deploy. It is failed something resource creation cancellation. So why it is? Because cloud formation template, if one resource creation failed, automatically everything is rolled back. There is an advantage. See, it is trying to creating ECS deploy, execution role, cluster, log group, container security group. Now, what happened is execution role. It is trying to creating AWS CloudFormation is not authorized to perform get role on resource deployment example role because no identity-based policy allow the get role action. This execution role don't have a permission to run from code deploy. Nothing but you have to come down in the pipeline section. You can just edit it. Whatever we have used here, this part, you can edit a stage. Here you can check it out what we have used. Okay, you can remove it once again. You can add it once again, that part. Okay, ECS and provider is CloudFormation, right? CloudFormation. And then is a specific. And you can, these all things are correct. Action mode. See, creator update, stack name, ECS deploy. You can, time being, existing one, you can delete it. You can delete this tab. Because already existed. So you have to automatically just refresh, done. Now you can come down once again, give that ECS deploy, same thing. Artifact name, template, and file name, something, ecs.yml we have used, right? Done. And see this here, template configuration, but capabilities and role name. So this is important here. This role is not sufficient. This role is not working as expected. So you can use all options plus role name. You can use ECS-CFN and all these fine, but take it up this ECS-CFN role, guys. Come down here, services, or else IAM. All right, IAM. You can come down to the role section. You have to modify that role. That's all. If that role is done, see, multiple roles will be there. In that, what is the role we are looking for? The permission point of view, ECS CFN role. Can you search it out? ECS CFN role. But we don't have all permissions. Only EC2, S3, ECS, CodeDeploy role, Elastic Beanstalk, and all will be there. But other roles are not there. So what I'll do that, add permissions, attached policies. Something like that, you can use it. Okay, so you can say attach policies. So what is error coming? Role permissions are coming, right? So we can say role, get role. Okay, just search. Is there anything? So that relevant role you have to give it. All are role, right? Okay. I can give for time being. Is there any admin part? Can you check it out? Yes, I'll give this as time being. Okay, that relevant one you can give it. See, AWS CodeBuild admin access, AWS Code Service Deploy, like that you can. But I'm just adding this point. Time being, you can add permissions. Okay, successfully attached here. So we have attached that policy. Now you can come down in this code pipeline. As usual, you can choose that same thing. Output file name, file generated by this action, and just done it. And save this. Cool. Okay, now release the change. Now let's see if this time it's going to create or not our pipeline here. We can say CFN, Cloud Formation Templates. Okay, not yet. We reached that location, right? See that. It's progressing this part right now. Like this, you can take it up anything. Even you can do the code deploy. You can take the EKS deployments. Anything we can pick it up and we can deploy it over here. So that part you have to, whatever kubectl commands, right? You can take it up through abstract.yaml file. As part of the abstract.yaml file, you have to run it. You can able to get it straight away. Okay, once again, it is failed. Action execution failed. So why it is failed? You can have a look here. And refresh, see, automatically is coming. But it is something is getting problem. It's okay. ECS deployment, if you check it out, events, where it is failing, and log group creation. Now this time it is failed a different one. See, log group creation is already exists something. Yes. Log group name already there. Which name it is? Deployment example log group. This is already there. That's the reason it is failed. Now what you have to do, guys? You have to come down, say CloudWatch, right? CloudWatch, you can go, you can able to find the log group. You can have a look. Log groups. It is already there, it is saying. Which one it is? This part, you can have a look. See, it is already there. So you have to delete this option. Delete log group so that next time it will work 100%. Next, cloud formation templates. You can stack deploy. You can say delete. Yes, it works. You can have a look. Refresh. And even code pipeline, I don't want to run this deployment stage. So what I'll do that edit option, right? So this is I don't want. All right, this is I don't want. So you can just edit it, delete it. That's all. Straight away, it will take it up. It won't take much time. So save this. Okay, guys. Now release the change. It works. See, it's progressing right now. You see, it is not taking too much time. All right, you can see the cloud formation templates, refresh, right? So it's see, still going on in progress and details. I think we would have deleted that part, I think, right? So that's the reason it's getting problem. It's okay, events. So this time what is an error? See, all are deployed. See, cluster is created, log group is created, execution is created, execution group, even log group is also created. Done. But after that, when it is failed, it is saying that does not exist subnet ID. So whatever it is referring manually as part of the code, in the code section, we are using one subnet ID. So that is not working. It's okay. If it is there, it will success automatically. So it's not a big deal. Okay. So that's the way it can work and we can able to delete it. Cool. Now it will automatically check it out. Even this one also, if you delete it, right, automatically that relevant resource is going to be deleted. You can see delete in progress. Automatically, even if you come down, this resource also going to be deployed. See, automatically deleted. So automatically it will delete. You can see the services and even Elastic Beanstalk. See that it is automatically deleting time because we have deleted this CloudFormation template in progress. You can see events. So delete completed, Elastic Beanstalk launch. So this is the way we can able to use it, the code pipelines plus code deploy. Okay. And once it is completed your work, what you have to do? You have to come down to the pipelines. For example, here, you have to delete it, this pipeline. It's important. If not, then delete like this. And say delete option. And in the even same, even here, so build projects, whatever we have, if you don't want, you can simply say delete option, build project, delete. This is always recommended, guys, after your work. Right. So it's done. Now build project is done and your source is done. And you can see the pipelines also we have done. It's clear. Okay.
Just a quick info guys, Intellipaat offers an AWS DevOps certification course. With this program, you'll get trained in AWS services, CI/CD pipelines, infrastructure as code, containerization with Docker and Kubernetes, monitoring with CloudWatch and much more, all through real-world projects and case studies. The course is taught by certified trainers and industry leaders who guide you with hands-on labs and practical assignments, ensuring you're fully job ready. With this program, Intellipaat has already helped thousands of learners transition into high-paying DevOps roles, and you can check out their success stories on our Achievers channel. Link is given in the description below. So if you're looking to build a strong career in AWS DevOps, this course can be your perfect launchpad. Visit the course page link in the description below and take the first step towards becoming a certified AWS DevOps engineer.
For going to start with anything, right? Let me tell you, right, most of the services or most of the things which we are doing hands-on, you will not be able to do, right? The reason behind is these are the kind of AWS native services, cloud native services, right? Entirely with that DevOps course, you have gone through multiple processes, DevOps timelines, right? The life cycle, like let's say CI/CD is the part of it, right? So what tool we use for CI/CD, right? You guys know it is Jenkins, right? Position, it is this, right? For version control, it is Git and GitHub, right? Okay. So that entire process and of storing, building the project and CI/CD, when you have used these kind of tools, the thing is now these are the open source tools, these are the independent tool. If you're using Docker for containerization, it does not mean that you have to use Jenkins only. You can use anything else. You can use GitLab CI/CD, right? So it is a group of multiple tools depending upon your choices, what you use, right? So when it comes to cloud as a platform, right? We're using AWS for virtual machines, EC2 instances, right? And to make the use of my, service, my tools, right? Jenkins, Docker, all these kind of tools. Okay. Now, so these kind of cloud computing services, they found one opportunity, right? Just to, work upon this domain of DevOps, right? So now what all jobs and what all things you do independently, we have this thing as well into our cloud computing platforms. If you are using DevOps. Sorry, if you're using Azure, then we have Azure DevOps, where you can just go ahead and use, you know, dev.azure.com, right? And then similarly, we have GCP, right? Google Cloud Platform, right? So it also has its different set of DevOps services. Now we have AWS, right? So in AWS also we have these set of services, right? Okay. So these type of services are there, right? Now what happens is they are, very native to the platform, right? So if you will ask me a question, sir, in sources where we will be storing the repositories, what thing we will be used, right? So what kind of actual architecture, what kind of technology we will be using? So it is exactly same. It is based upon Git and GitHub only. Same commands, same technology, just the interface is different, right? So when it comes to, cloud native services, right? So these are the cloud native services where CI/CD, deployment, pipeline creation, version control, everything you will get in one place instead of going into 10 different places, instead of, using, tools here and there, right? But this is not something which companies go ahead and prefer, because this is not something which companies go ahead and prefer. Companies do work upon this, but yes, they parallelly also prefer working with, the independent tools. Rashmi says why. Okay, Rashmi, then, to reduce your dependency, right? Now, Rashmi, you're using, this cloud native tool, right? I'm not saying you're using AWS, Azure, or GCP. Whatever you like, you can use it, right? But then your cloud computing activities, your tasks, your DevOps related task, everything is entirely based upon one company. You're depending upon one company. If tomorrow AWS shuts down or Microsoft shuts down or discontinues the services of, AWS web services, or let's say, Azure DevOps services, then there would be a very big gap and very big, a latency in your work, right? So what we do is, and also these offer us very limited features and functionalities, right? Now, so but when it comes to Jenkins, or not only Jenkins, any open source tool, right? They are very well maintained by different administrators, right? Administrations, different companies. So, and along with that, you have lots and lots of transparency, right? That, okay, if that is the issue, Jenkins now itself has, before 1 year itself, they have given us the, you know, update that now, you know, now you will not be able to use Java 17 anymore. You have to use Java 21 from the next year, right? So that is what it takes, like when it comes to. So in short, just I wanted to say the dependency is very less to one platform, one service, right? Using multiple service. Now, if let's say I want to use a code commit, everything is fine. But this pipeline services I'm not liking, right? I cannot integrate it with some other tool, right? But when it comes to independent tools, right? I can integrate my GitHub and Jenkins, right? I can, if let's say I do not like Ansible for configuration management, I can use Chef. If let's say I do not like Chef, I can use Puppet, right? So there I get lots and lots of choices, lots and lots of things, right? And once again, lots and lots of features and functionalities, right? Which hardly which these kind of AWS services offer. Yes, they do offer good services. They do offer, things which can be done. And some are, which are much more easier to use as well, with much more graphical work intact. If you see Ansible, Docker, Kubernetes, right? Much graphical, dashboards, much graphical dashboards are not there, right? So, but when it comes to Jenkins, yes, you have the graphical dashboard GUI. Similarly, we have everything graphically here as well. Now, so coming to your question, AWS Code Commit is no longer available for new customer. So yes, you can see the warning here as well. AWS Code Commit is no longer available to new customer. Existing customer can still use Code Commit and continue the services as normal. Yes, so you can, not use it if your account is created after July 2024. You cannot use it, right? But you know, if your account is created, before July 2024, you can definitely use it, right? Now, so all we are not doing it because just because it is a part of the course. Maybe if you are joining any company in future, right, and it is working upon code commit, you can definitely go ahead and you have the idea of how it works, right? After after you see me doing the tasks and everything, you have the idea how things are being done. At the real world, how things are being done. Let's say in any open source tool and how it is done in the cloud native tool, right? So you will be having that clarity and that idea, right? First thing, and secondly, if you will be having just some visual appearance, some you know some idea about how AWS code commit works, right? Then you will be good to go. And if let's say Azure DevOps services you're using, Azure DevOps, GCP, right? These kind of services you're using. So you will be much more familiar with cloud native services. Fine. So when you will come and you will click on create repository, right? Let's start from very scratch, right? There will be a button of create repository, right? Now, once you come and click on create repository, now, okay. So once you come and click on create repository, you'll find the interface of this sort, right? Exactly the way you used to create repository in GitHub, you have to create the repository here. Let's say today is 27, right? 2707 repo. Okay. 2707 repo is the name which I have given. Description again exactly in the same way, you used to do in GitHub, right? You have to do here, right? If you want, you can add it. If you want to convey something meaningful, you can add the description. Otherwise, just leave it as it is, right? Remove everything, right? Tags and all this. Tags, if you want, you can just add it just for if you want to add some value and if you want to map it with something, right? So just everything is as it is. Simply give the name and click on create. So repository created successfully, right? So this is how exactly things work, right? So now you have successfully created one repository, right? Now, if you come down, you will see HTTPS, SSH, and HTTPS GRC, right? Let's ignore this for now because these are the two main ones, right? So how are you going to? Who is going to tell me what are these? What is this HTTPS and this SSH? Protocols, exactly, ports, mainly the connection types, right? So when you're working with when you're working with your terminal, right? So before now, as we have created the repository, let's go ahead and create this EC2 instance. So right now, what I'm doing is I'm just creating one new instance. So Ohio, let's go to North Virginia. Launch instance. Instance. So let's go take this in one stretch only, right? If you guys are more comfortable in that. So I'm using 1 to 22. Right now. So let's say I've taken this t2.micro. Key pair if let's say if anything is there. Somewhere. Right. Now it's default. Done, right? So let's say not one, I've created two instances for now.
Okay, so far I haven't just created, I have just came to code commit. I've created one repository, right? And after the repository, I'm just, I've created 2 instances. Now, as I've created the instance, right? Now, so how will I connect this repository which I created with these kind of instances, right? There are 2 ways. One is HTTPS, other one is SSH, right? How will I connect with HTTPS interface, right? Okay. First of all, so if you guys are not having any IAM role with which you have allocated the services and allocated, the access to different services and things, what you can do is you can create an IAM role, and I hope so far all of you would be aware how to create this IAM role, right? So this IAM role, you can just go ahead and you can create a new role, right? Let's say for my role, there is, this is summer role, right? Administrator would be there, right? All these, permissions and all these policies would be attached, right? Exactly the same way you have to do as well. Correct? Now, so if it is there, if it is created for you, what you can do is you can just go ahead and create security credential, right? Now, the reason we are creating security credential is, let's say this is access key and you came to AWS code commit credentials, right? Now, here also you will find 2 things, right? One would be SSH public key code commit, one would be HTTPS git credential code commit, right? For AWS code commit. This is exactly the 2 ways of connection, right? Now, repository is there. This is what I have only created, right? Let me delete it. I will deactivate it. It's deleted, right? Click on generate credential. Now, this credential has been generated automatically, right? Username and password, right? For HTTPS, right? Now, for HTTPS, if you will see, you yourself can see the steps how to work with it, right? So right now, it says create a grid credential for your IAM user. If you do not have IAM user, download the credential and save them in the local location. This is what I have told you. Create IAM user, and with that create credentials and save it, right? So I'm using, the repository git clone. Fine. So I'm cloning this repository, right? Git clone and repository link, right? From there, I got the repository link. Enter username. And what username will you give here? The username which I generated just now for HTTPS connection, right? From IAM user, I went to the security credential, right? And then I did have generated it, right? So exactly same way you have to generate the username, enter. Now password. Password you will get it from here, copy it and save the password here as well. Enter. Now it has given me a warning. You seem to have cloned an empty repository, right? Can anyone tell me the reason for this now? I guess this is very evident, right? That why is it giving me a warning? After creating a new repository, I have explained you 2 ways of connection, HTTPS and SSH, right? Now, for that, I have created 2 instances. You can take local machine also if you want, wherever you want to perform it, right? So 2 instances I've created, right? Now, and as it is written here only, that git credential, there should be an IAM user that where everything should be allowed, right? So that's the reason I asked you to create an IAM user, go to security credential and create the key for HTTPS and SSH, right? Let me tell you how we have done that, right? Go to security credential, scroll down, click on AWS CodeCommit Credentials. Once you will click on it, there will be 2 options, SSH and HTTPS. Right now, we are performing HTTPS connection. So you will generate one HTTPS connection and you will get an interface of this sort with username and password, right? Now you have the username and password for HTTPS connection, right? So when you will copy this GitHub repository link from HTTPS and paste it in one of your machine, it will ask for username, and exactly the same username you will copy from here and paste it. Same password you will copy from here and paste it. Right. Now it is perfectly done. You appear to have cloned an empty repository. If I do ls, repository is cloned, but it was just a warning, right? So cd 27, right? Now, once I am in this repository, right? Once I am in this repository, I do not get anything, right? Okay. So it is empty, so you cannot access anything, right? So far I have done the connection via HTTPS, right? Now, once the HTTPS connection is done, right now you won't see any files there, right? Okay. So if let's say I create one file, so the command for creating a file is touch one.txt. Okay. Inside this repository only I'm creating one file. Now, this file is created one.txt, right? Now, so once a Git file is created, right? Or you can say, what is the very next step, right? So the very next step is to stage it. Git add one.txt, right? Once the staging is done, now we go ahead and we commit it. Post commit, right? So it's done. The very first commit is done. Now git push origin master. Now again, it is asking me for the username. Same username I will be copying, pasting it here. Password. Now to the master branch, it is done. If I will do a quick refresh in AWS CodeCommit Services, I got a new file that is master.1.txt, right? And that has been added from this machine. Correct. Now, let's say I'm adding something from with GUI, right? So let's say click on add file, upload file or create file. Let's create one, right? Now it's not like adding how we used to do in GitHub, right? Because in GitHub, what used to happen is we have series of things, we have series of statements, right? Where we go ahead and add, like, our file content, right? But there was very less information communicated. The reason behind is because already we were logged into GitHub, so we need not to give our main information again and again, right? So this time, let's say I'm creating a new file. I'm creating it from master branch, right? So let's say I'm getting, hi, this is manually created file. Manually created file. Now file name. What is the name of the file? So I have to give the file name. Let's say 2.txt. Okay, 2.txt. Now, so these were the informations: author name, email address. Let's say Samay. Email address. Let's say abc@d.com. Commit message. Let's say second commit. Now if you commit the changes, this is the file which has been created manually, and this is the commit report, commit part, commit ID, right? Now, come here, come to your repository, go inside the repository. Now there are two files, right? If I go to file number 1, it is entirely empty without any content. Well, it was created from that file, from that part, right? And this is the second part, which contains which contains this part of creating manual file, which I've added manually from this part of code commit repository, right? I've added it manually, right? Now, so let's say, okay, cloning part, will come to it later on. And this part also will come to later on. We'll come to it later on, right? First of all, let's go to repository and see. Okay, fine. Come to the repository and see the other type of connection, that is SSH. Okay, fine. Before connecting to SSH, let me explain you the content of this file. So far, what you have understood is from VM, from my EC2 instances, I have added 1.txt and manually I have added 2.txt, right? Both are under same repository, both are there, correct? Now, pull request, I'll tell you later on. Let's come to commit. Now, two commits are there. One says first commit because when I have added it from my instance, right, I have given it first commit only. That's the reason it is giving me first commit. Other Ubuntu, committer Ubuntu, right? Why? Because I have done it with EC2 instance, and EC2 instance I have not added any user. That's the reason author is Ubuntu and committer is Ubuntu. But when I did it with manually, with second commit as the commit message, and I given the author as Samay and committer as Samay, right? Okay, fine. So it is showing me Samay as the user, right? Now, commit visualizer is just, if for now it is a simple kind of diagram, but later on when you will see, you will get to know that when multiple files are being added, when multiple files are being done, right, then you will, this kind of flowchart, when multiple branches are into play, then you will get to know that these kind of flowcharts are the one which are creating the actual difference, right? Now if let's say I compare two, right, so there's nothing to compare because it's the same branch only, right? Now branches, right now we do not have any other branch, right? Okay, only one master branch is there. Let's say create a new branch, right? So here also the same principle follows, that a child branch is going to inherit the parent files from the parent branch. Let's say I create develop branch. I'm creating from master branch. Create branch. Okay. Now the branch is created. So if you come to this branch, you will find and you will see the same content, right? Same content of 1.txt and 2.txt, right? So exactly this is how it is being done. Now come down, do ls, now do git branch. You won't get anything, right? Now how will I come to the come to the latest part? So what we are going to do is we are going to do git clone, right? Exactly the same way we used to do it there. Why? Because right now we have not used git any kind of service, right? A pipeline service. Now once you do it, you will find 1.txt here also. You will find these two files. Now git branch. Okay. See, so it's a glitch that it is not showing the branch, but when I will do git checkout, it will definitely change into develop branch. Fine, switch to the new branch, that is develop branch. Git branch, you will see the content. Right. Now check out master. Okay, fine. This is how exactly it works for the code commit part. how we have, added the file and how, multiple branches are created with GUI also. So this is how it works. So is there? Yes, because right now, Kshitij, like earlier when you have studied Git and GitHub, right? Then you might have also, seen that, very basic things we have to do, right? Pull from Git clone, Git pull, everything is done from the URL only, right? Because that was the very basic and the very manual step, right? So for now, here also we are doing everything manually only for now, right? Once we will be doing with pipeline and this deploy part, then this thing will also be automated. Okay. Fine. Now the other instance, let's take it for SSH connection, right? Let's create a new repository, or rather, let's do it with SSH only, right? Let me create a new repository. Okay. Let's say I'm creating 2707, right? Simply, I have created a new repository. A new repository I've created. Last time what we did was we have worked with with HTTPS, right? Now this time we are going to establish the connection with SSH, Mac OS, Windows, Linux, right? These kind of operating systems are there. However, for every operating system it is going to be the same thing we are going to follow. I don't know why they have given different type of different bifurcations, right? But still, what we are going to do is we are going to follow from here, right? Okay. Now, so let's say this is my fine. So when you will create SSH key, right? You have to, put the public key here as well, right? How when working with Ansible, how we used to do create public key, but I'm doing with SSH the simplest method. SSH hyphen keygen hyphen t, right? Now hyphen t is for the type, right? What type of key I have to generate, right? So if you see, when you are working with Ansible with 1 to 24, right, there the encryption type is different, right? So Hariom, one more thing, and rest of you also one more thing you have to add, that is SSH hyphen keygen hyphen t and the encryption type RSA. Generating public key, enter. Fine, so it is done. ls cd.ssh. Now sudo cat, right? But here we are not going to paste it in slave part, right? Here we are going to definitely we are going to copy. Is some mistake, I think, I guess, yeah. You have to copy this part and you have to paste it. Exactly. Now once you have pasted, you will do upload SSH key. Now you will get SSH key ID, right? Come to your repository. Okay. Now once you come to your repository, right, what will happen is you have to, go inside cd.ssh, and you have to create a like you'll be finding one config file, right, without any extension. In the config file, you have to just make some changes. So let's do it. ls, right, sudo nano config. Now config file, I will copy this part, I will paste it, ssh key id here. So what I will add here is the exact ssh key id. Now id underscore rsa. This is the name of the private file. Control S and Control X. Now, what you have to do is you have to do config, and then this part, this thing you have to do. And why will you do it? Oh, file is not there, I guess. Exactly, Arul. I guess we have created it inside, some different repository, right? So no worries, I'm creating it once again. Copy it, paste it. Now inside .ssh, what you have to add is you have to add this part. What's the name? ID underscore RSA. Fine. So let's Control X. If you do ll, you will see that this config file, every user and group has the read access, right? But that should not be there. What I have to do is I will be copying this part and I will be pasting it once again, right? So sudo now ll, you can see only, now the permission has been removed, correct? Now what you have to do is you have to copy this, come down, paste it here. Yes, give the permission. Now you can see you appear to have cloned a empty repository. That is exactly what we have discussed before, right? I'm doing it branch here right now. I'm in develop branch, right? Let's do git switch. I'm just switching to the other branch. And after switching, what I'm doing is I'm just simply, do develop. I'm just adding some extra files, right? Now git, sorry, before that, touch new.txt. Fine. And now git add dot git commit -m all git push origin develop. Now password. Fine. Now guys, you have to see the password is not there, right? Okay. I don't think it is going to work, right?
There is one company that is
Fine. Now, since the develop branch is done, it is pushed perfectly, right? So if I will come here and do a quick refresh, reload site, just now it was done, and latest commit is all. Earlier it was first commit, now it is all, right? So if you come to the code part, and in master there is 1, 2 and new.txt, one extra file is there, right? Now what I will be doing is I will be going ahead to the branches part, right? Okay. Now this branch create pull request, right? Now I'm creating the pull request from master branch, right? Now when I will click on compare, it will tell me is it mergeable or not, right? So this is something which helps me a lot. Why? Because if you guys are aware about merge conflict, so merge conflict occurs generally because of these kind of mistakes, right? And we are not into knowing it whether we are able to, whether they are mergeable or not, whether the merge conflict can be done or not. So here you can see it says mergeable, that there is no merge conflict between a develop and a master branch, and it is mergeable, right? Now so it says title is all, right? Now so let's say new merge, right? And here you can just write it all, right? Okay. Now if I will merge, what will be the changes? So the changes would be a new file, new.txt will be added, right? So if I will do create pull request, it says no merge conflict, details, activity. Now in this activity, it will just let me know about the changes only new.txt is added. Commit, this is the sorry. This is the commit. Click on merge. Now these are the kind of merge strategies, right? What kind of strategy you want to proceed, right? So delete source branch after merging, or with merge offset, right? Three-way merge, squash and merge, fast forward merge. So fast forward merge I will do, which is the most generalized kind of merge technique. Now what will happen is, now it's done. Come back to my master branch and see the merge has been done. You can do it with GUI also, but also with CLI also, but now I have done it with GUI. That means it's so much compatible that you can do it with help of GUI as well. Now if let's say in future you do not need any branch, right? Let's say right now only one branch is there. Okay. So if you want to delete, you want to see the last commit, right? In last commit, what happened was, so in last commit, a new file was added, right? So exactly, if you want to delete this file, this branch, select delete branch, right? So it cannot be undone from the console. However, user might continue to copy their branch in their local repositories until the next time they pull changes, right? So you can just make the changes here itself. So this is what all the parts which we used to do in GitHub, Git and GitHub, we are doing it here, right? So this is when we use this is what we do when we use for creation of a repository. Delete the repository, delete it from here. Now so if you have noticed one thing, when I was doing this pull request, so no approvals were there, right? So anyone can change, anyone can make any kind of request, right? So no approvals were there. So if let's say I do it from master only, same, right? So you can add some rules also, create some template rules, so you can add regarding the this part, right? So that there isn't any mistake after merging. Let's proceed towards build artifact, code artifact, right? Where artifact repositories are there, right? So AWS Code Artifact is a fully managed artifact repository service that makes it easy for the organization for any size of security to store, publish, and share software using their software development process, right? And someone was asking me, is it free of cost, right? So accordingly, one by one, you can come and you can see what are free of cost. First 2 GBs for a month are free of cost, then 0.5 per GB, right? I guess Deepak, you were asking, someone was asking me regarding the payment part, right? So this is where you can check it, right? Yes. Okay. So some parts are free, some parts are paid, right? That is what I told you at that time. So here you can check that how much part is free. Okay. If you're having it in your console. Right. Now let's discuss in a proper manner, according to you guys, what is code artifact and why are we using it, right? So before coming here, let me give you an situation before coming to code artifact. Let's say you imagine you are building something, right? Or your team is building something. Let's say you are building some app or website. Okay, so you're building something, right? So to build it, you need some, you can say, let's say, let's take a very basic example, right? You are building an entire, you can say, campus, right? So build it, you need to have some, building blocks of it, right? You will be creating with cement and blocks, and bricks and all that, right? So the bricks and the, you can say, these kind of the bricks which you will be using are like the libraries and tools for any application. Let's say application or website you have to create, or just make it similar to an kind of a campus, a campus you have to create, right? So for campus creation you have to build different kind of uh, places, right? For that you need bricks, concrete, right? So exactly they are the very important unit, right? So exactly for a website or for an application, you have to use some software tools, some software packages, some software libraries, right? But you know but that code, as someone has already written that, so I need not have to reinvent it, right? So I do not have to reinvent it. If let's say, talking in DevOps language only, if let's say we can say, no, uh, okay, fine. Let's say my company is there, just using Ansible. Your company is using Puppet. Someone's company is using Chef, right? My company is working on WordPress. Your company is working upon Munstack, right? So all these things, when it comes to the when it comes to the comparison, right? So they kind of save their software packages, their resources, because if I'm working on Ansible, if I'm working on WordPress, I'm not going to code or create WordPress, right? Someone has already created it, coded it, and I will be just using it, right? So that's why you can see repository to securely store, publish, and share software packages, right? So mainly it is a kind of repository which is used to store the kind of software packages, right, which your company is using, right? So let's say, npm node package manager for JavaScript, pip for Python, Maven for Java, right? So these kind of, actually, uh these kind of dependencies are for the project, right? So what is this code artifact? AWS artifact. So it is a private storage space, right? For your code packages, right? So let's say a specific plot is there, right? Only you and your family is going to stay there, right? No one else, right? And so your own personal belongings, your own things which are very important to you, you will be storing it there, right? So exactly, AWS code artifact is there. It stores, and it securely stores, right? The private kind of codes is, let's say your private code is there, some software package is there, so all this we store it. I hope now you have the clarity what is code artifact and why we use it. Even better example, if I can give you, let's say you and your team, like, everyone is all of you are the restaurant, right? Now you have to create some dish, right? That dish is the application. How will you create any dish? You will create dish with help of ingredients. Now, to create that dish application, you will use ingredient as software packages, right? Now, how will you get ingredients to create the dish? You can either go to supermarket, right, where everything is available, but can you trust that this brand is trustable? In supermarket there are so many brands, right, that you will get oil and wheat for these many brands, right, but are they trustable? Are all of them trustable? No, right? Some would be good, some would be average, some would be bad, right? So for we have code artifact. Code artifact is that private kind of pantry or private kind of storage space for you guys. Only your company people can access it, and only trusted people buy it, and what all things you access there is trustable, right? It's just like a franchisee, right? So code artifact is that for any application, if you're accessing any open source or the new web software, right, you cannot directly go and copy it from internet that you are downloading some virus, or some kind of which can later on cause a security issue. What you're doing is, with code artifact, we are just copying it uh, from your own house, from your own company's artifact. So everything is secure and well tested, right? So this is the most easiest way, I think, with which I have, with which I can tell you. And how do we create it? Exactly the same way. Everything is same. Okay, fine. So AWS build and test code with elastic scaling. Pay only for the build time use. Right. Now, let's say I'm having this code build is a fully managed continuous integration service that compiles source code, run tests, and produces software packages that are ready to deploy. With code build, you don't need to provision, manage, and scale your own build server. Code build scales continuously and processes multiple build concurrently, so your builds are not left waiting in queue. Right. So this is a kind of Jenkins alternative, right? Where we go ahead and we run these our projects, right? Now, so create AWS code build, right? Now you can just create the project of your own. Let's create a project. Now, so fetching the project, like let's say you have done capstone project 1 yesterday, right? You have fetched the entire project from GitHub, correct? Now, if let's say you do not want to use code build, you want to use GitHub only, or S3, or whatever you want to use, just to save the kind of process you're having, right? The project you're having, right? Whatever you want, you can use it independently. So let's say project name is 27 July. I'm creating it as a default project. Now, this is the source one, right? Source is exactly from where you want to fetch the project. If let's say the code commit which we have been doing so far, you want to pull it from there, you can pull it. GitLab, you can use it. GitHub, you can use it. Amazon S3, you can use it. Let's take it as GitHub, right? Now, GitHub repository link you will be adding, right? So GitHub repository link you will be adding. Let's say I'm going to any GitHub. Fine. Let's say I'm copying it. I'm pasting it here. Okay. Now, repository in my GitHub account. Okay. Now, if you want, okay, let's ignore it for now. You have added the repository, right? Okay. GitHub username repository, right? So they have given me the format also. You have added the repository, right? Single build, multiple build. So this is a webhook, right? So yes, if you're using with GitHub, you can definitely integrate webhook, because here you're using GitHub in it, right? Okay, fine. So now, like rebuild every time the code has changed and pushed to the repository. So it is exactly the same thing which we are doing with Jenkins, right? So for anything, if you want more information, you can just go directly with the documentation, right? Now, environment depends upon you, like what are capacity of machines and images you want to use. EC2, Lambda, container, instance, right? Wherever you want, you can run it, right? So this exactly depends upon you, how you want to go ahead and how you want to proceed. Let's say I'm using Ubuntu and everything is done as it is, right? Build spec. Now, what is this build spec? So build spec is a file. It's a specific file. If you come and you will see in this application also here at GitHub, build spec file is there. So build spec file contains of multiple things, right? Now, what are the multiple things? Phases, what things you have to do. Node.js version 10 needs to be downloaded. Where is it? The path and the location and the artifact. Just now I've told you what artifact is. Contains the secure and the necessary information which is trustable. So these are the files which are installing dependencies softwares in index.html file, PNG file, GIFs, whatever it is, right? So these are just the artifacts which are important for use. So either insert build command or use build spec.yaml, right? So if the file name is build spec.yaml, yeah, you can exactly use it. Otherwise, if some other name is there, you can avoid it and you can use that. Now, let's say I'm going to add primary, artifact one. Right. So let's artifact one I've added, S3 I've added, right? So now, if let's say I'm pulling it from S3, what bucket I'm using, what bucket I've been working with, so that is the bucket that S3 is used to you store the kind of files and folders, right? Let's say I haven't created any bucket so far, but let's say if some created buckets are there, some bucket Ohio, right? So this is the bucket which I have created. In this bucket, all the artifacts and everything will be stored. Fine. So all this part you can ignore. If you want monitoring, you can use it. And this artifact part, if you want, you can use it, right? So going ahead, you can just create a build project, and directly, a project will be created. Role name. Okay. Fine. So if you want, you can go ahead and create a different IAM role with where you will be allocating these kind of service things, right? So regarding this building role and everything we have to do. Okay. I have to check whether the projects which I have used and the buckets and everything. So if someone has not deleted it or not, or what, right? Then only I will be able to see it whether the project is running or not, right? So build projects. If you want, I can show you the project build history. My project only. Let me show you. Which I have created. So okay, just leave it, right? Let me show you this project only. So this is how the build project looks like, how the logs and everything looks like, right? If you want, just for your, just to show you, I'm showing it this way. Otherwise, source and artifacts are the things where I have done it.
AWS DevOps. What we'll do first, we'll talk about what are the services corresponding to what do I mean by AWS DevOps. Okay, we'll talk about that because the normal DevOps we have seen various tools, right? Because if you don't know what is CI/CD, then AWS DevOps services will not be making a lot of sense to you. Okay, in that case, I will just tell you brief about CI/CD and then I'll proceed to AWS DevOps services. Okay, so CI/CD, first of all, understanding what is CI/CD is important before learning any DevOps tools. Okay, and that's what would have been followed if you have taken in DevOps sessions. So first thing what we cover CI and CD. Okay, what is CI? CI is continuous integration. CI is continuous integration. The purpose of CI is what? The purpose of CI is that even a small code, whatever code developer is committing to GitHub. Okay, that code, ultimately what I want. Ultimately, I want to deploy that application on some environment. Now, CI/CD is a process to make sure that I deploy only good quality code, only the code which is working, only the code which has been tested. So what we do, as soon as someone does a commit, Jenkins build gets triggered, or instead of Jenkins, apart from Jenkins, you can use various other tools. So that build gets triggered, and that build does what? So Jenkins job gets triggered, and Jenkins job does what? It will build your code, it will compile your code, it will perform some unit testing, it will perform some static code analysis testing to check the code quality, it will do the testing of the code. Then it will build a Docker image. Okay, after the code is done, after the build and test and everything is done, the code will be packaged and a Docker image will get created. Now this Docker image, I want to run a scan on it just to check whether the image is having any vulnerabilities or not. Okay, so we use Trivy for that. Now there are, for everything we have different tools. For everything we can have multiple tools. So we can use Trivy for scanning that image. Then once we scan that image, we store that image to Docker Hub. Okay, this is CI. Now this process keeps on repeating. Even a small code change, even a full stop, even a spelling change, or whatever small change, he fixes a defect or anything, the developer does, as soon as he commits, automatically the Jenkins job get triggered, and this Jenkins jobs does what? The Jenkins job downloads the code. Whatever the code is there, whatever the small code he has written, his code is integrated with the complete code, and the complete code is downloaded. And the complete code is built, tested, static code analysis, all those things. Images created, scanned, and uploaded to Docker. This keeps on repeating for every commit. So this ensures that always a good quality image is there. The image which is created is good, and it is safe to deploy somewhere. Okay, this is what CI process ensures. You can have multiple other stages here. That depends on your use case. Okay, but these are the minimal, pretty basic steps that every CI process will have. Then the output of CI process is what? A image. Okay, a image, or you can say a artifact. Okay, a image or an artifact which has been packaged. That is the output of the CI process. Then comes the deployment part. We need to deploy this image to somewhere, maybe to a EC2 instance, maybe to a EKS cluster, maybe to a Elastic Beanstalk environment, maybe to anywhere. We want to deploy it anywhere we want. So we have a deployment pipeline for it. We call it CD. What happens in this? So this pipeline, when it gets triggered, okay, it just deploys that image. The image that was created, or the artifact that was created as a part of CI, that artifact will be just deployed to a Kubernetes cluster. Okay, so this is what CI/CD is. You can deploy it to a EC2 instance also. You can deploy it to a Lambda also. You can deploy it to a Elastic Beanstalk also. Anywhere you want to deploy, you can deploy. So this is CI/CD. Now coming to why we are here, why we are learning AWS DevOps. Okay, everything was cool, right? We were using Jenkins, we were using Maven, all those things we were using. These things we were using. Then what is the use of these? Why AWS has these AWS DevOps tools? Okay, now the thing is, now remember how did we do this project? How will you implement this kind of pipeline? What you will do? What we did earlier? We created a EC2 instance. Okay, we created the EC2 instance. In that EC2 instance, we installed Jenkins. We installed Maven, we installed Docker, we installed Trevi. Okay, we created a Kubernetes cluster. Okay, we were doing everything on our own. The instance that we were creating, okay, the Jenkins server. Remember the Jenkins server? Everyone remembers Jenkins server? So we were the one who created Jenkins server. We were the one. How did we create it? We went to EC2, okay, and we chose our specification. Okay, we chose our specification that okay, I want to launch an instance. Okay, we named it what? We named it Jenkins server, and we chose all the specification that we want our server to be T2 medium, T2 large, or whatever. We chose T2 large, right? Remember, we used T2 large because it has 8 GB memory, 2 virtual CPU. The reason for this big server was that we had to install a lot of things there. Okay, we had to install a lot of things there. Then we went and created network configurations. Then we configured storage and all those things. In short, we were doing everything, right? So this can be a complexity. You can think of it like a complexity that to run a pipeline. So why we were creating a Jenkins server? Why we were creating a Jenkins server? We were creating a Jenkins server because Jenkins was our CI tool, right? Jenkins was, we use Jenkins tool for what? For CI/CD. In the Jenkins only we were creating pipelines. We installed Jenkins, so we created Jenkins pipeline there. So in short, creating a server and then using it for building, all those creating pipelines there. That is a complexity. What if you don't have to create Jenkins server? What if someone is there to manage everything about your server? You don't need to create any, or you don't need to install Jenkins. Remember, imagine you don't have to install Jenkins. Someone is in the background. You just tell him that, okay, I want to build my project, or I want to compile my code, I want to unit test, I want to static code analysis, then I want to build Docker image, then I want to scan Docker image, then I want to push the Docker image to ECR. Okay, and then you tell that person that okay, I want to deploy it in a Kubernetes cluster or EC2 instance, and you don't have to install any CI tool. Imagine. So that is one good thing about AWS DevOps services. Okay, so AWS we all know has a lot of services, right? AWS we all know have a lot of services. You can think of a category and AWS will have a service for it. Okay, you have services in categories of compute, containers, databases, developer tools, end user computing, game development, migration transfer, content. Every category, has a lot of services there. So these AWS services, AWS DevOps services, which you see here, they come under this category. They come under developer tools category. Okay, you see developer tools category. In the developer tools category, you see code artifact, code build, code commit, code deploy, code pipeline. Okay, so these are the services that we are going to see. And like any other AWS services, these services are fully managed. These services are what? These services are fully managed. You don't have to worry about what is happening in the background. Most of the things are kept abstract to you. Okay, what is happening in the background? You don't see it. Where is this thing happening? Where is the code building happening? Where is the code being compiled? Where is the unit testing happening? Where is the Docker image build? You don't see it. You just specify that, okay, I want to compile, unit test, build, and all those things. And they will happen somewhere. And that somewhere will be managed by AWS. Okay, unlike what we were doing. What we were doing earlier, we were creating a EC2 instance. In that EC2 instance, we were installing Jenkins. In that EC2 instance, we were installing Maven. In that EC2 instance, we were installing Docker. So we were installing it. Now, with the help of AWS DevOps Services, you don't have to create that EC2 instance in short. This is one of the features. There are a lot of features. I'm telling you one important feature right now. You don't have to create a EC2 instance. You just need to specify what you need to do. And something will happen in the background, and whatever you wanted to do, all the steps will be executed. Okay. And rest of the things will be totally abstract for you. Now, this thing also, has one more benefit. Now, you remember we were creating a server which was T2 large. Now this T2 large server was 8 GB memory, so it was costing you, right? The cost of the server is 0.0928, and the bigger server you choose, the cost also increases, right? The bigger the server, the heavier the cost. Now, with AWS DevOps Services, since you are not creating any server, AWS is doing something in the background, so you are not paying for it. If I was creating a server and installing Jenkins and all the tools there, so I was paying hourly charges. If my server was running 10 hours, I would pay for 10 hours. If my server is running for 24 hours, I will pay for 24 hours. Okay. And in this kind of situation where we are doing CI/CD, in that case, that server has to be always up, right? Let's say my team is working in multiple time zones. Okay, I have a team in India, I have a team in Brazil, I have a team in US, I have a team in Europe, I have a team in Australia. So every moment in 24 hours, everyone is working. Okay, my developers are working. Someone might push a code in the morning also. Someone might push a code in the evening also. Someone might push a code at night also, right? So this server which we are creating, can I stop that server? Tell me, guys. Is there any possibility? Can I afford to stop that server? Yes or no? Tell me. No, right? I would not, because what if I stop the server? What if I stopped this Jenkins server and someone pushed a code? Let's say this developer pushed a code and my server is stopped. So my everything will fail, right? These things, this pipeline will not get executed because my Jenkins server is stopped. Okay, so in short, this Jenkins server, you have to run it 24/7. There is not a single moment in the day when you can afford to stop this server, because you never know when someone pushes the code, because CI can happen anytime, right? I have multiple people working in my team in different time zones, and they can commit the code whenever they wish. So I cannot stop this server. In contrast to this, AWS DevOps tools, you don't have to worry about that. In case of AWS DevOps tools, you do not have to worry about that. Because we don't have a server now. Simple. We don't have a server where we are installing Jenkins. Everything is managed by AWS, and there is no server running. And what happens is, whenever the developer pushes a code, whenever the developer commits a code, something takes that input. Okay, so the code is built, packaged, everything happens, and let's say this process took 1 minute, so you'll be charged only for 1 minute. Okay, let's say this process of compiling, unit testing, static code analysis, building the Docker image, scanning it, and pushing it to ECR. Imagine this process took 1 minute. So you will be only charged for that 1 minute. Because what happens is, as soon as the developer commits a code, now we don't have a server. This part is managed by AWS. So when someone commits a code, something gets invoked, a process gets invoked, or temporary server or temporary container, you can think of a temporary environment. A temporary environment gets created. In that environment, all these steps happen. All these, you can think of a temporary server or a temporary container. Something gets created in the background. A temporary thing gets created in the background. And in that temporary compute, in that temporary server, these steps happen. Compile, unit test, static code analysis, Docker image, all those steps happen. And once these steps are done, that temporary server is destroyed. Okay, that temporary server is destroyed. And you pay only for the time that temporary server or the temporary container is running. That's all. If it runs for 4 minutes, only pay for 4 minutes. If it runs for 3 minutes, only pay for 3 minutes. And the rest of the day, don't pay anything. So imagine in my case, let's say my developers do 5 commits daily. Okay, my developer does 5 commits daily. 5 commits, let's say 1 in the morning, 1 in the afternoon, 1 in the evening, 1 in the night. So if you were using a server, means like in our earlier case, where you were installing Jenkins, you were managing that server. In that case, you don't know when the developer might do a commit. So you have to run that server 24/7. But if you are using AWS DevOps services, basically you don't have to worry about. You will be charged only for that few minutes of how many times the build ran. That's all. So this becomes very cheap. In addition to that, it's AWS managed, right? If it is AWS managed, we get high availability, reliability, durability, all those good adjectives. Because you are, AWS is giving you these services. It's a cloud. These are cloud services. Okay, so these are very, easy to manage. You can think of. Okay, now imagine I have my whole infrastructure on AWS only. Okay, I'm using all the AWS services. I'm using databases. I'm using RDS. We know all the services, right? For managing security, I'm using IAM roles, IAM users. Okay, for compute, I'm using maybe EC2 instances. Okay, for serverless, I'm using Lambda. Okay, maybe I'm using DynamoDB for my database, for serverless databases. Okay, I'm using SQS for queues. Okay, I'm using SNS for notifications. Means, in short, my whole infrastructure, my application is deployed on AWS. I want to use AWS for infrastructure. In that case, AWS DevOps tool will have very good integration with your existing infrastructure. Because since your infrastructure is also on AWS, and the CI/CD services, they are also on AWS. So that becomes a very good choice for you. It's a very good combination. Okay, they have very good integration. That thing is also there. That's why many companies do prefer AWS DevOps tool as compared to open source ones. So what are some open source tools? First of all, open source tools, right? So here Jenkins, we are seeing Jenkins as a CI tool, right? Jenkins as a CI/CD tool. On Jenkins, we were creating pipelines. On Jenkins. So Jenkins is one of the tools. There are many other tools. You have GitHub Actions. You have GitLab CI. You have Azure DevOps. Okay. You have Bamboo. So there are so many tools. But if those tools you are using Now those tools will not, you have to do an integration of those tools with AWS, right? So if I'm using, let's say, let me open Paint. Let's say this is my infrastructure. This is my infrastructure. Okay, if I'm talking about infrastructure means where I need to deploy my code. Where do I deploy my code? That is my infrastructure. That's my infrastructure. That's my cloud infrastructure. Okay. Now, if my cloud infrastructure is on AWS, if it's on AWS, that means maybe my EKS clusters are here. Maybe my EC2 instances, Elastic Beanstalk, RDS, all those resources are on AWS. I'm using AWS for it. Now, ultimately, what I do, I have to deploy an image on this EKS cluster. I have to deploy my application on this server. I might have to, copy a S3 static website content in a S3 bucket. Okay, let's make a S3 bucket also. Let's make a S3 bucket as well. Let's make S3 bucket as well. Okay, so I have all the infrastructure on AWS. Now, what are the CI/CD tools I can use? We have seen Jenkins, right? We can use Jenkins. I can use Jenkins to do a CI and deploy it to Kubernetes cluster that we did in the previous session. I can use Jenkins to, upload something to this bucket, or I can do anything to using Jenkins to deploy it. Similar to Jenkins, what we have GitHub Actions. Okay, we have GitLab CI. We have, Bamboo. We have Bamboo. We have what? What I told you? Azure DevOps, Azure pipelines. Azure pipelines you have. Okay, many. There are many tools. There are many tools. Okay, you can think of Argo CD. Argo CD you have. And there are many tools. There are many such tools similar to Jenkins. Now, if I'm using these tools to deploy on AWS, so I have to create a connection, right? I need to create a connection between Jenkins and AWS. I need to create a connection between GitHub Actions and AWS. I have to create a connection between GitLab CI and AWS. So that becomes a kind of a disadvantage or an additional task. But now imagine I have a CI/CD tool in AWS only. So that's what these AWS DevOps tools are. That's what these AWS DevOps tools are. So you can think of something is there in AWS only. Okay, that is doing your CI/CD. It's in your infrastructure. It's here only. Your AWS DevOps tools are here only. So you don't need some external entity or external connection to manage. Okay, that because now you have a very good integration. Okay, you can easily deploy using these services to your infrastructure which is already in AWS. So that is also a benefit. So these are some good things about it. Now, limitations are also there. Okay, limitations will also be there. We'll talk about limitations. So limitations, one of the limitation now you must have. Can you tell me? Can you think of any limitation? First of all, can you think of any limitation? So good integration with AWS is a benefit, but good integration with AWS is also a limitation, right? Imagine my company wants to be flexible. They have some resources to deploy on AWS, but they are using another cloud also. They are using Azure also. Okay, they are using Azure also. They are using GCP also. They're using GCP also. They're using Azure also. Now, in the future, they have plans to use. They have to plans to go to Azure. They have plans to go to GCP. They have to deploy some servers in GCP. They have to deploy an application in GKE, Google Kubernetes Engine. Okay, they want to deploy some servers in Azure virtual machines. Can they use AWS services to do that? Tell me. Can they use AWS services to deploy some resource, some things on Azure and GCP? No. So that is a limitation. These tools, these AWS DevOps services, these are only good if your infrastructure is on AWS. So that's why I told you, if my existing infrastructure is completely on AWS, then it's a very good choice for me to use AWS services, AWS DevOps services for CI/CD. Okay. Now let's see these tools. Let's see these tools. What are these tools? So these are the tools which we have in AWS DevOps. Okay. You have, you can think of categories. You have CodeCommit, which is a source. Now, story always, every story starts with a code, right? Every story starts with a code because that's where, developer is writing the code. Developer is writing the code in Java, C Sharp, Node.js, or whatever. So he needs to store the code somewhere. Till now, guys, what tools have you learned in source code management and version control? Tell me. Where were we storing our code? Till now, where we were storing our code? Remote repo. We talked about remote repository. So we were using GitHub. Right? So we were using GitHub as a remote repository. That means all our code, what we would do if we want to create a repository in GitHub, what we do? We go to repositories. What we do? We create a new repository. We give it a name. And say create repository. We say create repository, and this repository gets created. And in this repository, we can store a file. We can create some files. Okay, we can say hello.txt, or we can commit. We know all these things, right? We already know all these things. So how to create a repository on GitHub? Okay, we know pull. What is git pull? We know what is git push. We know how to create a branch. What is a branch? We know how to do a commit. We know git add, git commit. We know all those concepts, right? So we learned those concepts when? We learned those concepts when we were learning about source code management and version control, right? We were talking about source code management, and that was the first thing, right? When we started learning DevOps, the first thing we started was source code management and version control. Okay, this is what we're talking about earlier. Okay, in this, what we learned? In this tools we have learned? We have learned Git. Okay, Git is a open source. And using Git, what we can do? We can manage our repositories. We can create a repository on our local. Okay, this was on our local. What we used to do? We used to download Git, and we used to run Git commands. Git commit, git pull, git add, git commit, git log. Okay, those were commands we are doing. And local is not enough. If I create a repository on my local using Git and manage it, that is not enough. There are many people in my team who want to see that code. I want collaboration. Okay, I want collaboration. So we learned GitHub, right? GitHub was helping us collaboration. GitHub was a place where we were storing the code. Okay. So in parallel to GitHub, now GitHub was a remote repository. Exactly same as GitHub, what we have AWS CodeCommit. Okay, AWS CodeCommit service is exactly like GitHub. It's a remote repository. You can think of. While GitHub is normally used for open source projects. Okay, this GitHub which we were using, you have created a GitHub account, right? On day one, you have created a GitHub account. So GitHub account, normally we have, all the community projects, okay, all those open source projects, open source codes, we keep in GitHub. Okay, we create a repository and that we keep. You can create a private repository also. Okay, but if I'm talking about some enterprise level stuff, okay, where in big companies, how are the repositories managed? So there, our projects are secure, right? They cannot expose their projects to the outside world. So normally what they do, they use a self-managed GitHub, okay, or self-managed GitLab. Okay, GitHub, GitLab, Bitbucket, those are all remote repositories. They can use self-managed version of them because they want to keep their code secure. They want to create private repositories. They want good, quotas, because here you will, this is open source, this is default. What you see, there'll be a lot of limitations with it. In our projects, we don't use public repositories. We want private repositories with a lot of controls. So here, AWS commit can have an edge because AWS commit is what? It's an AWS service. And you can create a repository in AWS CodeCommit. And those repositories are private. The repositories in CodeCommit are by default private. Because can anyone else log into your account? No. Only the person who logs into your account, only he can see your repository. So for private repositories, CodeCommit is a good choice. But there are a lot of limitations of CodeCommit. CodeCommit we do not use a lot of times. Okay, but CodeCommit is exactly like GitHub. You can think of. See what I can do here. I can simply create a repository. Okay, like we were doing in Bitbucket or like we do in GitHub. So we can simply go in create repository. Okay, you can name a repository. I can name it my demo. Okay, then you can just say, you can have KMS key for encryption. So this is additional feature you are getting. This is additional feature you are getting. And you see, you can just create repository, simple. Okay, this is what to do. Now see, it says create repository not allowed because there is no existing project. That's fine. And you are getting a notification here. AWS CodeCommit is no longer available to new customers because they will eventually decommission it. That's why we will not cover AWS CodeCommit. AWS CodeCommit, we will not use. Okay, no. Now normally what we do, what you can do is ultimately you have to store your source code. Okay, so you can use any other place to store the source code. You can use GitHub also. Okay, and you can integrate it with AWS services. We'll see how. We'll see how to do that. But AWS has decommissioned CodeCommit for now. Only the existing customers which are already using AWS CodeCommit, they are only using it now. Okay, new customers, they cannot create a repository now. So this was used earlier, and you had similar kind of process here. The way you had, process of pull request, the process of, you could go and upload anything in the repository, download something, add a file, add an image. Same things you could do on CodeCommit as well. Okay, so this was about the source code. Then what about artifacts? We will see. About artifacts, we will see. But next is building part. Next is about code build. Now, what is code build? Code build is your CI. Code build is what? Is your continuous integration part. If you go to our project, so the CI was what? In CI, what we used to do, we used to build our code, right? We used to build our code. Building includes what? Compiling, unit testing, static code analysis, maybe creating a Docker image, okay, scanning the image, uploading. So this was your building process or continuous integration. So code build is a service which can help you with that. Code build is a service where you can do your building part, this part, and it's a managed service. So you don't need to create a server. You don't need to install Jenkins or any other tool. You can simply create a code build project. In that code build project, you can specify your stuff, whatever things you want to specify. Okay. Now, this build part, once your code is built, there is an artifact getting generated, right? Once your code is being built, so your artifacts get generated. Maybe it's a Docker file. Maybe you are creating just a txt file which is mentioning your image URI or maybe image URL, or you are creating a zip file, you are creating maybe a tar file. Okay, when your code gets packaged, you're creating a tar file. So you can get it stored in code artifact. Okay, you can use code artifact for it, and in artifact, your artifact will get stored. You can store your artifact in S3 also. There are options. There are options for that. Then comes deploy. Deploy corresponds to CD. Deploy corresponds to CD. Now, in deploy, you have various options. Okay. In deploy, you have various options. You can deploy to where? You can deploy to a EC2 instance. You can deploy to a EKS cluster. You can deploy to a Elastic Beanstalk. You can deploy to a anywhere you can deploy. You will have deployment options. We will see that. So this is about deploy. And pipeline. Pipeline is basically creating a flow. Creating a flow of all the stages which you see here. Okay. First, your code will be stored somewhere. We will not be using CodeCommit. We can store our code in GitHub. Okay, that will be our source. Source is what? Source is where the code is. This will be our source. Build. In code build, using code build, we'll create a code build project. Okay. Then for deploy, we'll specify some deployment options that where we want to deploy. And all these things we will integrate in a pipeline. So pipeline is pretty easy. If you know code build, code deploy, and all those services, you can simply create a pipeline, and in the pipeline, you can just orchestrate the things. Okay, so we'll see code build first. Okay, let's go and see code build first. Okay, so here I will give you a repo. I'll show you a repo. Maybe. Okay, let's use this sample application. Okay, now this is. Let me show you the file structure, code structure that we will be seeing. So here you see we have a app.py first. Okay, it's a simple Python application. Okay, this is a simple Python application. This is app.py, and this is having a code. Okay, you can think of any code. It's just printing hello AWS demo user, whatever. It's a Python Flask application. You do not have to worry about that. This might be a complex application also. This might be a simple application also, but that is not your concern, because development of this application, writing the code about this Python application, maybe it's a Node.js, maybe it's a Java application, maybe it's a any application. So a developer will write the code. A developer will write the code. So you don't have to worry about this. So this is app.py. Now to containerize this application, we have a Docker file. We will see this Docker file. Okay, we'll see the Docker file. One more file which you see here is requirement.txt. Now requirement.txt also as is like a, so build and packaging tools are different for different applications. Okay, depending on your code. For Java, what we use, for Java we use Maven as a build tool. Okay, and whatever the dependencies are in my project, I'll put it in pom.xml, right? In npm, what we do in Node.js project, we use npm as a build tool, and all the dependencies we put in package.json, right? We saw this earlier, right? This application. Let me open a couple of applications. This is one application. This is, let me open Node.js project. Yeah, so here there are a couple of projects which I opened. This was the project of Java. This was Java project. In Java project, we were using Maven. Okay, and we use pom.xml. Maven understands pom.xml. Okay, so we have all the dependencies mentioned in the pom.xml. When the code is compiling, these dependencies are getting downloaded. Okay. Similarly, in Node.js projects, what we have package.json. In package.json, we put all the dependencies, and when the code is compiled, all these dependencies are downloaded by npm, and then the code is compiled. Similarly, in Python, we have something called requirement.txt. Okay, in requirement.txt, we mention all the different dependencies, and when we compile this, what happens? Whatever dependencies we have mentioned in requirement.txt, those dependencies get downloaded. Okay, and then our code is compiled. Okay, so Go will have a different Go. If you're writing a code in Go language, so that will have some separate tools, that will have some separate file where requirements are managed or dependencies are managed. So that will come with experience, what we use for this language. Okay, so we saw how many files in this file. We talked about add.py, which is our sample application. We talked about requirement.txt, which is having all the dependencies in our project. Okay, and we talked about Docker file. Docker file is containerizing this application. Now this Docker file, if you see, this Docker file is what? This Docker file is, we have learned that Docker. Now, let's see this Docker file. Docker file is doing what? From Python, this is a base image. When we are writing a Docker file, we have to talk about the base image, right? So we see from Python, this is our base image, right? This is our base image. Then work dir. We have work dir, work directories like cd. Okay, so we are going into /apu directory. So we are setting the work directory inside a container. So this will be our work directory. Then we are doing a copy this requirement.txt inside the container. Okay, so the requirement.txt which you have here, which carries your dependencies, you are just copying it inside the container. Okay, then what? Then after copying the requirement.txt, you are running a command. Which command? You're doing pip install -r requirement. So this is how we install. This is how we install the dependency. Like in Node project, what we used to do? In Node project, we used to do npm install, right? If it was our Node.js project, we used to do npm install. So in case of Python project, if it's a Python application, we use pip install. And just we mention -r requirement.txt. So what happens with this? So the requirement.txt that we have already copied in the container, and then we are running command. So pip does what? Pip will read your requirement.txt. Pip will read your requirement.txt and it will download the dependencies which I mentioned in requirement.txt. Okay. Then whatever dependencies got downloaded, I'm just copying it in the container. So I'll copy dot and dot. So everything is the whole code, basically copy the application. So we are just copying the whole code. Whatever the code in our current path is, we are just copying it inside the container. And we are exposing the port. Okay, expose 5000. We are just exposing that port. Expose command, I hope you all know. So this is telling us that in the container, the application will run on port number 5000. Okay, and then we are running a command. We are running Python app.py. Okay, this is a command that we are running. Now, when we are talking about code build, whenever we are talking about, now we are learning what? We are learning code build, right? We are learning a service called CodeBuild. Now, CodeBuild has a service called, has a special file. It needs a special file called buildspec.yaml. Okay, we have to create a file called buildspec.yaml. Now, you need to understand what you are doing in the build process. It totally depends on you what you're doing in the build process. In our code, what are you doing? In the application that we built last time, in the last session, this code, what are you doing in the build? We were doing all these things in the code. Okay. And where we have mentioned that? In our Jenkins folder, we had a Jenkins file.ci. In this file, we were mentioning what we need to do, right? So we were saying first we will do a compile, then we will do a code review PMD, then we will do a unit test, then we will do a code coverage check, then we'll do a code package, then we'll do a build Docker image, then we'll do a scan Docker image, then we will upload this image to ECR. So these were the things that we were doing, and we mentioned them in Jenkins-CI, Jenkins file CI. If you are doing this using CodeBuild, so you have to create a file called buildspec.yaml. Okay, you need to create a file called buildspec.yaml. Buildspec.yaml means build specifications. What are your specifications to build your project? So you should know. You should know what you want to. So if you see this buildspec.yaml looks like this. Okay. Now it is having things you might not need it. Okay, many things are optional here, but this is a very simple buildspec.yaml. Okay, so whenever it comes to code build, we need a file called buildspec.yaml in our repository. Okay, in short, no, it's written in YAML first of all. This buildspec file is written in YAML. Now, YAML file is very easy to understand. Look at these things. Now, look at these things. Understand version. Version is a code version. Version is a version of a build spec. You can leave it as a env. Environment variables. Some environment variables. Now, here environment variables, I'm creating a parameter store. Now see, if you have to create any global variables means the variables which will be used across your build lifecycle. Okay, there might be some variables which you want to use, right? Maybe in my case, I want to put Docker username, my Docker hub username, my Docker hub password. Okay, my image, my repository, Docker hub repository name. So these are my global parameters. Okay, which I want these variables to be accessible throughout my phases. Throughout my build process, I want these variables to be accessible. So these are global variables which I keep in env or environment variables. Exactly same as like we used to do in Jenkins. Remember, In Jenkins, what we used to do? In Jenkins also, in the pipeline, we used to say environment, right? What we used to do? In the environment, we were creating a environment variable, right? Same thing happens here also. Here also, in the env, we are storing some environment variable. Environment variable can be anything. It can be anything. Now, here we are using env and we have a set called parameter store. That means we are going to store these variables in SSM parameter store. Now, there is a service called SSM. In AWS, there is a service called SSM. Just search for SSM. You know what the service? So SSM in short, I will tell you what this SSM is. SSM is like a supermarket. SSM is like a supermarket. SSM has a lot of small tools or utility tools you can think of. Okay, you can create some automations here. You can store some parameters here in parameter store. You can manage maintenance windows. You can create some automation documents. You can manage application configurations. You can see dashboards. A lot of it's like a supermarket. There is a thing in this parameters in this SSM, a thing called parameter store. Now this parameter store stores your parameters. Okay, you can store any parameter here. You can store any parameter you like. So what I can do? Simple. It's very simple. I can create a parameter. Give it a name. Okay, let's give this parameter name. Okay, let's give these names only. Let's use these names only. So my parameter is this. Okay, my parameter name is my app / docker credential / username. So I'll say, okay, this is my parameter. This is my parameter. Okay, now value. What value you want to give it? So let me give my Docker Hub username. Okay, so I'll go to my Docker Hub account. I hope everyone has a Docker Hub account. I hope everyone has a Docker Hub account. So let me sign in. Let me sign in. Okay, so this is my Docker Hub account. Okay, so here, usually this is my Docker Hub username. So my Docker Hub username, I will copy it and I will store it. I'll just store it here. You can store it as a secure string also. Okay, or you can store it as a normal string. I'm just storing it like a normal string. So, okay, that's all. This is my username. So I created a parameter and say create parameter. Okay, see, this is a parameter. Now you have created a parameter called my app docker credentials / username. And the value of this parameter is what? The value of this parameter is this. Okay, so now this is what you have created. Similar to that, you can create more parameters. You can create a parameter called password also. Okay, you can create a parameter called let's create a parameter called password also. As a create parameter, I'll say, okay, I'll put this as parameter name. Okay, and I can use secure string also if you want. You can say secure string also, or let's put a normal string for now. Value. Now here I will use the token. Okay, here I can use my Docker Hub token. Okay, so I can create a credential. How to create a credential, you know, right? We all know how to create a Docker Hub token, right? So I can say, I can go to my account settings, right? I can go to my account settings, and here I can go to personal access token, and here I can generate a new token. Okay, let's say I'll say this is my. I can name this token. Let's say my token is I'll say demo token. Okay, publish repo as a read and write and generate. So this token gets created, D say key or whatever. So I'll just copy it. Okay, and I'll store it. I will store it here. Okay, so this is my password. Okay, I'll say create parameter. Okay, so what I've done, I have created two parameters. Now there is one more parameter which I need in my pipeline, in my project. I need a Docker registry URL. Now this can be your, you can create a repository. Okay, in your Docker app, you can basically go to, your project. Okay, so I'll go to Docker, I'll go to Hub, I'll go to Home. Okay, and I'll create a repository. Let's create a repository here. Let's go to repositories and let's create a repository. So I'll say create repository. Okay, I'll say the name of the repository I'll put as sample Python API. Okay, this is the name of my repository. This is the name of my repository I'm creating. I'll say create. Okay, done. So this is my repository. So I'll copy it. Okay, I'll copy it and I will use it here. So basically, I want to create a variable called this also. Where is it? The project? Yeah. So I'm creating a variable called my app Docker registry URL. Let me go to parameter store and create a new parameter. Okay, and the value of that parameter I will put as this one, the repository which I have created. Okay, done. Now, so this is all the stuff I did. So this is the name of a parameter and this is the value of it. Okay, so I'll say create parameter. So what I've done, I have created three parameters. One is my Docker Hub username, one is my Docker Hub password, and the third is my Docker Hub repository which I created. Why I created a repository? Because in this repository only I will push my image. Because ultimately what I want? Ultimately I want that my code gets built, right? Using this Docker file. When I build this Docker file, a Docker image will get created, and that Docker image I want to push it to Docker Hub, right? And I want to push it to Docker Hub in this repository. Okay, so for that I created these three variables. Now I could have hard coded them in my code also. Instead of using a parameter store, I could have hard coded it, right? But hard coding is not good practice. So what you can do is you can store these variables in secrets manager or maybe parameter store, or you can store it other places also. Now these are the environment variables, fine. So it will pick it up when this is a pipeline, right? Build spec.yaml is basically a pipeline. So when this thing will run, or this is a project, this will get executed. When this file will get executed, it will go to the parameter store and it will pick up these values. It will pick up the values of these parameters and store it in these variables. Docker registry username, Docker registry password, Docker registry URL. It will store it in these variables. And these variables will be used in our below project. Now you have phases. Okay, now you have phases. You have defined environment variables. Now you have phases. Phases, there are 4 phases here. First phase is install. Okay. Then comes pre-build, then comes build, then comes post-build. Okay, these are the 4 phases you see inside the phases section. Phases are basically steps, stages. Similar to what you had in Jenkins, we had stages. And inside the stages, we could create multiple stages. First stage was compile. Second stage was code review. Third stage was unit testing. Fourth stage was code coverage. Now, here we call them phases. Okay, now we'll understand what these phases are doing. So this install phase is doing what? It's just setting up your environment. Okay, because what we want to build our code. Okay, so in that, what we want, first of all, we want to do a Docker build. Okay, because if you see our project has a Docker file which we want to build, and this Docker file after building will give us an image, and that image we want to store it in our Docker hub, right? That's what we want to do. So exactly that's what we will write in our build phase. Okay, first let's see build phase. So the build phase, what we're doing, we specify right this. Just remember the syntax. Just remember the way it is written. So we write build. Okay, then we have commands. Here we can write all the commands that we want to run. Okay, so the commands are, in commands you can write normal Linux commands. So I'm doing echo running tests, cd, it's going inside this directory. Okay, this directory means your code directory. Okay, now you can simply relate it with Jenkins. How does Jenkins work? So if I show you how Jenkins work, so we see this was our Jenkins server like we created that day. Remember, this was our Jenkins server. So if you understand this, then code build will be clear. So this was our Jenkins server what we did. On the Jenkins server, what we do, we create pipelines. Okay, our code is lying on GitHub. Let's say this is GitHub. Let's say this is our where code is lying. So when a developer does a commit, okay, this is a developer, he does a commit in the GitHub repo. He makes a commit. So there is a webhook which is required. Webhook between GitHub and Jenkins. So this is the webhook, which means that as soon as there is a push which happens in the repo, this Jenkins job which is there here, that get an alert, and that Jenkins job does what? That Jenkins job downloads the code. Whatever the code is written in GitHub, whatever the code is in the repository, the whole code gets downloaded here. This whole code gets downloaded here. Okay, in the Jenkins server, this whole code gets downloaded. Okay, and now on Jenkins server only, what is happening? All the steps that you want for building the code, that is compiling, unit mvn compile, mvn unit test, mvn verify, mvn this, then docker build image, docker push, all those commands are being run here. Okay, so in short, what is happening? The code which is there in GitHub is getting downloaded here, and the whole code is being, all the steps are being run on this code. Exactly that's what happens in code build also. If I'm talking about code build project, if I'm talking about AWS code build, same thing happens. Exactly same thing happens. So what happens? This code which is in GitHub gets downloaded on where? Not on a server, but somewhere which is abstract to you. Now this thing is totally abstract to you, but the code which is there will get downloaded in a temporary environment on a temporary server or a temporary container, and on that temporary image container or server, all the steps that you have written in your build spec.yaml will get executed. Okay, so these steps are getting executed where? These steps are getting executed in some temporary environment. Means you can call it a code build environment. You can call it a code build environment. So in that code build environment, what happens? It's downloading your code. Okay, it's downloading all your code. This code is downloading. Then it's going inside this folder. Okay, AWS, yes, AWS simple Python app. So in this folder it goes. In this folder it goes AWS simple Python app. Okay, in this folder it goes, and in this folder it sees all the files: Docker file, app.py, buildspec.yaml, this, all those files it sees. Then let's see what it does. Then it's build a Docker image. Then it tries to building a Docker image. Now, same command that we have done earlier, exactly the same command that we did earlier. First, we will log into Docker Hub. If you remember, the same thing we used in our Jenkins project also. If I show you, see what we're doing. What we were doing. We were doing the same thing, right? We were first logging into Docker Hub, right? And then we were pushing the image. So here also, we see the same thing. So we are logging in, we are doing Docker login -u, and this is our Docker registry username. So now Docker registry username is a variable which you have created. This is an environment variable which you have created. See, Docker registry username, and the value of this is this. That means whatever we have stored in our parameter store, my app Docker credential username, this thing we have stored in parameter store, and the value of this is my username. So this thing will be taken. This thing will be taken. Okay, and it will come under in this variable Docker registry username. Similarly, the password which is stored in my in my parameter store. Okay, this password, this will come in this variable Docker registry password. So these values are being used here. See, Docker login -u, my username, which is already got, and to provide the password, okay, we are just using this thing. So the same process we used earlier. So we do echo. This is the way we use. Okay, we do password stdin. This means it will expect input, and we are doing echo. We do echo here. Echo means printing something. Okay, so we are printing Docker registry password. So while this command will ask for a password, and this command will provide the password. Okay, and this is how we do a login. So this command will log into Docker Hub. Okay, then what we're doing? Then we are doing a Docker build command. We want to build an image, so we are in Docker build -t. Okay, and this is the name of the image and dot. Okay, then we are doing Docker push. Same thing, Docker push, name of the image. So this thing normally what we do only, right? We build a Docker image and push a Docker Hub. This is exactly what we write in build command. Now, this is build process. Now, pre-build will contain the things that we need before it, right? So before what we do, before building a Docker image, what we're doing, we are just doing pip install. That means whatever dependencies we have written in our requirement.txt, those dependencies we are doing in pre-build. So pre-build, so in this example, we are doing this, but normally you can assume pre-build is like a prerequisite of build. If there is anything which I need as a part of build, I need it in the build step. I will make sure that in pre-build I am using it. You can think of that. Right now, what I'm doing, I am building the Docker image, and then I'm pushing to Docker Hub. Now, if you want your image to be scanned by Trivy, so you can write a command here to scan the image using Trivy. But Trivy needs to be installed there, right? So how will you install Trivy? You can just mention that in a command. In the pre-build, in the commands, you can mention the command to install Tree, and that's all. Your Tree will get installed. Okay. Then install was what? In install, we mention the runtime versions. Coming to what we were saying, I told you that in case of Jenkins, we used to create a server, and there we would install whatever we would need. If our code was in Python, if this code is in Python, what we do? Before building the Python code, we need to install Python, right? Right? If the code is in, let's say, Node.js, if this code is written in Node.js, so before building this Node.js code, we would need to install Node. We would need to install npm Node needs to install it, right? So that was manual thing that we used to do here in case of Jenkins server. But now we are not using Jenkins. We are using CodeBuild. So we, in the install step, we just mention the runtime version. Okay, these runtime versions are there. Okay, these runtime versions are, you can fix it. For example, my code, I know that my code is in Python. I know that my code is in Python. It's app.py, it's a Python code. So for that, what I need a Python runtime. So if my code is in Node.js, so I would need Node runtime. If my code is in Java, I can mention Java runtime. So this is a runtime version. Now, where is this runtime version created? That runtime version is created in the temporary environment of CodeBuild, which is not visible to us. It's somewhere in the background. And once all the phases are executed, that environment will die. Then comes pre-build. In pre-build, what you're doing? Some prerequisites, okay, which are needed for the build stage. Those you put in pre-build. Okay, here you can write some echo statements. Okay, you can install some utility softwares, maybe Trivi, or maybe you are scoring Chekhov, maybe you are installing, you are doing some, anything. Just in pre-build step, you can initialize few things, you can create some variables, you can, right now I'm doing what? I'm printing hello echo, installing dependencies. Then I'm doing pip install, any command I'm writing. Okay, in the build step is your actual build. What is happening? Build step is the core thing. What are the steps which you want to get executed? The CI steps. Okay, here what we're doing, we are going into the folder and we are just doing Docker login. Then we are doing a Docker build and we are pushing that image to Docker. That's all. Then comes post build. Post build is what? Post build is what you want to do after the build. After the build stage, if you want to do something. So here I'm just printing echo build complete successfully. Maybe you want to do something here. Maybe you want to notify someone. Maybe you want to execute some other command. Maybe you want that once this thing is created, once this image is pushed to Docker Hub, I might want to delete some files. Okay, I might want to delete some files. So that also you can mention. Okay, so this is about your phases. Okay, so let's go and create a build spec project now. Okay, so what we'll do? We'll go to code build. Okay, let me go to some other region. Let me go to California. Okay, you can do it in any region, doesn't matter. So what we do? We go to code build. Okay, we have selected code build, and here you see getting started. Okay, on code build, click on create project. We need to create a code build project. We specify the project name. Okay, project name is what? I'll say sample. Okay, Python app. Okay, just call it whatever you want. Then project type. So there are two types here: default project or runner project. So normally we use default project. Okay, now runner is something else. It says create a code build managed runner for the workflows in GitHub Actions. So this is for for GitHub Actions or GitHub enterprise actions or GitLab, or this is for those things. But right now I'm using default project. There are some additional options here, okay, which you can skip. Okay, if you want to enable public access to your build project, okay, whatever the artifacts, or once this build project is doing what? Build project is building your code. Okay, it will build your code, it will run unit test, it can package your code, it can create an image and store it in somewhere. So those things, if you want to make it publicly accessible, so you can say public build access, you can say. So build artifacts, whatever the logs will be created, those will be available for general public if you can enable it. So these are options, okay, which you can have. You have one option for enable concurrent build limit, which says that how many builds of this project will run in parallel. So we are creating a project right now, and that project will run. So how many concurrent runs of this project you might want? If I want that, if I want to restrict it to 1 or restrict it to 3, so only 3 parallel executions of this project can happen. Only 3 parallel builds of this project can happen. Okay, so you can, if you don't want to restrict, you can just leave it as it is. Okay, so these are additional configuration. Then comes source. Now source is where you will get your answer. You were asking a question that how does my code build knows? How does my code build know that where is my SCM? Where is my code? My code build is an AWS service. How will it know whether the code is there in GitHub, or whether the code is there in GitLab, whether the code is there in Bitbucket, whether the code is there in somewhere else? How will it know whether the code is there in S3? So for that, you create a source. Source where I have to specify, or I have to connect to what I want. I have to specify where my code is. So right now my code is in GitHub. I'll say GitHub. Okay. Now I say you have not connected to GitHub. So we need to create a connection. Okay, create a connection between our code build and GitHub. How do we do that? So for that, you can say manage account credentials. Okay, you have not connected to GitHub, so click on manage account credentials, and it will take you to this place. Okay, and here you can say connect project to GitHub. Now you have 3 options here. Okay, you can use a GitHub app. Okay, you can use a GitHub app. So connect project to GitHub using AWS Managed GitHub app. You can use a person access token. So if you already have a PPAT for your project, how to create a person access token, I told you in the previous session. Okay, how do you create it? You can simply go to your GitHub repository. You can go to GitHub repository. You can go to where? You can go to settings. Where is it? Settings. And then you can go to developer settings. And here you can go to person access token. And you can create a token. You can create a person access token here. Okay, token classic. And you'll get you can say create a new token. And the token what you get, you can use it here. Here you can use it. Okay, you can store that in a secrets manager, or you can just store it anywhere. You can use a file. Other option is OAuth app. So OAuth app, you have an option of this also in GitHub. See, in GitHub, if you see, there is an option of OAuth app also. If you want to have a new OAuth app, and you can see how this process works, and you can set this also. Or you can use simple GitHub app. Now this is easy option, GitHub app. So you can say create a new GitHub connection. You can create a new GitHub connection. I can put a connection name, let's say new connection, whatever. I'll say connect to GitHub. And simply install a new app. Okay. Here you will be asking you what permissions you want to give. Do you want to give permissions to all repositories, or do you want to give permission to only selected repositories? So I'll say all repository. I'll say install and authorize. Okay, done. And say commit. Okay, and you can just save it. You can search for the connection name and just save it. Okay, done. Done. So you have done what? You have done the connection. Now it says your account is successfully connected by using the AWS managed GitHub. Okay, now this means your code build is able to connect with GitHub. Now all the repositories will be accessible here, and you can choose from this list all the repositories. Okay, so I'll choose my AWS-CI/CD repo. Okay, this AWS-CI/CD simple app, where our project is AWS-CI/CD. This repository I'm selecting here. Okay, then it's asking you source version. Here you can specify the name of the branch that you want to build. Let's say right now I have only main branch. Okay, so in this project, when this project will be built, I want to build only the code that is there in main branch. So I'll say main. If you want to build, if you want to put the code, if you want to build the code that is in branch 1, branch 2, branch 3, so you can specify the name of the branch here. Or you can also mention some commit IDs. Okay, I can commit IDs, commit refs, those also you can mention. So right now I'm putting main because I want that whatever I'm building, when this code gets built, only my main branch gets built. Okay, then some additional configurations you can mention, and you can go deeper. You can get clone depth. So you can, how deeper you want to clone, means ultimately what is happening. Here I told you, your code build is doing what? When someone does a commit, whatever code is there, the whole code is being downloaded. The whole code is being downloaded. Okay, so you can specify git clone depth. So git clone depth means till how much commit history you want the setup to have. So you see commit history. If you see my commit history has only 2 commits right now. Okay, so if I have 40 commits, 50 commits, but I don't want till that depth. I want only first 5 commits. I want to download till only first 5 commits. So I'll say 5 here. Okay, so this can save up your space. Okay, so clone depth, choose, if you use full, if I'm using full, that means since the beginning of my repo, whatever commit history was it, all the commit history will get downloaded in that temporary build environment. Right now I'm talking about the temporary build environment of code build which will get created. In that, whole commit history will get downloaded. Okay, if you say full, but if I say 1, only the latest commit will get downloaded. Whatever the latest status of the code is, only that reference will get downloaded. That's all. So these are what are Git submodules. Now Git submodules are some other concepts. No need to go into that much detail. Okay, these are some optional steps. Okay, so this is about source. This is about source. So in source, what you mentioned? In source, you have mentioned that your code is where. So we mentioned that our code is in my GitHub repo, and we went and attached, or we went and created a mapping connection between CodeBuild and GitHub. Next is primary source webhook events. Now what do we want? We want that our code should be built every time when someone pushes in my repository, right? Whenever someone does a push in my repository, I want that this code build job to get triggered. So for that, we have something called webhook. Okay, so in case of webhook, so here is an option. You can say rebuild every time a code change is pushed to this repository. So you can select it, because I want every time the code gets changed, I want this code build project to get triggered and build my code. And that's what we want in a CI, right? That's the whole purpose of CI. Even the small change someone does, the whole code is being downloaded and it is done for testing and all those things. Now build type, you can say single, it will trigger a single build. If you want to trigger multiple builds, you can say batch build. So we'll do single build. You have command approvals. Okay, you can say command approval if you can disable. Okay, you can command approval is about pull requests. If someone raises a pull request and when someone approves it, okay, in that case you want to trigger it. So these are some options of webhook. This talks about event. When do you want that this code build project should get triggered? Okay, you can anyways trigger it manually. Manual trigger is always an option. But this particular thing, primary source webhook events, talks about automation. That as soon as I push, as soon as someone approves my pull request, if I say all pull requests, if someone approves my pull request, okay, if someone pull request accepted by fork, so all these are options here. Okay, so you can also create a filter group. In filter group, you can say push, or you can say multiple. So if someone opens a pull request, if someone pull request merge, if your pull request gets merged, in that case also you want to trigger. If your pull request gets created, if your pull request gets updated, if your pull request gets closed. So basically telling you in which cases you want to build your code. Okay, this is about event. Which event should build your code? Simple. Okay. Then you can specify some additional configuration also. And here I'm doing what? I'm doing manually create a webhook for this repository in GitHub URL. So you can also create a manual webhook. So let's select it. Let's select this option. Now comes environment. Now here, the environment, what is the environment? This environment is that temporary environment that I've been talking about since a long time. Okay, this temporary environment is what? This is a code build environment, which you are not managing it. You are not managing it. Code build is managing in place of you. So this is that managed environment. This environment will be like this Jenkins server. This Jenkins server that we used to create, where our build and all those unit tests and all those things were happening. So this environment is similar to that. But the best thing is that I don't have to install anything here. I don't even see it. So this environment, you can use environment image. So basically that is the environment gets created. So do you want to use the image of AWS CodeBuild? So the environment that is created, basically it's a container. That is a containerized environment. So that containerized environment, do you want it to create using a managed image? Or you can use your own image also. If let's say there is something which is a different programming language came in. Okay, I am using on some XYZ programming language, or maybe my environment needs some tools. My environment needs some tools with this managed image are now not having. Now managed images are standard images. Okay, managed images are standard Amazon Linux and Ubuntu images, very basic images. Very basic images these are. So for many purposes they are sufficient, but maybe in your case, your build, whatever you are writing in your build, because these steps are going to get executed in that environment. If you understand that these things which you're writing here, these things need some extra stuff, some additional tools, some additional libraries. So what you can do is you can pre-bake an image. You can create your personal image. You can create a custom image. In that image, you can do your installation of the tools, installation of those libraries, and use that image instead of managed image. Okay, so what code will do? CodeBuild will create an environment using your image, and that image will have everything, whatever you have specified. Okay, but I'm using managed image. For us, managed image is fine. Okay, running mode. Okay, now running mode means that your environment will be running in a container, or if you want to run it on a server, you can run it on a server also. Okay, that is totally up to you. That is totally up to you. Now, when would you choose a container and when would you choose an instance? Now, see, instance you will choose in case you have some heavier code. Let's say my build process has a lot of commands, and those commands require some heavy compute. Okay, some a lot of advanced commands I'm using, some tricky commands I'm using. Okay, which will be not sufficient for a container. Containers are short-lived, right? Containers are short-lived for small steps. Containers are totally fine. But some long-lived processes or some long-lived tasks or some complex calculations, computations, if I'm doing, for that I can use instance also if you want. Okay, and I'm choosing container because for us it's pretty, these are it's just building an image and pushing to ECR. Okay, so container should be fine for us. OS, I can choose the OS of the container. So the container, the environment will be created. So that will be Amazon Linux. I'm using a runtime, let be standard. Okay, and image. So this is these are pre-built images. Okay, these are pre-built images. So you have selected what? You have said managed images, right? You have selected managed images, and these are the image options you are having. Okay, now see, there are some standard images, standard 2.0, 3.0, 4.0, 5.0. Okay, you have Coreto 11, Coreto 8. Now Coreto is a Java distribution. Okay, so normally if you have a code in Java, so you can use these also if you want. But I'll go with default. I'll go with 5.0. Image version, you can use image version also. So I will use the latest version. So leave it default. Now service role. Now service role is doing what? Service role is what? Service role is a role for this code build service. So code build is doing what? Code build is a service which is a replacement of Jenkins you can think of. Whatever Jenkins was doing, code build is doing. The only thing is code build is not being managed by you. It makes your life easy because you don't have to install 10 different tools in this code build. It already has some basic tools, but if you want it to have more required tools, you can use your custom image. Okay, so service role. What coming to service role? Service role is what? Now your code build will be interacting with a lot of things, right? Now code build is a service. It will be interacting with maybe S3 bucket to store your artifacts. It will be connecting. It will be it will be connecting with code deploy for deploying. Okay, it will need to access code pipeline for pipeline execution. It might need to connect with SSM parameters with this parameter store to get the passwords, right? So code build is a service which is interacting with a lot of other services. Code build is a service which is interacting with a lot of other services, like it can interact with code deploy, it can interact with SSM parameter store, it can interact with secrets manager, and it can interact with S3. So you need to create a role for code build to do all those things, right? Because one service, when it wants to interact with other service, what to do? Tell me. If one service wants to interact with other service, what do? We create a role for it, right? So exactly same thing we have to do here. We have to create a role. Now the best thing is you don't have to create a role on your own. You just say new service role, click on new service role, and give the name of the role. Whatever name you like here, you can give it, and the role will automatically get created. You don't have to create it. That role will automatically get created. Okay, so this was environment configuration. Then you say additional configuration. Now additional configuration, there you can specify some more details. You can specify auto retry limit, that if your code build fail, imagine this code build, when the build is running, it fails. Do you want to auto retry it? So right now it's 0, but if you want to auto retry it, you can retry. Timeout. Timeout is just, when will your build timeout? I don't want to keep it running forever, right? If something is getting stuck, okay, maybe one of the step which is running, it's getting stuck somewhere, and it's taking a long time. So I'll not wait for end of, I'll just mention the timeout. Then queued timeout. Queued timeout is what? Now, if I have 20 jobs being triggered, 20 people did a commit, 20 people did a commit. So 20 jobs will get triggered, right? 20 code build projects will be triggered. Okay. So if my concurrent execution that we talked about here there was a setting of concurrent build. Okay, now concurrent build means how many projects can run in parallel, how many builds can run in parallel. And you know what, these environments, these code build environment that we have mentioned, these environments are managed by AWS. We cannot control it. So they have something in the background. AWS has something in the background, and it creates a temporary environment for us. And in that environment, our things are getting executed. So now, let's say there are many people in the world, they have triggered. Now, AWS has some limit, right? AWS has some limited resources you can think of. So if I create, if 20 people trigger, let's say, do a commit, so 20 environments will get created, right? 20 such temporary environments will get created where their codes are being built. So depending on the capacity at that time, other environments, other builds will go into the waiting state. Okay, that depends totally on the capacity. That totally depends on the capacity. So default capacity, you can check how much default capacity is allocated to your account. Okay, you can check that in service quota. You can go to here, you can go to service quotas, and you can check what is the default service quota you are having of concurrent executions. So if you are exhausted with this quota, then your build will go into queue. It will be queued up. It will be queued up, and it will be queued up for 8 hours. By default, 8 hours. Now, if you want to make it smaller, you can make it bigger. Now, these are some additional settings. These are, you can leave it blank also. You can leave it default also. Okay. So privilege. Now, if you want to build your Docker image with elevated privileges, you can say privilege. Okay, you can specify VPC. Now, if I want my code build to be allocated to attach to a VPC. Okay, I want it to attach to a VPC. So then I can maybe imagine when you want to have it. Maybe my code is lying somewhere in a EC2 instance. Okay, or you can think of I'm using some GitHub Enterprise version. Now this is a bit complex scenario where I want that my code build should download the code from that server. Okay, and that server is a private server, is living in a network. Now, how will my code build access that? So for that, you need to attach a VPC to it. Okay, so if your server is running in that VPC, so you can map this VPC with code build. But by default, we don't need this normally. We don't need this normally. Compute. Now here it talks about CPU and RAM. So basically this code build is an environment, right? This code builder is a execution environment where your whatever you have written in this build phase, or whatever these 4 phases are, these 4 phases are getting executed in this environment. So this environment will have some capacity, right? It'll have some RAM, it'll have some CPU. So this is specifying the RAM and CPU. Okay, so if you want more CPU, more RAM, you can specify bigger options also. But if you have a normal build, you can specify some normal compute also. So for us, even 2 CPUs and 4 GB memory is enough. Okay, the higher you choose, the more you pay. You will choose higher CPU and higher RAM in case of, let's say, I want to build a LLM. It's a I am working on some uh, machine learning project. Okay, and for building that project, I need a heavy compute, because in that case, these steps which I have written here, that will take a lot of time to get executed. If I'm building a LLM which is having, it's a heavy LLM, it's having a lot of things and a lot of advanced stuff. It needs some heavy processing. So in that case, 2 GB might not be enough. In that case, I will go for this or this. Okay, so totally depends on your choice. So I'll go with the default, or this was default, I think. Go with the default. Okay, then you have other options. You can set environment variables, some Docker registry credentials you can set up here. Okay, you can connect to a file system also. Okay, if you want to connect to a EFS, you can connect to a file system also. You can set up environment variables. So all these are your environment options. Okay, these are some additional options. But even if you go for the minimalistic option, that is also fine. You just need to choose a managed image, a container, and you can choose a OS, and that is good. Okay, that is good. And by default, you can select OS, your operating system, the image name, and image version. That's all. And the role automatically gets created. If you want to make it unique, just say any name. Okay, a role with this name will get created. Then comes build spec. Now, build spec talks about the location where your build spec file is. Okay, so my build spec file is where I can go and provide the path of my build spec file. So this is my build spec file. It's in my code repository. It's in AWS. So I'll copy the path. Okay, let me copy the path and I will put it here. So you just specify the path of the build spec. Okay. Or if you want to write a build spec here, you can switch to editor and you can write a build spec file here also if you want. Okay. If you don't want to specify the path of the build spec file. Okay, so I'm specifying the path right now. So my build spec file path is this. Then batch configuration. Now this is for advanced options where you want to group the builds in a single execution. In a single execution, you want multiple builds to happen, so you can use this batch option. Advanced options. Artifacts are what? Now when your code gets built, you want to store some artifacts. Okay, so where do you want to store it? Artifact is anything which will get produced. So in your code build, in your build spec.yaml, you have an artifact section. Okay, you have an artifact section. See, now the artifact section says what? Which files you want in the artifact. So I want all the files. So I've written, go into this base directory. That means inside AWS simple Python app. That means in this repository. So it's just one step behind it. So I put ... See, build spec is getting executed, so it has to go one step behind it. Means AWS simple Python app, and then it has to look for all the files. **** means look for all the files and keep them as artifact. Artifact means anything. It can be a file where I have the name of my image. It can be a tar file. It can be a jar file. It can be a zip file. Okay, anything. So you can say that maybe in your build, you are generating a zip, and that zip is your artifact, and you can put the name of zip here. Okay, you can have a war file which is getting created here. Okay, maybe you're doing mvn package. Maybe you are having command mvn package. Tomorrow I'll show you. We'll do a maven project also here. So like you have an mvn package. So a tar file, a war file will get created. Now that war file, I want to store it in S3 bucket. So in the files, you can mention the name of the war file, target / sample app.war, kind of that. So that will come as an artifact. Okay, you can mention it. And in the code build, you can say the path. Where do you want to store artifacts? So if you don't want to store artifacts, say no artifacts. But if I want to store artifact in S3, I can put the name of the bucket. Okay, I can put the name of the bucket where my artifact is. Right now, I'm not choosing any artifact. Let me leave it. So tomorrow we'll do the build of this bigger project. Then I'll show you how to store the artifacts. Logs. Logs are what? Now, whatever execution is happening, your build project is getting executed. So where do you want to store the logs? So for that, we have CloudWatch. You can store the logs in S3 also, or you can store the logs in CloudWatch. Okay, totally depends on you. So I'll say CloudWatch logs. It's optional. Okay. If you want to store in S3, so you can say that also. So I'll choose CloudWatch logs and say create build project. So your build project is getting created. Okay, your build project is getting created. Now in the build project, what we specified? No, see. It's asking for create a webhook. Now what you have to do is you have to go to your repository. You have to go to your repository. Okay, in the settings. Like normally, how do we create a webhook? We create a webhook like that only, right? We go to our repository, we go to settings, and here what we do, we go to webhooks. Okay, and we create a webhook. We say add webhook. Okay, and here it's asking for a payload URL, and we will copy this payload URL what we got. I'll copy this payload URL and I will paste it here. Okay, content type I'll choose application JSON. In the secret, I will choose this secret. Okay, so this is doing what? This is creating a webhook, a hook between our GitHub and CodeBuild. Okay, that means when there's a push happening here, so I can define here SSL verification I'll enable, and I'll define what event will trigger it. So here I can define just the push event. If someone pushes something in this repository, then I want this CodeBuild project to get triggered. Okay, so I'll just say add a hook. Okay, done, added. It got added. Now I'll just say close, and that's all. That's all. So this build project is created. CodeBuild project is created. Okay. Here what we have done, we have specified the source. Our source is what? Source is my GitHub repository. Okay. We have a role. Okay. Where we have, here we have all the stuff. Where you can see build history. How many times this project has been built. Okay. You can see project details. Project details, you can see name of the project. You can see, ARN. You can see the source. Okay. Which branch is being built, main branch is being built. You can see in detail other things also. You can see the environment that you are going to use this image as a building. It's a Linux container. This having this much amount of CPU. Timeout is 1 hour. Okay, and this is all. And this is a build spec that will be triggered. Now, if you want to test something, just click on start build. click on start build. Let's test it. So what will happen once you click on build? A build is happening. A temporary environment will get created, and you can see the phase details. Now see, these phase details will tell you what is happening. So it failed. We'll see what has failed. Okay, but the thing is, it's first of all, look at the phases. First is submitted, means as soon as you triggered the build got submitted to code build. Then the build went into the queue. Went into the queue. Now, since there was nothing in the queue, it just took only less than a second. Then it went to provisioning. In the provisioning phase, what is happening? In provisioning phase, the environment is getting created. So it took 5 seconds to create the environment. Okay, basically the environment settings which you had given, that I want 2 GB of RAM, 4 GB of this, I want a container, so basically whatever the environment settings you are given, so that environment got provisioned and it took just 5 seconds. Then it's downloading the source. See, it is downloading the source. In downloading the source, what it is doing? It is downloading a source code. And here it gave an error. It says error is, we'll see the error doesn't matter. Then once it's download the source, after downloading the source, it will run these 4 steps. Okay, install, pre-build, build, and post-build. Since downloading source failed, it cannot go to the rest steps. Okay, we'll fix it, don't worry. Then it says finalizing, then it says completed. Okay, but in short, my build got failed. And in detail, I can analyze it, what happened here. I can see the reports. If there was a report, so no report got generated. I can see the environment variables. I can see some other build details here. I can see even the resource utilization matrix here. I can track how much CPU was being used, how much memory was being consumed. Okay, so this can help me in identifying the correct amount of RAM and CPU which I'm using for build environments. Okay, if I check my resource utilization and the graph is shooting up, means if it is hovering around 100 or CPU utilization, memory is very high, so that in that case what I can do, I can go and choose a bigger environment. In that case, I can choose a bigger environment. Okay, so this is, you can see the logs also. In the build logs, you can see logs also. See what is happening. Running on code build on demand. Okay, it downloads, waiting for download source. Phase is download source. It's downloading a source. See, code build source directory. So it's downloading a source from where? From github.com, your repository. This is a repository. Okay, and YAML location. So it's trying to find this location of this build spec file. So it went into my project. Okay, it went into AWS CI/CD sample app. If you see, it went into AWS CI/CD sample app. Okay, then it went to AWS simple Python app. Means AWS simple Python app, and then it found out this build spec.yaml. Okay, it found out that. Okay, it says no command found for the phase install. See, install phase is running. Install phase ran here, so it says no command found for the name install, because install phase we did not do anything, right? In our install phase, we were just setting up our runtime. We were just setting up runtime version, so we were not doing anything actually. So if we want to run commands, we can run commands in install phase also. And install, if I want to run Trivy, if I want to install Trivy, if I want to install MySQL, if I want to install Git, I want to install some XYZ things I want to install. So I can write that command in install phase. Okay, so it ran, it's fine, no command. And then it says setting HTTP client timeout and all those things. Processing environment variables. Okay, decrypting parameter store. Now it's trying to decrypt. It's trying to decrypt parameter store environment variables, and it gives an error. Look at the error, guys. Look at the error. It says access denied. It says that the role which we created, code build sample Python app service role. Remember what I told you? I told you that this service role we were creating will be used by code build to do what? Because code build is interacting with so many different services, right? My code build is interacting with S3 for download, for storing the artifact. It is connecting with SSM parameter store. No, this role does not have access to SSM parameter store. It says is not authorized to perform. So what I have to do? I have to go to my role, that role which got created, the service role which got created. This role I'll open, and this role right now does not have permission for SSM. So I'll give it permission. Okay, so this role has some permissions. See, it has some basic permissions. Okay, it has some basic permissions, but it needs permission on SSM parameter store. Okay, so I'll say add permission. I'll say, I can say attach policy. I can just find a policy for SSM. Okay, let's find SSM back. SSM, I'll say Amazon SSM automation role. I'll say Amazon SSM full access. Let me go give it SSM full access, because full access of SSM will give him permissions to parameter store also. Okay, it should give permissions to parameter store also. Okay, here you will be seeing SSM describe. Okay, it's not having it or what? Okay, I think it's not having it. So let's see something for parameter store B. Parameter. Or let's say SSM full access will make sense, I think. SSM full access should be fine. We'll check, don't worry. I'll say add permissions. Okay, done. So to this role, this role is my code build role. The role that my code build is using. Okay, now this role, now I have given it permission for Amazon SSM full access. Now what will do? If I start the build again, let's see. It'll again do a build. Now let's see where it fails. You can check phase details. Now it failed. Okay, no, it's giving a different. See, it's giving a different error. It's giving a different error. It says no. So you check the build logs. You can check the build logs. Now it had progressed. No, earlier it was giving an error here, right? Decrypting parameter stores was giving an error. Okay, but now it passed. Now it's giving a different error. It says decrypted variables error message. Parameter does not exist. Okay, it is not able to find that this particular parameter. Okay, so we will have to check this parameter, whether this parameter exists or not. Okay, so I think it's time now. Let's continue this tomorrow. Okay, we can continue this tomorrow. Okay, we will do this. This was one project that we'll complete tomorrow. This is just a couple of issues with parameter store. The parameters that we created in parameter store, just those parameters are failing. So we'll fix those small issues, and then we will learn about other things. We learn about what is code deploy. You need to go to build project, and here you have to give the project name. Okay, I'll give it sample. I'll give it sample build project. Okay, just give it whatever name you want. Then here you have to check, you have to provide the source, because when you are going to, because code build is doing what? Code build, purpose of the code build is to build your project. When I talk about build, what comes under building? Building means compiling the code, unit testing, maybe some static code analysis, building this Docker file to create an image, uploading the image to Docker Hub, running scans. So that all process comes under building. Okay, all the thing is CI. This is called continuous integration that we covered multiple times. So we are using code build service for that. Okay, so here I have to specify the source. That means where is my code lying? So my code is lying on GitHub, right? My code is lying on GitHub. So I need to tell AWS CodeBuild that my code is lying on GitHub. So you can select the source. Okay, now if your code lying on GitHub, you can select this. If your code is lying in GitHub Enterprise Server, GitHub Enterprise Server is an enterprise version of GitHub. Okay, because the GitHub that we normally use, like me, you, everyone, what we normally use, this is having certain limitations. Okay, this is having certain limitations. So organizations or enterprise projects, they don't want to use this because it has some limits. You can check limitations. For example, GitHub Actions will have limited number of hours for free. It will have some limits on the total amount of code in GBs that you can store. Okay, repositories, there are a lot of limitations. So some organizations don't prefer this free version of GitHub. Some organizations don't prefer this free version of GitHub. What they do, they use GitHub Enterprise Server. They will create a server of their own, and in that server they will install GitHub and it all the process. So if your code is lying in GitHub Enterprise Server, you can use this. If your code is lying in GitLab, if your code is lying in Bitbucket, so basically all these integrations are available. So for us, the code is in GitHub, so I'll choose GitHub. Okay, and then you need to establish a connection, because AWS by default will not know how to connect to your GitHub. So you need to provide a connection. So how do you provide a connection? So you will see here manage account credentials. Right now for me it says your account is successfully connected, but for you it will not show because you are doing it for the first time. Okay, so you can click on manage account credentials. Okay, it will take you here and you will get an option of connection. Okay, for example, let me show you how will that option come again. So this is the thing you will see. So how to connect to GitHub? So if you have not connected to GitHub yet, so on this page, what you can do, you can set up a connection. You can say create a new GitHub connection. You can click on create a new GitHub connection, and it will take you to this authentication screen. Okay, it will take you to authentication screen where you can provide the Git connection name. You can give any name. You can give any name. I'll say connection 001. Okay, any name you can give and say connect to GitHub. And now what it will do, it will ask you for app installation. Okay, just say install new app, or if you already have the app, you can select the existing app. Okay, so what you have to do, you can go to install a new app. For me it's already there, so I'm not doing it. I'm selecting the existing one. If you are doing it the first time, you have to click on install new app and you just put your username and password there. So it will just say connect and your connection will be established. You can search for this new connection which got created and you can save. Okay, this is how you get connected with GitHub. Now it's connected. Now my AWS CodeBuild is connected with GitHub and I should see all my repositories there. See, it is showing all my repositories, and I will search for my particular repository. So my repository is what? My repository is AWS CI/CD sample app. Okay, so I'll open it. I will just open it. Well, that's all. Okay, I opened it. And now you can select it. It will show you if you AWS CI/CD simple app. Okay, so just select it. Then source version in this put main. Okay, you can leave it optional, but it talks about which branch you want to build. So if I have lot of branches, I can specify that which branch I want to build. So I said main. I want to build main branch. Okay, then if you want to give additional information, You can give additional information, okay, about how deeper you want to clone. I will say git depth has 1, git clone depth has 1. So it will just clone the latest version of my, it will just clone only the latest version. But if I say git clone as 5, it will clone my repo up to 5 history, 5 commits back. Okay, so that also you can do if you want. But if I want to make it lighter, I'll use 1, so that it always takes the latest one. Okay, then comes primary source webhook events. Here what you need to do, you are saying rebuild every time the code changes pushed to this repository. Okay, this means let it be selected, because I want that every time someone pushes in my repository, I want the code to be built. Great. And other things are default. If you want to leave it, then it's fine. If you want to set up, manually webhook, if you want to set up a manual webhook, you have this option as well. I told you about this option yesterday, but this is again optional. This is optional, so leave it. Done. So we have set up a webhook. Then coming to environment. Yesterday I told you what is environment. Environment is basically the temporary code build environment. Environment is basically the temporary code build environment which will get created. And in that code build environment, whatever you have written in build spec.yaml will get executed. Okay, so I told you difference also. I told you difference between using Jenkins versus code build environment. When you were using Jenkins, you had to install the server, you have to configure a server, you have to create a EC2 instance. In that EC2 instance, you had to install Jenkins, you had to install Docker, you had to install a lot of things. And here in that Jenkins server, all the building was happening, all the process, all the steps of your code build were happening. For example, creating an image, uploading to Docker Hub, unit testing, all those things were happening on server. But now we are using code build. So we don't have to set up a server. So code build creates a temporary environment, okay, where all those steps will be executed. Okay, for that we have written build spec.yaml. So our build spec.yaml was this. Our build spec.yaml basically, what was this build spec.yaml? Our build spec.yaml had some environment variables, which is optional, which you might want, which you might not want. We created 3 environment variables. Okay, Docker registry username, Docker registry password, Docker registry URL. Okay, this is about basically why we have created it, because we will be using it in our build steps. Okay, so we created these 3 variables and stored in our parameter store, because I don't want to hard code. I could have hard coded everything here. My GitHub username, I could have hard coded it here. My Docker registry password, I would have hard coded it here, but that's not good practice. Good practice is to store these credentials somewhere. So we stored these credentials in parameter store. Okay, parameter store. See, parameter store, if you search for, you will see this. So, okay, doesn't matter. We can create these parameters again. No problem. If these parameters are not there, we can create it. So let me copy the parameters from North Virginia. Okay, I'm copying the parameter from North Virginia. Yeah, I had 3 parameters in North Virginia. So I'm just copying these parameters to California also, because right now my pipeline will run in California. Okay, so let me copy it. So this was first, let me create this one. The value of this was this password. This password I'll copy it. Second parameter I'll copy will be this one. This one, let me copy this parameter now. Username. I'll say create parameter. Username will be, I'll copy the value of it. Value is my name. Create parameter. Okay, and then I'll copy one more last parameter. This one, registry URL. Okay, this is the parameter name. Okay, and the value of this will be, it should not be repository name, it should be docker.io. Okay, it should be docker.io. So I'm putting it docker.io. Okay, these three variables I created. Okay, three variables I created. One is my Docker Hub username. Second is my Docker Hub password. And third is Docker registry URL, whose value will be equal to docker.io. I'll say create parameter. Okay, done. Okay, these three parameters got created. So now why I created these parameters in parameter store? Because I don't want to hard code my username, passwords, and these variables in my code. Okay, so it will refer, I'm telling it to refer to these values, to these parameters in the parameter store. Okay, and I'll be using these parameters below. How I'm using it? So in CodeBuild, in this build spec.yaml, we have phases. Okay, we have phases. I told you about 4 phases: install, pre-build, build, and post-build. Okay, in install phase, what we're doing, we are setting up runtime version, because we know that our code is written in Python. So we are just setting that our code build environment, this code build environment, which will be a temporary environment, which will get created. This code build environment will have Python 3.11 setup. We are just telling that. Okay. Then pre-build, what we are doing? In pre-build, I want to execute some commands. For example, I'm running echo command for printing something. Then I'm running pip install -r requirements.txt. You can basically run any commands. So I'm doing pip install -r requirements.txt, which will read my requirement.txt and will download all the dependencies. Then we have build phase. In the build phase, what commands we are executing? We are executing running tests or just echoing something. And then we are doing a Docker login. Then we are doing a Docker build, which will build my image. And then we are doing Docker push, which will push my image to Docker Hub. Okay, and then we have post build. In post build, I'm running a command. Which command? I'm just printing build completed successfully. Okay, this is what I'm doing. Okay, so these were all phases. Now you are free to put whatever commands you want in different phases. These commands, these phases gets executed one by one. First, my install phase will execute. Then my pre-build phase will execute. Then my build phase will execute. Then my post-build phase will execute. So depending on your requirement, you can put whatever commands you want there. So for me, it's a Python application. So that's why I'm doing pip install. Maybe in your case, it's a Node.js application or a Maven application. Then you can do mvn compile or mvn, you can do npm install, or maybe you want to install some Trivy or some softwares. You can put that. So whatever, it's feel free to put any command here. Feel free to put any command here. Then we have artifacts. Okay, what are artifacts? The output of this build stage. After this build process gets completed, do I want to generate some output? Output as in, do I want to produce some artifact which can be used in some later stages? Because after building, I might want to do something, like I might want to deploy. After my code is built, I might want to deploy, and the deploy phase might need some artifact, might need some files, might need some, a zip file, a war file. So I can put that in an artifact. So these artifacts will be available as an output of my code build. Okay, once my code build is done, okay, so these artifacts will get generated. Okay, done. So this is my build spec.yaml. So code build requires build spec.yaml. Okay, so what we were doing, we were creating this code build project where we have given the name of the project, we have provided the source, we have provided our webhook that we want to trigger this build every time when there is a push. On the environments, we can customize our environment. Okay, we can say that we want the environment to use a managed image, because this environment thing talks about what this temporary environment where your build is happening. So you can prefer what type of environment you want. Okay, so if you want to manage environment, you can choose that. If you want to get the environment created using your custom image, this I told you one example also. Maybe my build spec.yaml has some features like tree scan, or maybe it requires some other tools. I'm referring to some other tools which are not present in this managed image. So I can use custom image. Okay, I can use custom image. I can create a custom image. In that image, I can do whatever installation of tools I want and then use that image here. But right now, managed image is fine. Running mode, I'll choose container. If you want to use a server for it, you can use it. Okay, and here you can use operating system. So I'll use Amazon Linux. If you want Ubuntu, you can use it. Okay, so maybe the commands which you're writing here, these are actually Linux commands only, right? These are what? These are Linux commands only. Maybe some commands which you're writing here, they are compatible with Ubuntu. For example, you're doing apt get, apt update, something like that. So those commands will be compatible with Ubuntu. You cannot use Amazon Linux in that case. So in that case, you'll choose Ubuntu. So totally depends on you. Runtime, you can choose standard. Image, you can choose any. So if right now this standard is fine for me, but in case if it's one Java project, so I could use Java where Corretto 11, where Java is pre-installed, Corretto 8. Okay, you can use that. Image version, I'll use the latest image. Okay, then comes service role. Service role is what? You don't have to create it. You just leave it as it is. You can just provide, hyphen, 002 or 003, whatever. So a role with this name will get created automatically. What this role is doing? This role will give permissions to CodeBuild to operate on some other services on your behalf. Because CodeBuild is doing what? CodeBuild is a service. It will interact with a lot of other services. It might interact with S3. It will interact with XYZ. It's easy to instance. It might interact with some other services. So how will one service get permission to interact with other service? Using a role, right? So this role will automatically get created. I just say new service role and I just mention the name. Okay, you can give whatever name you want. If you already have a role, you can use existing service role. But for the first time for that, you have to just go with the default what it gives you. Okay, then if you want to do some advanced configurations, if you want to change the retry limit, timeouts, okay, and these are the place where you want. You can choose compute resources also, okay, where you can specify that temporary environment where my build is running. If you want to make it bigger, meaning if there is some advanced computations or some advanced steps in your build part, maybe your phases which are running, they are doing some advanced stuff, maybe building a LLM, building a large language model, or maybe building some AI ML applications. So for those kind of applications, maybe this 4 virtual CPUs and 8 GB memory is not sufficient. So in that case, you can go for bigger also. Bigger the machine, bigger the price. Okay. And the best thing is, which I told you yesterday, that you only pay for the time your temporary build environment is running. Okay. So this build environment will get created when you trigger a build. And this build environment will get destroyed after your build is done. And you pay for only those number of minutes or seconds that your build environment was there. That's all. Unlike Jenkins or maybe other servers where you are paying for it for 24/7. Even if no build is running on Jenkins server, still you are paying for it because you cannot afford to stop it. But this temporary environment, you can just you don't have to worry about it. It will get automatically created and it will get automatically destroyed. Okay, so I will go with the default here. Then you can provide other things also. Some environment variables you can provide, some file system identifiers you can provide, EFS if you want to connect. So there are options. So I will leave. These are advanced details. So next is build spec. Okay, here you have to tell the location of the build spec. Okay, basically the path of your build spec.yaml file. Okay, so my build spec.yaml file is located. I'll copy the path. Just simply copy the path from there. Simply copy the path from there and just put it in. Okay, so it's not lying in a directory. My build spec.yaml is lying in under my home directory only. I have all the files in the home directory only. I have all the files in my home directory only. So I will just provide my build spec.yaml path. Artifacts. Where do you want to push your artifacts? So for us, we don't require right now. Okay, because it's written, you might choose no artifacts if you are running tests or pushing a Docker image to ECR. Basically, we are just doing what? We are just building our Docker image and we are pushing it to ECR. So maybe we don't require artifacts, but maybe your code is creating some war file or a jar file or maybe some other dependencies it's downloading. So you can choose a S3 bucket where you can store your artifacts. Okay, you can choose a S3 bucket where you want to store your artifacts. So I can choose a bucket. Let's choose a bucket. So the bucket has to be in the same region. So you can add it later also. It's not required to add it right now. You can later on edit it and you can add artifact later on also, no problem. So I'll leave it no artifact for now. I will leave it no artifact for now. Then comes logs. Logs basically whatever is happening by code build, whatever your code build is doing, all the logs for this activity. If you want to log it somewhere, you can log it to CloudWatch or you can log it to S3 also. So just say CloudWatch Logs, which is optional, and CloudWatch log group with this name will automatically get created. AWS/CodeBuild/sample build project. This log group will automatically get created. Okay, if you want to see any errors, you can check in this log group about the errors. Once this is done, you can just say create build project. And what is happening? Your build project is getting created. Okay, it gave an error. It says webhook creation failed. It says webhook creation failed. What is it? Okay, it's talking about the connection, I think. So I think it's interfering in the connection that we created yesterday. Edit project to retry. Okay, let's retry the webhook part. So you will not get this error. I'm getting this because yesterday I had set up this thing. So let's update project. Let's try again. Okay, even if it does not work, anyways, we can. Okay, now it works. Okay, so it maybe it did not took the latest changes at that time. Now what we can do. Now one thing you have to make sure your build project that you are creating that has a service role. Remember this service role which I created, which automatically got it. You can check. You can check this service role which automatically got created. You can check it. So this role is doing what? This role is giving permissions to code build. To do what? What permissions you can check. So automatically it got created. Okay, so it's giving permission on things like logs for creating some logs. It's giving permission on S3. It's giving permission on creating report group and all those things. So these are some default permissions which it got automatically. But guys, our code build, my build spec, if you see my build spec will try to connect to parameter store, right? I have in my build spec, I have written that please fetch these parameters, Docker of username, password, and all these things from parameter store. Now what will happen? This code build project, when I trigger it, when I start this build, it will go and execute this build spec.yaml. And when this build spec.yaml will execute, it will try to connect to parameter store. But right now, code build does not have permissions on parameter store. It has just these two default policies which got created. So I need to give permissions to the code build to access parameter store. So in this service role, what I'll do, I'll go to add permissions and I'll say attach policy. Okay, and here I'll give SSN full access. Okay, see, Amazon SSN full access. Basically, parameter store comes under SSN, AWS Systems Manager. Okay, and I am giving code build service role full permissions on SSN. So code build will have full permissions on SSN, and it can read my parameters. It will be able to read my parameters, and I will say okay. So now code build has SSN full access. Okay, now what I'll do, I can build my project. Let's build my project. I'll say start build, and you see build is happening. You can see the phase, all the phases you can see. See all the phases you will be able to see, and it will tell you on which phase if it is failing. Okay, it failed on one phase. Okay, it failed on one phase, but we'll see what is the error. But let's see. Submitted. So these are phases submitted. So when you triggered your build, it got submitted to AWS. Now, AWS what will do after your request is submitted to AWS, AWS will create a temporary environment for you. Okay. Now, there are many, not just you, there are many users of AWS in the world, right? Many people are using CodeBuild. So AWS has a lot of temporary environments already. Okay, which are already active. Some environments are already active. Some compute on the background, they are already active. Okay, or maybe they are full sometimes. So your request might get queued. Sometimes your request might get queued if there are multiple jobs, multiple triggers happening. So your request might get queued. Okay, but it did not get queued this time, and in less than a second, it got successful. Then it went to provisioning. Okay, it went to provisioning. Now, provisioning it took 6 seconds. Provisioning is a process. When you say provisioning means a temporary build environment is getting created for you. A temporary build environment is getting created for you in this provisioning step. Okay, this also got successful. In 6 seconds, the temporary environment got created. Download source. Then in that temporary environment, the code which you had in GitHub, that got downloaded because your code is going to be built there. In this temporary environment, your code is going to get built. So here, your code, all the source code got downloaded. Now install. Now see, now these are same steps. Install, pre-build, build, and post-build. Means whatever you have written in your build spec, install, pre-build, build, and post build. Okay, these steps will run now. Okay, these steps are going to run now. So now what happened here? Let's see. So install succeeded, pre-build succeeded, build got failed. Now build says command execution error. Error while executing command build spec.yaml reason exit whatever. Now here this is not a clear indication, right? So I can go to my build logs and I can check the logs. Let's see the logs. Let's see the logs. Yeah, it says error here. It says error here. It says what? It says download it says phase entering the code. It says build spec running command build spec dot yaml. It says build spec dot yaml command not found. Command did not exit. So let's see this error. Wait, let's debug this error. What does this error say? So here the information is not complete. It just says that it was not able to find this build spec dot YAML. Okay, we'll see why it is not able to find. Let's check our configuration. Maybe we missed something in the configuration. Okay, because I made some changes in this project earlier today. Let me close it. This is not required now. Let me go to my build project again. Okay, and let's see things. So maybe we'll go to edit. Let's confirm edit. We'll go to edit this project and let's confirm everything. Okay, source is good. Okay, AWS CI/CD sample app is good. No problem here. Main branch is fine. This is also fine. This is fine. This is fine. Yeah, okay. So this is the issue. See, it's taking some default build spec.yaml, which I don't want. I'll say use build spec file. Okay, I'll say exit the build spec. So maybe it did not take my build spec file. Okay, so I'll use my build spec. So here what you can do, you can refer to the build spec file which is there in your GitHub repo. Okay, here you can put in the build spec file path which is there in your repo. So my build spec YAML file is where? It's inside the home directory. So I'll just copy the name of it. Okay. Or if you don't want to refer to that file, you can simply insert your build spec commands. If you basically whatever the build spec commands are there, this command, this build spec file, you can write it. You can write it here also in this part. Here you can write it in this. But I don't want. I want better. The good practice is what? To refer to a file which is present in the repo. Okay, so I'm referring to this file. And rest everything is fine, no problem. Other things are already fine. So I think now it's fine. I think now it should run. Okay, I'll say start. Let's check now. Now it should be able to find my build spec.yaml. Earlier it was not able to find my build spec.yaml. Now it should be able to find my build spec.yaml, I think. Okay, you can check phase details and see what is happening. So install succeeded. Pre-build is happening right now. You can refresh it. So build is happening. Okay, if you want to check the live logs, you can check in the build logs. You can click on trail logs. Okay, it'll show you live what is happening right now. So see, your everything is happening, whatever you have written here. See, it's doing pip install. See, now it's pushing. See, now it's pushing. Push refers to the repo. It's pushing to the Docker repo. Done. Done. So it's succeeded. See, it says succeeded. So your code build is done. The code build is done. So build is done. Means whatever steps you have written in build spec.yaml, those steps got executed. So this was about code build. Now this will keep on happening even if I now see, I can check. I can go to my build project. Okay, I can see the sample build project that we have created. It shows success. Last build status is success. Okay, you can check to which repository is connected to, and it's showing everything. And here you can check in the build history. You can check about the history. So we have run it 2 times. We have run it 2 times. See, now we have configured a webhook, right? We have configured webhook. That means if I do a commit here, let's do a commit here. In my repository, I'm doing a commit. Let's edit this file and let's make a commit. I'm making some commit random. I'm saying installing dependencies to compile or something. I'm just adding a commit and I say commit changes. Now, as soon as I do a commit, my project should get triggered. Let's see. Yeah, look at it. See, automatically got triggered. And by submitter, look at the submitter. Earlier, submitter was me because I was triggering it manually. But this time, submitter is GitHub hookshot. Means commit. I did a commit. So code build identified that, oh, someone has done a commit. Let's build this code. And my code is getting built. And that's what CI is all about. That's what continuous integration is all about, right? I want that even a small commit or even a pull request someone raises, or even a even some feature, someone fixes a bug, someone makes some changes. I want what? I want that my code should be built to check whether they have done the correct coding, to check whether the changes that they have made, are they perfect? Will they hamper my production or not? Are they good? To check that, we do CI. That's what CI is all about. And code build helps you in that. Code build helps you in that. Now, after code build, what we'll do one more project. So building is done. We are able to build our code after every commit. Even a single commit someone does, I am able to build my code. Now, what about code deploy and code pipeline? Now, deployment is about what? Pipeline we'll see, but deployment is CD. While continuous integration always builds your code. Okay, even a small change someone is doing, the whole code is built. It gets unit tested, code is compiled, image is getting created, push to Docker Hub. This keeps on repeating. Now thing is, I have to deploy my code to a server, right? I have to deploy my code to a server. So how do I deploy it? So let's say I have an EC2 instance on which I want to deploy my code. This is my target EC2 instance. On the server, I want to deploy my application. CodeDeploy is a service which can help you to deploy your code to a server or to anywhere. I can deploy my code to a EC2 instance. Maybe I want to deploy my code to a EKS cluster. I want to deploy my code to ECS cluster. I want to deploy my code to a Lambda function. I want to deploy. So I can deploy on Elastic Beanstalk. I can deploy in anywhere. So CodeDeploy can help you in deploying. So what we'll be seeing today? We'll be seeing how to deploy a code. It can be any code which is there in my GitHub repo. Let's say this is my code. This is my code. Let's say this is GitHub account, my GitHub. This is my GitHub repository. In my GitHub repository, I have, I'll show you the repository that we'll be using. Let's open the repository that we'll be using. Yeah, let's use this repository. So this is a repository where I have a index.html. Okay, this is pretty simple repository. No, code doesn't matter. Code can be difficult, complex, or easy. Doesn't matter, because you are not the one who is going to write. It will be your developers who are going to write the code, right? So let's say my front-end developers or my developers wrote the code. Here we have an index.html file which is just printing AWS DevOps Demo, or it's just printing something. Welcome to something. It's a index.html. Now what I want to deploy this index. Let's say this is index.html. I'll write it here. In my repository, I have a index.html. Now it can be anything. It might be 20 files, 30 files. It might be 500 files here. It might be huge code. Doesn't matter. Ultimately, what I want to deploy this code on a target environment. Maybe a EC2 instance, maybe a EKS cluster, maybe a Elastic Beanstalk environment, maybe a Lambda, wherever. So what we'll do today, we will deploy this application inside this EC2 instance. So what our intention, as I told you, is to deploy this code in a server on a EC2 instance. Okay. For that, what we need to do, we need to install a code deploy agent here. Now this code deploy agent is doing what? Now code deploy agent is what? Code deploy agent is the agent of code deploy, which checks what is going on here. If any change happens, this code will get deployed here automatically. Okay, this is what it does. Now, since this is the index.html, I would need a web server here, right? Because it's a web application, right? It's an index.html means it's a web application. So I will need to install Nginx or maybe Apache or maybe Tomcat, Nginx, HTTPD. I will install something here. So we will see that. But let's do step by step. First of all, okay, let's go to developer tools. Okay, so we have done build. So we will not do build now. Build we have done already. Code build we have used already. Now we will go to deploy. Code deploy. Now I'll say getting started. In the getting started, what we can do, you can do along with me also. Even if you're getting error in code build, doesn't matter. You can follow code deploy. We will fix whatever issues you are getting in code build. We will fix it. So code deploy is anyways a new project. We are using a new project for it. So you can work on it. Okay, so whoever is doing along with me, exit. You don't do code build now. We'll fix it later. Focus on code deploy. So in code deploy, what we'll do, we have to create an application. Okay, we will create an application. So before creating an application, we need to create two roles. Okay, first step is to create IAM roles. So one IAM role we'll create for the server, because on this server, what we're going to install? On this server, we are going to install code deploy agent. Okay, code deploy agent. Okay, this agent we will deploy on the server. Now this agent will be running on the server, and this agent will be doing various things. It wants to access S3 bucket, it might want to access SSM parameters, it might want to access code build, it want to access code pipeline, it might want to access code commit, or different things it might want to access. So I will create a role for my EC2 instance. Okay, I will create a role for my EC2 instance. So I'll say, I'll go to roles. I'll create two roles basically. Which role I'll tell you? First, I will create a role for my EC2 instance. So we are going to first create a role for our EC2 instance. So AWS service, I'll say EC2. Okay, I'll say EC2. So I'm going to create a role for EC2. Okay, and I'll say next. Now what permissions I want to give? So I want this EC2 instance to get permission on AWS CodeBuild. So just search for CodeDeploy. I'll search for CodeDeploy, and here you see Amazon EC2 role for AWS CodeDeploy. So if I want to deploy, so this is the role we have to see. So what this provides, see, you can check its description if you want. This role is providing EC2 access to S3 bucket to download the revisions. A role is needed by the CodeDeploy agent on EC2 instance. So that's what I told you, right? I told you that we will be installing a CodeDeploy agent on our EC2 instance. So that's why we need to create a role for my EC2 instance so that it can interact with the S3 bucket. Okay, because that's what it will need. It might need to download artifacts from the S3 bucket, right? Because if I build something using CodeBuild, when I build something, the artifacts will be getting stored somewhere, right? Or any artifact which I want, it will get stored in S3 bucket. Okay, so I want my CodeDeploy agent to be able to get that artifact. So that's why we need to create a role for it. So I'll select this role. Okay, this role I'll select it. The role is Amazon EC2 role for AWS CodeDeploy, and I'll say next. And that's all. That's all. I'll give it this role name. I'll call it EC2 role for CodeDeploy agent. Okay, I'll just say this. EC2 role for CodeDeploy agent. Okay, and I'll say create role. Done. Done. So the role of EC2 is done. So I created this role for my EC2 instance. Okay. Now later on, when I'll create a EC2 instance, I will attach this role to that instance. Okay, so let's park it for now. Let's park it for now. Next, role number 2. This role number 2 will be a service role. That means we'll be creating a role for CodeDeploy. Now, the way we created a role for CodeBuild, remember, we created a service role for CodeBuild because CodeBuild was doing a lot of things for us. It was interacting with S3, it was interacting with SSM parameter, it was interacting with different things. Similar to that, AWS CodeDeploy is also a service, right? CodeDeploy is a fully managed deployment service. Okay, that automates software deployment to compute services such as EC2, Lambda, on-premise servers. So it's a service, similar to CodeBuild. But the purpose of CodeDeploy is to do deployment. So I want CodeDeploy service to be able to access EC2 or Lambda or other resources. So I need to create a role for CodeDeploy. Okay, so let's do that. So I'll create another role. Okay, so this time in my use case, I will select CodeDeploy. Okay, because I'm creating a role for CodeDeploy. So here there are 3 options. If you want to do a CodeDeploy for Lambda, means if you are using CodeDeploy to deploy on Lambda, so you can choose this role. If you are using CodeDeploy to deploy on a ECS cluster, so you can choose this role. Okay, or if you are deploying on EC2 or other sources, you can do normal CodeDeploy. So for us, this is fine because what we want to deploy our code using CodeDeploy on this EC2 instance. So I'll choose this first option. I'll say next. Okay, and it automatically gives you suggestion that this permission you have to add AWS CodeDeploy role. Okay, I'll say next and give this role name. I'll say CodeDeploy service role. Okay, just name it whatever you want. I'll say CodeDeploy service role. Okay, and I'll say create role. So I created 2 roles basically. I created 2 roles. First role I created for a EC2 instance. Second role I created for CodeDeploy. So these were the 2 steps that we did. First step was creating a role for my EC2 instance. Second thing we did was creating a role for CodeDeploy. Step number 3 is what? Step number 3 is we need to create a EC2 instance. Let's go and create a EC2 instance. Okay? I need to create a EC2 instance. I'll say launch instance. Okay, I'll use some defaults. I'll name this, give a name. Naming the server is important. I'll give it, let's call it my server. Okay, my server, I call it. I'm calling it my server. Or you can say app server. I call it app server, app server. Okay, you can call it in, but remember the name. Name is important here. I'll tell you why. So name of my server, I'm giving app server. Okay, AMI, I'll use default. Whatever Amazon NX 2023 AMI, I'll be using this one, default one. Then instance type, let it be T3 micro. That is also default. T2 micro, T3 micro, doesn't matter. Make it default. Key pair, if you want to create a key pair, create it. But if you don't want, just proceed without a key pair. Okay, key pair is also not required here. But if you know key pair, you know you can create a key pair. It doesn't matter. So I'm going without a key pair for now. Then in network settings, I'll also leave default here. Let it be default network. Let it be no preference on subnet. Let it be enable public IP. Let it be, security group. Security group, let's create a security group. Okay. Security group I'm creating. Let's allow SS traffic from anywhere. I'm allowing this. I'm allowing this. So these 3 traffics I'm allowing. Okay, these 3 changes I'm doing. I'm creating a security group called launch wizard 1. And this security group, I'm giving him 3 permissions, which will allow all 3 traffic. Okay. Then comes the user data section. Now in this user data section, user data everyone knows, right? What we do in user data, can you tell me? In one word, can you tell me what we do in user data? It's for automation, right? User data is for automation. Okay, you can run sh file, or you can write any script here. So whatever script you will write here, those script will get executed when your instance is launching. While your instance is launching. Guys, now on our server, we want to deploy this code deploy agent. We want to install this code deploy agent. So what I can do is I can either, just launch an instance like that. I can just launch an instance like that and manually go and run the commands to, deploy my server or deploy this code deploy agent, install this code deploy agent. Or I can write the commands to install this code deploy agent in this user data. So it will get automatically deployed, right? I will just mention the commands to deploy the code, install the code deploy agent. So while my instance is launching up, at that time, my code deploy will already get installed there. Because that is a cool thing to do. So I already have this in my repo. Okay, this repo link, if you don't have, I'm bringing you this repo link also. I'm bringing you this repo link as well. Okay, so in this, I have written this script. Okay, you can just copy paste this script. Now this script is doing what? This is doing yum updating. Okay, it is installing Ruby because Ruby is needed. Code deploy agent needs Ruby. It's installing wget. It's going into EC user directory, and then it's getting this. Now, guys, remember, this is a URL. Okay, you can use this URL normally, but see, we are in California region, right? So the script here says AP Northeast 1. So if you want, you can change it to California region. So California is US East 1, right? California is what? California is US West 1, sorry, US West 1. So instead of AP Northeast 1 here, you can make it US West 1. Okay. Now you'll be wondering where I got these steps. See, just type on Google install code deploy agent on Linux, Amazon Linux. See, install CodeDeploy agent or just write it. AWS documentation. Open the AWS documentation and it has all the steps. That's where I copied. See, sudo yum update, sudo yum install, sudo yum wget. Okay, then changing the directory, then using wget hyphen whatever. So just same commands I have copied it from here. Okay, so if you want to get copied from there, you can copy it, but I'm using this script in my user data. Okay, I'm copying it and I'm pasting it in my where is it? Yeah, in my user data. Okay, I'll just change my region here. Okay, instead of AP Northeast 1, I'll put US West 1. Okay, US West hyphen 1. That becomes California. Because my instance is in California, so I'll put US West hyphen 1. Okay, US West hyphen 1. Here also. And here also. There's one more occurrence of AP Northeast 1, so I'll replace it with US West 1. Okay. Any mistake, if you make any mistake here in the user data, then your instance will not get bootstrapped. Your instance will not get started. It will get stuck here in some commands. Okay, so make sure you are writing the commands properly. Okay, so and that's all. I'll say now one more thing. One thing we missed in the instance here. You see, in this advanced details, you will be getting an option of IAM instance profile. Okay, so IAM instance profile is basically the role which this EC2 instance will take. So what you can do is you can select the role which we created just now. Step number one was what? Step number one was we created this role for my server, right? EC2 role for CodeDeploy agent. So just select that role here. Okay, you can do it later on also, but okay, good to do here because since we have already created the role, so I'll just ask EC2 instance to take that role because I created that role for this server only. EC2 role for CodeDeploy agent, which gives EC2 permission to interact with, download as all those things. So we understood that role. So I gave this role here. Okay, and that's all. And say launch instance. Okay, so my EC2 instance is running. Okay, and this EC2 instance will get what? Automatically on the server, CodeDeploy agent will get installed because I have bootstrapped it. I have written this user data in it, which will make sure that while my instance is getting launched, these commands will get executed and I will get my server with AWS agent, CodeDeploy agent already installed. Okay, so let it run. Till here fine. Yes or no? So we did three steps. First step was creating a role for a EC2 instance. Second step was creating a role for CodeDeploy service role. Third step was creating a server with this user data. Let's check. If I connect to my server, let's go to connect. Let's do a check whether CodeDeploy agent is running or not. Okay, so if you want to do just system CTL, you do sudo system CTL status code deploy hyphen agent. Okay, just run this and it will show you running. See, it shows running. So CodeDeploy agent is running. We did not install it manually, but we did it via this user data. Okay, and that part is done. Now, what will you do? We need to go to CodeDeploy service. We need to go to CodeDeploy service and say create application. Let's say create application. Okay, give it a name. So I'll say sample. I'll say sample code deploy APP. You can just create an application with whatever name. Now compute platform. It says where do you want to deploy? Do you want to deploy your application on an EC2 instance? Do you want to deploy your application on a AWS Lambda? Do you want to deploy your application in a ECS cluster? So these three options you have. Since you are deploying on a EC2 instance, so we'll say EC2. Okay, and say create application. Okay, so we created our application. Done. If you want to create a notification rule, okay, notification rule also you can create. It means integration with SNS. SNS everyone knows, right? That you'll be notified. If any deployment is happening on this application, you will get notified. You'll get an email, you'll get a, you can create a SNS notification for that. Now comes step of creating a deployment group. So we have created an application called sample code deploy app. Now, for this application, we need to create a deployment group. What is a deployment group? Deployment group is basically specifying the details of the server where you want to deploy. So we want to deploy on this server, right? On this app server. So we have to create a deployment group for it. So we say create deployment group. You can give a name. So we want to deploy which application? We want to deploy this application. Compute type, where you want to deploy? We want to deploy on EC2. If you want to deploy on some on-premises server, you can do that also. But I'm deploying on EC2. Then deployment group name, I'll call it, just call it anything. I call it demo or deployment group. Okay, just a name of the group. You can name it whatever you want. Service role. Okay, now in service role, I will choose this code deploy service role, the role which we created in step number 2. Okay, because I have already created a role that my code deploy service will take this role. Okay, and this role has, who can take this role? This role can be taken by code deploy. And what permissions will code deploy have? We are giving it AWS CodeDeploy role permissions. Okay, so this role we created and we use that role here. Okay, done. Now deployment type. You have two options here. In place deployment or blue-green deployment. So I'll tell you that. What is blue-green deployment? Listen carefully. Normally, if we have a server, okay, if we have, let's say, 1, 2, 3 servers, 3 EC2 instances. Now I would want to deploy my application here. So let's say currently version 1 of the application is running here. Okay, I'll say version 1 of the application is running on all the servers. Imagine these servers are a part of autoscaling group. You can think of, okay, sorry, version 1. So obviously same version of application is deployed on all these servers. Version 1, version 1, version 1. Now, my audience, my customers, they are hitting maybe Route 53, will be Route 53 entry, or maybe a load balancer. Let's say this is a load balancer. Okay, so right now, whatever request they are hitting, this request is going to this load balancer, and this load balancer is receiving traffic to this. And the person which is accessing, he will get a response from these servers. That is version 1 of the application. Now tomorrow, when a new version of the application comes in, version 2 of the application comes in. Let's say version 2 of application comes in now. Now this version 2 of application should be deployed here, because I want this person to use the latest version. So I would want to deploy this version 2 on these servers. Now I have two options. One option is that I deploy this version 2 on all of these servers at the same time. Is that a good option? If I deploy here, 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 on these servers only, if I deploy version 2, that might not be a good option for me. Why? Because while the version 2 deployment is happening, these servers will have a downtime. imagine the deployment time is 1 hour. Imagine a lot of deployment, it's a huge package, and the deployment took 1 hour. Now, for this 1 hour, this person will not be able to access my application, and he will not be happy, right? I will not tell him that please don't use my application for 1 hour. Some deployment is happening. He will be, he will not be able to use it. So this is in place. What this is called? In place deployment. Okay. Other option is blue-green deployment. Now, blue-green deployment is a deployment strategy. Okay, there are different deployment strategies. Blue-green deployment, canary deployment, there are different strategies, but blue-green deployment is very popular deployment strategy. Where what we do? Now, let's say in blue-green, what we have these servers which are existing. In addition to that, we have one more setup. We have one more similar setup, means the load balancer and 3 servers. Now, what we'll do, we will deploy this version 2. Okay, we will deploy this version 2 on these servers. Okay, on these set of servers, these are exactly same. These servers are exactly same as these servers. Now, version 2 of the application is being deployed here. Now, once the application version 2 is deployed here, my testing team can test. My testing team can do a testing whether this version 2 is working fine or not. Right? If the testing team is satisfied, if they give a go, then what I need to do, I just need to route this request. The request that was going to this load balancer, I would route it to here. That's all. Now, this person whose earlier requests were going on version 1, now his request will go to version 2. So this is what blue-green deployment is. Means at a time, I have these servers also running, and I have these servers also running. And one set of servers will be having older version. I will deploy the newer version in another set of servers. Now there is zero downtime. Almost zero downtime is there because these servers are already updated with v2. I just need to switch the connection from here to here. That's all. Now this person will be able to access version 2. Now tomorrow version 3 is coming. So version 3 can be deployed on these servers. And these servers are not being used right now by this person. So version 3 will be deployed here. And people will be able to access, testers can test it. And later on when they have tested, this will point to this now. So this is called blue-green deployment. Does it make sense? Does blue-green deployment make sense? Blue-green deployment strategy is a strategy which ensures minimum or zero downtime when a deployment is happening. Then what about the session of the user? So session can be refreshed. Okay, so there will be very minimal disruption. Very minimal session can be, very minimal because what happens in the background, maybe databases and etc. are kept in sync. So there is very minimal disruption. That is handled at the application level. The user sessions and all those things, they are handled. Okay. So this was blue-green deployment. So here you have 2 deployment options, in place or blue-green. So if you have multiple servers, you can go with blue-green deployment also. But right now we are going with in place since we have a single server and this is a test application. So let's go with this environment configuration. Now, where you want to deploy? You want to deploy on EC2. Okay, I'm going to deploy on EC2. If I want to deploy on auto scaling group, I can choose that also. Maybe if I have auto scaling group, so I can choose that. But right now I'm using Amazon EC2 instance. Okay, now here tag. Now you have to choose on which instance you want to deploy. So I have an instance already on which I want to deploy. This is my instance, and this instance has a tag. This name app server. So I can mention this key and a value or the tag on the server on my code deploy. I can tell this name and value as app server. So if I have 10 servers now, imagine I have 10 servers on which I want to do deployment. All those servers name will be Any tag, I can mention any tag. Right now I'm putting name tag, but maybe I have a tag called env. Env is equal to dev. Imagine I have 10 servers with the name env is equal to dev, and I just have to mention here in the tag group one, I just have to mention env as dev. So means in my deployment group there'll be 10 servers. So on those 10 servers, deployment will happen. So its tag is just an identifier. With the help of tag, you are just telling CodeDeploy that on which server you are to deploy. Okay. And it tells you matching instances, one unique matched instance. Okay, so it tells you that there is one instance with this particular tag. Okay, then agent configuration with AWS system. Now agent we have already installed. Okay, we have already installed CodeDeploy agent using this user data. Now, if you don't want to install manually, you also have an option of this. You say now and schedule update. So in your server, CodeDeploy agent will automatically get installed, and it will be scheduled for updates also. Maybe a new update is coming tomorrow, or maybe AWS launches a new update of that package. So that update will automatically happen there. Okay, but right now we don't want, because we have done it manually. Deployment setting. Now deployment setting is also, now we have chosen in-place deployment. Okay, here we've chosen in-place deployment. Now there is one more thing, a deployment setting. Now deployment setting is telling you that do you want to update all your server at once? Imagine I have 3 servers here. Okay, forget about Blue-green. Blue-green we are not using right now. Blue-green we are not using. I have only these servers on which version 1 of the application is deployed right now. I want to upgrade it to V2. I want to deploy latest version of application there. Now, do I want to deploy V2 at the same time on these 3? Should I deploy V2 at the same time here? If I do that, all 3 servers will be down. Then again it will cause a downtime. But if I want to deploy it one by one, so I'll choose here one at a time. So one by one, first the latest version of V2 means latest version will get installed here. Okay, but while the installation is happening, these 2 servers will be running on V1. So this person can still access his application. The person will be still able to access the application. Then once this server is done, then it will move to this server. On this server, it will install V2. But a person will be able to use this and this. So it will not be 100. There might be some reduced capacity, because at a time all the servers are not active. But at least this person will not get furious. He will still be able to access the application. Okay, so this is the thing which you have. So I'll right now say all at once, because I have a single server. Or you can create your own deployment configuration also if you want to. If I want 20%, I want 30% of the instances, I want 40% of the instances at a time. So you can say that. Load balancer. If you have multiple servers, you can also put a load balancer, but right now I don't have, so I'll say ignore it. Okay. And in advanced details also, you can mention triggers and all those things. Rollbacks. If the deployment fails, do you want to roll back? So I'm disabling rollback, but if you want to roll back, if the deployment fails, that also you have option. Okay, so I'll just say create deployment group. Okay, so the deployment group get created, done. So deployment group is what? Deployment group talks about the target where you want to deploy. Since I want to deploy on a EC2 instance, so I told that all the settings related to that my EC2 instance should have this tag, my EC2 instance should be having, I chose a service role of CodeDeploy. I want to deploy all at once. I will go with in-place deployment or blue-green deployment. Okay, so all these things I specified in my deployment group. Now done. We have created a code deployment group we have created. Deployment group we have created. Now let's create a pipeline. So code pipeline is what? Code pipeline is just, a flow of steps. Okay, code pipeline is just a flow of steps. Like I want to do this first, then this sequence of steps. There might be some steps which I want to do in parallel, some steps I want to do in sequence, some steps I want to do, any. So you can orchestrate that using a pipeline. So we know Jenkins pipeline, right? We know Jenkins pipeline. So exactly the same thing is code pipeline. Okay, code pipeline is pretty easy. So what I'll do, I'll go to getting started and let's create a pipeline. Let's create a pipeline. So here, say create pipeline. I'm going to create pipeline. Okay, now look at it. Here you have 3 steps, very simple 3 steps. You have first is the category option. You are creating pipeline for what? It is asking you are creating pipeline for. So AWS has done a lot of improvement here. So couple of months back, you would not see this kind of option. Okay, now see, it is giving you so many options. It's giving you, if you want to do deployment, if you want to just do deployment, it's asking you, where are you going to deploy? Do you want to push your image to ECR? Do you want to deploy to ECS Fargate? Do you want to deploy to CloudFormation? Do you want to deploy to, if you have code written in Terraform? If you have written your infrastructure on Terraform and you want to deploy in AWS, so these are some ready-made templates. These are some ready-made templates which you can use it, good to use. It's simply no code. Even someone who does not know coding, he can just use this template to create a pipeline. It's a no code kind of they have made it no code. So this was deployment. Now, if I want to do CI, continuous integration, so they have added support of CI build Gradle. Means if it's a Maven, like a Gradle is like Maven only. Okay, CI build Maven. If I have a Java project, and I want to do a CI now, see, you don't even need code build now. No, it will create code build part also here in this. You just simply go and create a pipeline and you select that my code is written in Java. It has some form.xml file and I want to use Maven to build it. If my code is in Node.js, I can use this. If my code is in Python, I can use this. So it is like, it's giving you everything written. Now if I do it, see, just for testing, just for showing you how it looks like, I'll do, let's say, I'm doing continuous integration and I'm using CI build for Python, just for showing you. I'll roll it back, just show you what kind of auto generation code happens. See, I'll say next. Source provider, I'll choose that my code is on GitHub. Obviously, I'll choose GitHub. Okay, I'll choose my repository. Let's choose my repository. Let's choose this. Okay, I'm using this repository connection, and I'll put my repository. Okay, whatever Python code I had. What was it? CI CD. Let's say this in CI CD simple app. This was a Python code, right? And here put the branch name. Let's say main. Okay, and the next. Simple. Now look at it. Look at that. It has created a build spec.yaml for you. See, now you don't have to create a build spec YAML now. We did it manually earlier. For our project, we had created build spec manually. But now, if you're using a template, you don't even have to do that. It's giving you a sample build spec.yaml. It is just saying that, okay, you see, it's having a phase. Only build phase it is having. It's having only build phase, but if you want additional, if you want multiple phases, install, pre-install, or whatever, so you can add those phases, but this is just some quick way of doing things without writing, build spec and all those things. It's generating a lot of things for you. Okay, so let's go back. This was just to tell you. I'll go back. Let me go back to pipelines. Let me cancel it. I'll cancel it. Okay. Similarly, let me show you how for the deployment looks. Now, if I want to deploy on, let's say, using Terraform. Imagine I have a Terraform code. And I want to use that Terraform code to create infrastructure on AWS. Okay, I have Terraform code stored on my GitHub, let's say. So I'll say Terraform deploy to AWS. So I'll say next. Okay, provider, again, I'll choose my code or my repository. I'll choose my connection as this. Basically, this connection you all know. And I will choose a repo for my Terraform. Okay, where I have my Terraform stuff. Okay, let's pick a Terraform code. I think I should be having it at multiple places. Let's say this is having some Terraform code. So let's say this is my Terraform code, let's say, in this project. Branch, I'll say main, I'll say next. Now see, again, look at it. It's not giving a template for you, but here if you see, so it's telling the pipeline name. This is the pipeline name, retention policy, you want to retain it or delete it, and say preview. Let's preview the code. Yeah, look at it. So in the background, what it did, it has created a pipe. Now this is a auto-generated, this is, again, you don't have to write this. This is a cloud formation, because ultimately AWS will do what? When you're creating a pipeline, code pipeline, when you're creating a pipeline, it creates a pipeline using this cloud formation template, okay, which you don't have to worry. Okay, there are a lot of things here which you don't have to worry about. Let it be, and just say create pipeline for template, and your pipeline will get created. So these are, a lot of templates which are given to you by AWS. Let me cancel it. Let me go to our what we have to do. So for us, we'll create a pipeline. Now see, I told you how to create a cloud pipeline using, if you have code written in CloudFormation, then also you can deploy it to, AWS. You have CI part here, using which you can deploy, you can do a continuous integration. You have automation. You have, or these are some templates. Simply, these are some templates. Or we'll go with custom pipeline. Now, this was the only option earlier. Earlier, we used to get on this option, custom pipeline only. These three options have been added recently, which are no code tool kind of. You can use it easily and things will happen in the background without you worrying about writing the code. But we'll go with build custom pipeline because, okay, I'll go next. Pipeline name, let's give a pipeline name. I'll call it demo pipeline. Just call it whatever you want. You have execution mode. Okay. Here you have three different modes: superseded, queued, and parallel. Now, if you want to run pipelines in parallel, you can choose parallel. If you want to use queued, means if multiple pipelines are running, if multiple triggers are happening, so you want the jobs to get queued one after the other. You can say queued. Superseded means overridden. So you can check to info and you can see what these are. Superseded means a more recent execution can overtake a older one. Means, let's say if someone triggered a build and the build was running and suddenly I push something new, so it will override the existing one. Okay, so superseded. So by default is superseded only. But if I say queued, so it will be in queue. My one commit will trigger the build and deploy will happen. Then next, then once it is over, then next, and all that. But if parallel, it will happen in parallel. Multiple executions will not wait for other ends to complete. They will all happen in parallel. Okay, so you can choose whatever. This is up to your choice. Okay, service role. Now, service role, again, we don't have to create a service role. The way we created a service role for CodeDeploy, but we don't have to create a service role for CodePipeline. Okay, we just have to come here and we just have to say that role name, that's all. Okay, and a role with this name will automatically get created. You don't have to worry about it. Okay, a role with this name will automatically get created. So I'll say I'll go with it. Okay, so it says allow AWS CodePipeline to create a service role. So your code, this role, will be automatically created. Okay, done. In some advanced settings, you can put your artifact location. Artifact location is what? Where your artifacts will get stored. Okay, so artifacts are getting generated, right? Every time run something will get generated. Okay, so where you want to store? You want to store in a default location. So a bucket will get created. In that bucket, all the artifacts will get stored. We will see it, don't worry. Artifacts part, we will actually see it. So I'll say default location. But if you want to specify a custom location, so you can specify custom location. In that custom location, your artifact will get stored. Encryption key, you have an option of encryption key also. This artifact that you're storing, so this is a key. KMS key, KMS key, right? KMS is for encryption. KMS is for encryption. So do you want to use that key for encryption? So if I use default AWS managed key, so that default key will be used to encrypt the data in the artifact. So the artifact store, where my data will get stored, where the artifacts will get stored, that store I am protecting with a KMS key. If I want to use the default key, I'll go with it. If I have my own key, so I'll go with custom managed key. These are additional settings. If you want to add some variables, you can add some variables, but leave it default if you want. Then say, so what we are on step 2 right now. We have given the Python a name, and we have said execution mode as queued. Okay, and we have chosen a service role which automatically will get created. And this service role will allow your code pipeline to do various things, to interact with various other AWS services, to interact with S3, to interact with code deploy, to interact with code commit or different services. So I'll say next. Now source again, same thing. Where is your code line? So my code is in GitHub. So I'll say GitHub via GitHub app. So again, I'll choose that connection. Okay. Again, I'll see that repository. Let's find that repository. This repository is AWS CI/CD pipeline CodeDeploy. Okay, let's use this repository. Okay, this is a repository. I'll select it. Branches, default branch, main, let it be. Okay, now code output artifact format. Now in artifact format, what will happen? A zip will get created. Whatever the artifacts you will be storing, whatever the artifacts that will be created, that will be stored in a zip file. We will see that in a few minutes. We'll be seeing that. So here you have to choose a format. First of all, you will decide what do you want to save as an artifact. I can save my whole code as an artifact. Okay, I want to save just one file as an artifact. Maybe after a maven build, I want that only the war file will be my artifact. If maybe in some step, I want something, I want a file, so I will put that file as an artifact. So it can be anything. So that thing will be zipped in a zip format. It will get stored. Okay, or you can use full clone. Full clone will clone your whole repository. Okay, this complete repository will be used as artifact. So you can do both. Okay, you can use basically both. Anyone you can use. So, and now again, webhook event. Now here's enable automatic retry on a stage failure. If a stage fails, it will get retried. Now webhook events. Webhook is same thing. Do I want this pipeline to automatically start whenever any push and pull happens? If anyone pushes to my code in this repo, if anyone does a push or he does a pull request, I want the pipeline to get triggered. Webhook. So that's what webhook is, right? So I'll say, okay, I'll say start your pipeline on push and pull. No, I can specify even some filters. I can say that only push. I want the pipeline to get triggered only when there's a push or only when there's a pull request. Okay. I can say that, let's say push. I can say that push, only push if it happens in only in the branch called main. I can specify that level of filter also. So this pipeline will only get triggered if push happens on my main branch. Or I can say if push happens on all the branches starting with release start. Okay, so whatever branches in my repository, they are starting with release. So whenever someone pushes in these branches, so this pipeline will get triggered. But in other branches, if someone pushes, the pipeline will not get triggered. Okay, so I can say file path also. Let's say in my file, all the files with the .java. Okay, let's say .java. So only if there's a push on .java files, start.java files, only then my pipeline will get triggered. So to that level of specification I can give here. You know how cool is that? Because maybe I don't want to build my code every time. I don't want to deploy every time. It is possible in real time, in real time, if someone changes in the readme file, if someone just changes the image and some readme file, I don't want to deploy, right? Because readme is just for reading. But I want to deploy if anyone changes my HTML file or my actual business logic. In that case, I want to deploy. So this option can be useful in that case. Then you have don't start the pipeline in this condition. So you have negations also. I don't want to start the pipeline if anyone changes to my dev start branches. Okay. So you can give this level of negations. Okay, I'm removing filters right now. Okay, now I will go next. Okay, so what we're doing, we have given a source information here. Okay, that our source, that our code is lying in GitHub. We have selected the repository, we have selected which branch to build, and we selected the event which would build the code. Let's say next. Now, build stage. Now, build stage, I'll skip because for me right now, build stage is not there. I have this index.html, which doesn't need to build, right? Which doesn't need to build. So I'll just deploy it. I will just deploy it. Using CodeDeploy, I'm just deploying this index.html in my EC2 instance. So you can skip the build step also. But if you have a build stage, for example, in our previous example, we had a build step, right? So in that case, what I can do, you can put a command also. In the build, if I want a command, echo hello world, I want to run a command in the build step. You can do that also. Or if I have a project already in CodeBuild, now see in my CodeBuild, I have a project, as it said. Okay, I have a project, right? I have a sample build project that we did previously in CodeBuild. I can use that project also. So what will happen in this pipeline? There will be a build stage which will build my Docker image or whatever we had in our build, right? What we had in our build, we had basically these phases in the build. So in the build phase, in the build project, what phases we had? We had basically all the phases, build, install, pre-build, post-it. So what will happen? This build will get triggered first. Okay, and what was this doing? This was uploading, it was building my Docker image, uploading it to Docker Hub, pushing it to Docker Hub, doing some tests and all those things. Then I would want to deploy. So that also you can add here. Okay, but I'm skipping right now because in our case, we don't want builds. The build project we have seen, code build we have seen already. Code build we have seen already. So in the build stage, you can add your code build project. Okay, if you want, you can add your code build project. but right now we don't want. Add test stage. So test stage also I'm skipping. Maybe you want to do some tests. Okay, before deploying to a server, I might want to do some test, right? I might want to run a code build project just for testing. Okay, so I can use that also. I'll skip it, not required. Add deploy stage. Now I want to deploy. So in the deploy provider, I can deploy on various things. So I can deploy on Lambda, I can deploy on EC2, I can deploy EKS, I can deploy EKS, I can use ECS blueprint deployment. I have a lot of things. So I'll choose AWS code deploy here, right? Because in our code deploy, we have already created a project. Remember, in our code deploy, we have already created a project. If you see our code deploy, where is that? Applications. Okay, we have our application already, right? Sample code deploy app. We have created this application. For this, we have created a deployment group. In deployment group, we have mentioned that server where you want to deploy. Now in the pipeline, I'm just integrating that. In my code pipeline, I'm just integrating. So code pipeline is nothing. It is just doing integration of various stages. So I can integrate my build project here. I can integrate my deploy project here. Okay, the project which is already existing, I can just integrate it. See what I'm doing. In my deploy, in the deploy stage, I'm just integrating my application. See, application name. Application name as a sample code deploy app. Okay, this is the same deploy application, deploy project, code deploy project that we have created. This application, sample code deploy app. So this is what I am integrating here. So I select it. Deployment group. Now it will automatically give me the deployment group because in this application we created demo deployment group, which was targeting our EC2 instance, right? It was targeting our EC2 instance, and what I do, and just say next. Okay, input artifact. Input artifact will be the artifact of your input, means your source artifact. Okay, here I don't have any stage called build. Okay, build stage we have skipped. That means we have a source stage and then we have directly a deploy stage. We have only two stages here. We have a source stage and we have a deploy stage. So whatever will be the output of this stage will be the input of the stage, right? So this source stage will be producing a source artifact, right? If you see the source stage artifact, what was it? Artifact code output artifact format. In our source stage, we are mentioning a zip file. That zip file will get created in an S3 bucket. This zip file containing my code will be present, will go into the S3 bucket. And that artifact, and this is the output of it, right? It's an output out of artifact format. You notice this is a source step. Add source state. Step number 3 was source step. So what will happen in the source step? What we mentioned the place where our code is, and the output of this step will be an artifact. Okay, every stage will have artifact. Every stage is going to have artifact. So output of this stage will have an artifact. What will be the output? The artifact will be a zip file containing my code, and this output will be the input for this deploy stage. Means I don't have a build stage right now, but if I had a build stage, if I was having a build stage, so the output of this stage will be serving as an input for the build stage. Then the build stage will also produce an artifact, maybe a war file, maybe a Docker file, maybe a Docker image, maybe anything. So that output will be the input for deploy stage. Then deployment stage will produce an artifact. So every stage will produce an artifact. So artifact output of the first stage will be the input for second stage. Simple. Okay. So let's go back and let's skip it. So this, again, I'm repeating step number 4. Here I have to skip the build step. See, input, look at it. If I would have a build stage, then the input artifact for it would be source artifact. Source artifact defined by source, because source comes before build. So output of this will be input of this. So I'm skipping it because I'm not having it. Skipping it. So for my automatically for my step number 6, that is code deploy. For this I'm choosing AWS CodeDeploy, and I'm choosing the application which I already have, the deployment group which I already have in that application. And here input artifact is source artifact, which contains my code basically. Okay, this will contain my code because you understood it, I think. Okay, and I'll say next. You can review all the steps and just say create pipeline. So your pipeline is getting created. See, look at the pipeline. Now, pipeline is nothing extraordinary. Pipeline is simply combining various stages. It's having a source, then maybe a build if you have it, then a deploy stage. I don't have a build right now, so there is only 2 stages: source and deploy. Source step is doing what? It's connected to GitHub. See, it's showing GitHub, so it's connected to GitHub. Deploy stage is doing what? It's doing the deployment in that deployment group. Okay, and here I have code. See, it's in progress. If you want to check the logs, just click on it here. It will show you the logs. So basically, when deployment succeeded, see, succeeded, and I can see my deployment lifecycle events here. I'll say view events. See, all these stages happen. Application stop. I'll show you what this thing is. Where it is coming from. But the Python RAM. Now, let's see how it works. Now, if you see, the pipeline has deployed. Deployment is done. My deployment is done. See, if I refresh, it shows green. That means deployment is done. So code build happened, and the deployment of my application happened on my EC2 instance. Now let's try to access it. How do I access my application in my server? So what happened in the background? Let's first of all see, before accessing it, let's see how this deployment happened. So in my code, if you see, I don't have a build spec.yaml. Build spec.yaml is for building, for code build. The file which is required for build project is build spec.yaml. But for code deploy, or we have something called app spec.yaml. Okay. We have something called app spec.yaml. Now, what this app spec is, now this app spec file, if you notice the code structure, now let me show you the logs first. Let's see by the logs, that will be easier to understand. So my Python RAM, okay, so I had a source stage and a deploy stage. So in the deploy stage, I referred to the code build project that I already created. Okay, so code deploy happening where? It was happening using the code deploy application, which I already created a couple of minutes back. If you see the logs of it, if you see the events, you see these things happen. Application stop. Then you have download bundle, before install, after install, application start, validate service. Now, where are they coming from? See, what happens is, if you see my app spec.yaml, here what we have written that the files now in abstract YAML is a YAML file which governs my deployment. Okay, this abstract file is required for deployment. Now, deployment I will not do like that only. First of all, I have before install. So here we have something called hooks. What is a hook? Hook is something which will get triggered when something happens. Okay, hook is something which connects something, right? So if my deployment is running, so first this before install. So in the before install hook, what I mentioned, I have mentioned that I want to run this install dependency script, which is kept in this location. Then I have mentioned I'm running this as root. Then I am starting my server. Then there is one more hook which I have created for application stop. So these hooks will trigger one by one. Normally, what happens? First, the application stop triggers. Okay. So see, look at the first application stop will get triggered. So these are the events which you see here. Application stop. You can basically override them using your appspec.yaml. Okay. In the appspec.yaml, you can call various scripts for doing some jobs. If you don't write this, it will not do anything. But here I have written something. So what is happening here? First, what is happening? Application stop is running. Now, what this application stop is doing? If you notice in my appspec.yaml, what I have in application stop, I am triggering this script, stop server script. Okay. In the scripts, I have something called stop server. Now let's see what's in there. In the scripts folder, if I go in the scripts, I have a stop server. Now this stop server is doing what? This is stop server is just I can run any command here. This is basically a shell script. See, bin bash, it's a script. It's doing what? It's just checking whether HTTPD is running or not. Okay. If it is not running, if it is running, so it is just stopping it. Service HTTPD stop. Okay. So that's what the script is doing, because that's what I normally do, right? If I have to deploy something on a server, if there is already an application in here, if there is already an application of version 1 in here, normally what I'll do, first I will stop it, then I will deploy my latest, right? And that's what I will do here. So these are some events which happen when a code deploy is happening, and you are basically overriding whatever you want to do in these events. You can write in your build spec.yaml. Okay, so in my build spec.yaml, I have written application stop. So this will stop my app. This will call the script called stop server, which is kept in script folder. So this script stop server is just trying to find if HTTPD is running or not. If HTTPD is a web server. HTTPD is a web server on Apache. So if this HTTPD is running, so it will stop it. Okay. Then what is happening? See. Then if you see, download bundle is happening. Okay, download bundle is downloading your artifact, whatever. Then before install. Now, in my appspec.yaml, I have configured before stop also. See, I have before install. See, before install. Now this before install is getting triggered. In before install, I am doing two things. In before install, I am first calling install dependency script. Okay, then I'm calling start server script. Okay, let's see what's there in install dependency script. So in the install dependency script, what I have this code which is installing dependency. It is installing HTTPD. This script is doing what? Yum install HTTPD-y. That means in my EC2 instance, HTTPD or the web server will get installed. So it is making sure this particular hook this particular hook, which is there before install, it will run before the any installation is happening, and it is installing all the dependencies which I need. Then it is starting the server. Now what I have in start server, let's see. If I see what I have in start server, in start server I have service HTTP start. In short, manually whatever I do, okay, there are some, for anything, for few tasks I need some prerequisites, right? Now, like normal, if I'm doing manually, that's what I will do normally, right? Normally what do I do? First I will stop the web server, then I will maybe install that web server if it is, if it is there. If the web server is not installed, I will install it, then I will start it. Okay, and here you have files tell you that there is a index.html which is there in the in the root directory. Just copy it in this destination /var/w/html. So this is the normal thing in HTTPD. In HTTPD is web server, right? HTTPD is a web server. So on HTTPD, what happened? This is a special location. Okay, /var/w/html. In this location, if you place this index.html file, it will come up as a website. So you can notice that if I go to my server, and I'll show you, if I go to this path, /var/w/html, let's go to this path, you will see a index.html. Yeah, see, look at it. See, there is index.html. So normally what happens in HTTPD? HTTPD is a web server from Apache. In HTTPD, what happens? This special path is a path /var/www/html. This is a very special path. Now, in this path, if I keep any index.html, this will come up as a website. That means what? That means if I show you what's in there, see inside this, it's my code about what my index.html is. This is what was there in my index.html, right? If you notice, what was in my index.html? In my index.html, if I open my index.html, this was the code, right? Title is AWS DevOps Demo. So exactly that's what happened. In the deployment, that's what I've done here. It's written that this index.html, which is present in the root, it has to be copied to this destination. What is the destination? Destination is /var/w/html. So this is basically your appspec.yaml. So appspec.yaml is used for code deploy. When a code deploy project is running, so it basically checks your appspec.yaml and it figures out what to do. So you have version, OS, you can say these are again basic things. In files, you talk about the files which you need to copy from your code to your destination on server, and you have hooks. Hooks you can configure as per your wish. So here we have configured two hooks. One is application stop hook, which will run at first when the application is, this is the first step. Then before install comes later. Now, if you want more things, tomorrow, if you want to do something in the install also, if you want to do something after, let's say after install, I want to send some email to someone. What I can do? I can go to AppSpec and I can create a hook for post install, after install. And I can write a command to, send someone an email. If let's say as a part of application start is happening here, but maybe I have something else here. Maybe invalidate, I want to run some test to check whether my application is running or not. Maybe I want to do a ping. I want to ping something, whether that page is coming up or not. So I can write validate step also here in the hook. So this is what our AppSpec.yaml is. Now, Since it has run already, since the deployment is done already, now I can do what? I can try to access my application. Let's get the IP of my server, copy the public IP of my server, and let's try to access it. I'll try to access it on port 80 because HTTPD default port is 80 only. See, I can see my code. It's coming from where? Welcome to CloudWatch Punjab, my name, and this is all coming from where? This is all coming from my deployment. Now, if you notice, if I make a change, let's make a change here. Okay, in my index.html, I'm going to make a change. Okay, let's make a change here. So instead of AWS DevOps Demo, okay, I am writing, or maybe instead of congratulations, I'm writing thank you. Thank you for watching. Okay, I am making a change here. I am making one change here. Now, if I make commit, as soon as I make a commit, I make a commit. Now, look at the pipeline. Let's go to my pipeline and check. You will see, look at it. It identified, it noticed that I made a change here, and this, it started pulling the code from my GitHub repo because there is a webhook. There is a webhook, and that webhook pulled the code from the GitHub repo. And now, once it is done, it is doing a deployment. See, deployment is in progress. See, deployment is in progress. You can go and check the logs again. If you click on here, it will show the logs. Okay, you can click on, you can directly go there back, click on this. Okay, and you can check the logs here. Success. See, it succeeded just now, and you see 6 seconds ago. It took 6 seconds. If you want to see the events, you can see the events. Okay, and the code, the latest code that you have made a change, that got deployed. That means, and if I check my website, if I refresh it, see, it says thank you for watching. In real time, whatever changes I'm making to my code, that is getting deployed as well. See, I can add multiple things here. See, I can add a build step. If I want to add a build step here, now it will fail obviously here, but let's add a build step. If I want to edit this pipeline, okay, if I want to edit this pipeline, I'll say edit. See, you have all these editings you can make. You can edit your pipeline properties. You can change the execution mode. Queued was default. If you want to make it superseded, if you want to make it parallel, you can make it. If you want to add some variables in the pipeline, okay, if there are variables or global variables which you want to use across the pipeline, you can create variables also. Git triggers. So what would trigger the pipeline? Well said. In my branch, if someone, so it's about triggering. What will trigger the pipeline? You can edit triggers also. Source, you can edit. My source is what? GitHub. My code is in GitHub. You can edit this stage also. So these are just stages. You can you can add one more stage here. Let's see, between source and deploy, I'm going to add a stage. Okay, stage, I'll say test stage. I'll call it test stage. Just add any name. Now, in this test stage, I can do whatever. I can say I can fail this. Now, if this stage fails, I can skip this stage also. If I want to skip, I can skip this stage also. But if I want to fail this stage, I can fail this stage also. I can add success condition. I can add failure conditions. Okay, I can add, action groups. In action groups, I can, choose what I want to do. I want to add a manual approval step. Let's add a manual approval step. So action name I'm putting as manual approval. So why I'm adding it? Maybe I want that deploy on the server should not happen automatically. I want someone to manually approve it. Then the deployment should happen. So I'm adding a manual approval step here. Let's say I'm saying now. So I added a manual approval step here. Okay, as I done. Okay, now see. Now let's see what happens. I'll save it. Now in your pipeline, if you see, there is a manual approval step added. Now let's say if someone does a commit. Okay, if I do a commit here, let's say I'm making a change again. Let's roll it back. Let's make it. Thank you for watching. I'll say thank you for watching the session. I'm making one more change. Okay, I'll say commit change. Now see. Now I made a change. Now look at my pipeline. Let's go to my pipeline, and it will sense my change. Yeah, look at it. Look at that. It's waiting now. It's not deployed. It did the source, but now it is waiting for approval. Look at it. It did not deploy my code here. Still, if you see my code still says thank you for watching. But now I can manually approve here. See, it's asking for manual approval, which is pending. I click on here. Okay, and now I have an option of approve or reject. I'll say approve. Comments, I'll say approve. Any comment you can put and say submit. Now, as soon as submitted, now deployment is happening. See, I can play with it. You can just try playing with it. Try playing with that. Okay, see, deployment is happening now. You can add more things. You can add multiple steps in parallel. Let's say in my deploy, I want to add one more stage for building. Okay, let's say I'm adding a build stage. Okay. In my build stage, in action group, maybe I'll add my build project. Let's say I'm just putting build project. Okay, sorry. Build. Let's say build. Okay, and I'm choosing let's say code build. Okay, there was a code build project that we created. I'm adding that in this stage. Okay, project name, let's say it's sample build project. Okay, and other things I'm keeping, output format, let it be. I'll say what it wants. Unable to save English, set the minimum number of input. Okay, input format, input artifacts I'm going to add. So input format will input artifact will be source artifact. Okay, and I'll say done. So, and I'll say done. I'll say save. So you can keep on adding multiple stages here. See, now I have 4 stages here. See, I have a source stage, then a build stage, then a test stage, then a deploy stage. Now what happens if I want to? No, there is an option of release change also. There's an option of release change. Now release change will, no, you create a release, right? Release process. I think you might have learned in CI/CD what is a release. Release is, let's say, after a month, if I'm done with a lot of changes, normally we have a release cycle, right? We do deployment on some servers after every release. We create releases. Okay, so I can create a release. Once a release change, so it's a release change will detect the most recent change in each location and run that change to the pipeline. So it will fetch the latest stuff. And so it will fetch the latest stuff. So basically it's triggering everything all over again. Okay, so see, code build source is happening. Then here build stage will happen. Build stage will fail. It might fail because build stage was coming from a different project. This is just to show you it failed because this was some other project, right? So it failed obviously, but you can add multiple stages here. Okay. If you want to stop execution, you can do that. Okay. And for deployment, if you want to check the artifact, let me show you the artifact also. So I go to deployment. Okay. And see, there is a revision needed. Click on this revision location. So this is the S3 location basically. So I told you, right, a pipeline S3 bucket will get created. So see, a code pipeline, this bucket got created. If I open this bucket, so this will give you the location of the bucket. So let's go to it. So this will open the S3 bucket. And this is your zip file. This is a zip file which has got stored in the bucket. Remember why it is a zip file? Why it is a zip file? Because that's what we configured in our source stage. Remember, in our source stage of the pipeline, if you remember, in the source stage for a pipeline, what we did? In the source stage of pipeline, we have done what? We have said, if you see the source stage, in the source stage, we have said that the artifact is going to be a zip file, right? See, output artifact format, and it was code pipeline default. That means a default zip format. And this default zip format gets stored in where? It gets stored in this SD bucket. So this is zip file. You can download and check also. See, I downloaded it. Okay, this I downloaded, and I can check it. This will contain a zip file of that. Okay, it will not open here right now like this. Okay, but this is what the artifact is. Now it depends on you what you want to put here. Totally depends on you what you want to put here. Cool. So that is all. That is all, guys, about AWS DevOps Services.
Just a quick info, guys. Intellipaat offers an AWS DevOps certification course. With this program, you'll get trained in AWS services, CI/CD pipelines, infrastructure as code, containerization with Docker and Kubernetes, monitoring with CloudWatch, and much more, all through real-world projects and case studies. The course is taught by certified trainers and industry leaders who guide you with hands-on labs and practical assignments, ensuring you're fully job ready. With this program, Intellipaat has already helped thousands of learners transition into high-paying DevOps roles, and you can check out their success stories on our Achievers channel. Link is given in the description below. So if you're looking to build a strong career in AWS DevOps, this course can be your perfect launchpad. Visit the course page link in the description below and take the first step towards becoming a certified AWS DevOps engineer.
So we are discussing about CloudWatch. So if I'm going to ask you guys, what is CloudWatch? What is, as per you, what is CloudWatch? This is the monitoring service. It is not just a monitoring service, you can say. It's a observability, means it's going to observe what's going on, how the services are performing. And if you remember, in AWS, we are building multiple services like EC2, auto scaling. Everywhere you are able to see that there is a dashboard is there. The dashboard is what? For the monitoring dashboard. That dashboard is came from where? It is integrated via the help of the CloudWatch. Okay. And if you remember, we discussed about giving you one example that if my boss is going to ask me to monitor 2000 server, and every hour I need to monitor CPU memory, are I am able to do that? No, na. So what is the option we have? The option is that I need to create one server, centralized server, and that centralized servers I'm going to use and deploy the monitoring tool. And for example, these are my servers which I need to monitor. So where this monitoring tool is installed, this will be going to become my monitoring server. And the server, the target, which I need to monitor. In this, I'm going to install an agent. A small software. This software responsibility to send the data, whatever the parameter you set, like after 1 hour, after 30 minutes, after 5 minutes, whatever you set, it will going to coordinate and send the data like this. It is a server to the your target to the your monitoring server, and all the logs will be captured at the monitoring server. Monitoring server is not just going to capture the logs, it's also going to provide you the dashboard. What is this dashboard? Dashboard will be going to provide you the top CPU utilizations, some parameter. You just create a dashboard via which, if you remember, if somebody working, you are able to see some monitoring teams. Did you see the monitoring team? When you see the monitoring team, did you see there is a big screens are there? television screens are there, or there's some dashboards are created, correct? So what that dashboard is going to do is something look like this. There are big screens are there, or there's some metrics are going on, and that metrics are monitored by the your monitoring team. And we are able to create the same dashboard via this CloudWatch as well. Yeah, Gafana, you can say that. Okay. So what we discussed till now? Alarm, which we use in auto scaling group. Correct. Did you events, which we use in Lambda? Correct or not correct, guys? We also have a logs, which we're going to cover. We also have a metrics. So what is metrics, guys? What is metrics? Some parameters via which we are going to monitor the system, correct? And in the task manager, if you're going to use a window, we have some predefined metrics, correct? So everybody aware about what it is? A either network parameter we are checking, that what is the network input output, disk utilization, disk input output, CPU utilization, memory utilization. These are the parameters via which we are monitoring our system. So can I say it is a fundamental building block for monitoring any resource? Can we say that? Without metrics, are you able to monitoring something? If, for example, if somebody say that I have a fever, how are you going to judge that person have a fever or not? You're going to use thermometer, and then you're going to record the reading, yes or no? So we need something via which we can judge, yes, there is a temperature or there is a increase of fuel in, like I'm driving a car, and when I'm going to understand that my car having low fuel, when my car indicator indicate me, correct, guys? So this metrics is very important to understand. If I'm going to talk about in a AWS how metrics work, it will going to create a namespace. Now you're going to ask me here, what is this namespace? Namespace, you can say that it's a container. It's like a container. Container of what? Like if I'm going to say that EC2, you need to monitor the EC2. So EC2 is a namespace where all the EC2 related metrics are listed. Clear? For example, if there are 2 servers are running, okay, all the 2 servers are up and running, and you need to monitor the resources like CPU, memory, whatever, CPU, disk utilization, network utilization. So where are you going to monitor it? When you go into the CloudWatch, you need to go to the metrics section, and in the metrics section, you need to go to the EC2 section, and then you're going to select the 2 particular servers which you wanted to monitor. So whatever, if there are 5 servers, it's also going to be placed under this namespace. Let me open the console quickly. So let me type here CloudWatch. And we have a metrics, correct? So these all are the metrics available. Let me open the pen and pencil. These are the metrics available. If you see here, it's talk about the DynamoDB. It's talk about the logs file. We are not going to use it. We need to go for the EC2. I think EC2 is not running. No, EC2 is not running. So that is why the metrics are not available for EC2. Where we created the EC2, let me go to the Mumbai if some EC2 is there. Yeah. See here, I created one EC2 long back. So EC2 section is available. So if I'm going to click here, it will go into, this is the EC2 is going to what? This EC2 is the namespace. This EC2 is the namespace under which there are predefined metrics are available. If I'm going to metrics means how you're going to monitor your server, like disk read, disk, all are the disk related, CPU related, and scroll down. There are multiple different parameters or metrics are available, which is predefined by the AWS. Okay, and let's talk about the which server you're talking about. So if you see that this is the server instant ID. So these instant ID the same. So these all parameter are related to this single server. Similarly, if there is a one more server is available, that server metrics is also available in the same below down. You're going to find the other server detail. But I think I only created one server. So no, see here. Now the IDs change 389. If I go up, it's changed to 57CF. So all the EC2, whatever the EC2 is running, it should be going to come in under this namespace. I'm hoping it is clear. This will going to become your namespace. In this namespace, all the metrics names are available, and this is the instant ID. So we use metrics, correct? In the metrics, basically what we collecting? We collecting the data points. We collected the data point. So what is this data point? We collected the data points now. What is this data point? If you remember, last week I discussed about one example. I log in into my system, capture and write down some information like at 8 a.m. CPU utilization is 80%, RAM utilization is 34%. What I am doing, I'm writing some information with the date, with the timing on my notebook, on my laptop, or somewhere I'm capturing it. Correct or not correct? Similarly, if the metrics are there, so metrics will be going to send the data. Correct? It's going to produce any data. So data is in the form of what? The data is going to consider as a data point. So we can say that it is a value or unit of measurement. Correct? If I say 90%, 90% is what? Is a measurement, na? So value means unit of measurement when at a given time span. Whatever time span you say that at 8 a.m. So this is the time span at which time span this metrics have what is the data value, correct? So how it is going to store? It will going to contain year first, month, and then it's going to capture the date. After that is going to capture what? After that is going to capture hours, minutes, and then is going to capture second. Is this sufficient? No, na. It's only going to talk about the time. It's only going to talk about time span. Correct. So if I'm going to see the clock right away, so what is the current time? Its current time is 8 o'clock 22 minutes. Correct. That is the time. So it is only going to talk about time. But where is my value? So value is going to contain in the message. It's also going to contain the message. And this message is basically going to capture the actual value. And combination of this both, this time span and is going to become your what? It's going to become your data point. I'm hoping you understand that. Okay, take an example. I will going to take a 2024. What is the month? I think 05. Date is 11. Correct. At what is this, guys? This is the time And then message, we can say that, consider that the message will be like, I will say that CPU utilization is 24%. So this will going to become your year. This will going to become your month. This is going to become your day. This will going to become your hour, minute, second, and this will going to become your value or message, you can say that. Now I'm going to ask you one more question. If I'm going to say that value of matrix is what, guys? This value versus threshold. If I'm going to ask this thing, do you able to answer me what is that? Value of matrix is equal to threshold. What is threshold? So if I'm going to say that, metrics are data about the performance of your system or service, whatever you're going to say that, I will consider it a system. Correct? And if I say that matrix is what? Time order set of data point, whatever the time order means, if 4 hour, whatever the data is, it is going to consider like that. Now, if I'm going to say that, what is the threshold? Let me consider a threshold value. So if you all are giving an exam, correct? And what is the passing criteria for any exam? 33%, 40%. And the marks is what? If I'm going to say that you all are studying, there are 2%, Rohit and Amit. Rohit get 80% marks, Amit get 90% marks, Sumit get 40% marks. These are the marks, or I will say 70%. Now, your board or your school, whatever university, create some categories. Which categories? Above 40 and equal to the 40 is pass. Correct? If the person get 75 to 85, it will be getting A grade. If the person is getting 85 to 100, the person will be A plus. If the person getting 65 to 75, it will be B plus. So what is this value? So these are the actual numbers. So these will be going to consider as a matrix. Data point for Rohit, yes or no? And this, what is this? Rohit get A grade. How are you going to define? This is the threshold set by your university, your college, your school. Okay, assume that. If you guys confused, no worry. Let me give you one more example. So this is your clock. So clock, everybody know what is clock? In this clock, well, 6, 3, 9, 1, 2, 4, 5, 7, 8, 10, 11. These are the what? These are the some parameters. You can say that something is written. Numbers are written via which you are able to identify your time. Correct? Via which you are able to identify the time. Now, if what is the time now, guys? If you see this clock, what is the time? So if I'm going to ask you Could you please check the clock and give me the time? So are you going to say that this is the matrix? Can you consider this a matrix value? Yes or no? After 1 hour, I again came to you and I'm going to ask, hey, could you please tell me the time? So at that time, what you find? Like this, some value is written. So at that time, what is the matrix value? Matrix value will be changed to 3. So matrix values depends upon the utilization. It's very correct. What is the threshold? Threshold is, for example, tomorrow morning, I need to take a flight at 8 a.m. I need to take a flight at 8 a.m. So what I'm going to do, guys? Tell me what I'm going to do. I am going to set a alarm. Yes or no? Either in my mobile phone, either in my alarm system if I buy it. Somewhere I need to set some alarm. Yes or no? Everybody doing it? So what is this alarm you set? For example, I set the alarm for 4 a.m. What did this alarm mean? Can I say that it is the threshold value you guys set? Can you consider alarm is a threshold value which you set? Now what going to be happen? The clock is moving like this, correct? In this direction. Once this small needle will reach to 4, alarm will be going to trigger. Yes or no? Why alarm will be going to trigger? Because you meeting this criteria, your matrix value, the value is equal to your threshold value. So whenever you reach to the threshold value, there is one alarm triggered. If you remember in the auto scaling group, what we done? We set some time like CPU utilization 52%. What is this 52? It is an alarm, a threshold you guys set. Yes or no? Correct. Understood now what is the difference between threshold? Great. Similarly, your car also have a threshold value because everybody driving a car. In my car, there are 2 threshold is automatically set. What is this 2 threshold is set in my car? Whenever I'm driving, okay, and my speed, when I started, my speed is 20 kilometer. This is what? The matrix value. And slowly, when I increase the speed, when my speed is reached to 80 kilometer per hour, I am going to receive a sound noise from my car, like beep sound. Beep. Why? Because in my car, there is a automatically threshold is set by the car manufacturer saying that if there is your car speed will be reached to 80 kilometer, it will going to sound. And when your speed is reached to 120 kilometer and above, then the beep sound will be continuously honking you, beep, 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 until you are not reducing the speed. Clear? I'm hoping these all are the value and the threshold which is you set to achieve some particular thing. Okay, so metrics we already know it is CPU utilization, network in out. We can talk about disk write, read. Everything is considered as a. It is for EC2 as a matrix, and every different service have a different metrics according to their service role and the performance. So when the metrics will be changed by default, every 30 seconds is a standard one. Every 630, not 60 second, not 30 second. Every 60 second, the data will be changed. Every 1 minute, it's going to check the performance and giving you the value. So whatever the metrics data, for example, it's going to keep the data. So let me open the screen. Okay, right now I'm in Mumbai. Currently, which region I am? I'm in Mumbai, correct? Let me go and see is I have some EC2 running or not running. Did you find any EC2? No, na? No EC2 is there. Correct. Let me go to the CloudWatch. Let me go to the metrics again. Let me go to the EC2. Currently, there is no server present either at the stop stage, either in running stage. Nothing is there. No server in any state. Nothing is running. But if you see here in this matrix, you are able to find that there are some server IDs are mentioned, correct? And there are two server IDs are mentioned. Why there are two server IDs are mentioned? Because matrix will be going to store the data for 15 months. Understood or not understood? Matrix will be going to keep the data for last 15 months. In Singapore, I didn't find any namespace call it out EC2. Why? Because last 15 months, I didn't start any server. I'm hoping it is clear. Okay. So that is your metrics. And I think you already know. Now, we already know events. So that is already covered. We already know alarm, which we already done at auto scaling group, Lambda, and metrics. We just covered what is metrics. Now we are going to discuss about the logs. What is this logs? What is this logs, guys? Any idea, guys? What is logs? If I'm going to ask you logs, I'm talking about this portion. Okay. Now, if you see there are two log groups are there. I'm going to explain you what is log group in a second. Just wait. Some information is written. And if I'm going to click here and go inside it, I'm going to find some log streams. And when I click this log stream, there are multiple logs are stored. Log event are stored. Okay. Log group, log stream, and log event. If I click here, what is this, guys? Time span. How the time span work? Year, month, date, hour, minute, second. Okay. And it is also going to capture some message. So these log are for what? If you read this log, you're going to identify that it's talk about initializing the Python this. So that means we are running some Lambda. I think we are checking the Lambda log. Okay, so the Lambda we run, so Lambda captures that information and it will going to store the log file, and that log will be going to store in the CloudWatch. Clear? So logs are nothing more than just collecting and managing the centralized logging system. Login means I'm not talking about username and password login. I'm talking about the logs from your system. Correct? The matrix value is the current resource utilization at the given time frame, and threshold value you set, like you wanted to monitoring something and you need to say that if 80% utilization is, please inform me. If 20% utilization is there, please inform me. Drop me a message, send me SMS notification. So it totally depends upon you how you wanted to configure it. Okay. So why the logs are very, very important and why we required it. Logs are going to help you to capture the logs from your system. Correct. It is help you to capture from your system. So any kind of information which you're going to capture is tracking and validate the events, correct? Anything, any purpose, anything you happen. For example, we have one server. Okay. In the server, you can identify that there are lots of different logs files are created. If it is a Linux, you're going to find that there is a one log folder is available where all the logs will be captured. In the var logs, you're going to find the all the application related logs will be stored here. Depends upon your type of data you're going to store. Okay, whatever event is happening, it will going to store. So assume that I have multiple servers. And now my boss asked me, hey Rohit, could you please tell me the all the 10 logs and provide me the login into the all the 10 servers and provide me the log information. So it is very tedious job for me to log in into each and every machine, see what is the current logs, and assume that if this server crash, is I am able to check the logs? No, na, because the where the log store under this server. If this server is no longer available, did I am able to see the log file? No, na, I'm not able to identify it. Similarly, if some security team required some audit, whatever the logs are there, so we are not able to identify it. Correct. Why? Because the server is already crashed. We don't have logs present. So what is the solution here? So solution here, you can create one more server. This server is a central server. Central server for what? For the log collection. This server going to collect the logs from these target accounts. Agent will be running here in all the machine. And agent role is what? Whatever the time frame you set, okay, it will going to send the log at this central location. So if somebody going to ask me, could you please send me the log file? So I am via this, I just need to log in into this machine, central machine, and I'm able to see the log, correct? Similar way, CloudWatch is also providing the same level of feature. It will, you can upload your system logs over the CloudWatch via which you can centrally manage your log system. Clear, guys? Not only for the EC2, not only for the EC2, assume that on-prem is there or data center is there and AWS is there. If some servers are running here, when you're going to install the agent here, CloudWatch agent you need to install. This agent will be going to capture the information like log files, or if you want to monitor CPU memory, whatever, it will going to connect it. It's need to be connected each other. It will going to send the message through this link, and the CloudWatch is running here, and it will going to send the all the logs into central location so that you are able to create any threshold, any alarm. If any information you see that it is corrupted, it will be going to drop a mail. So it is a central location where you're going to manage your logs. Okay. Now, as when I'm opening the console, you can find that there are multiple things are available. Okay. There are multiple things are available like log group, log stream, log event. What is this log stream log event? What is this? So let's talk about first log event. What is this log event? So one single event at a given time frame, it's happen. That event is known as log event. If I'm going to say hi, that is one event capture, date with the time, and the message that is going to what? Value is equal to what? Event. Clear, guys? Yes or no? So if you open this log event, what you find at this time frame, this action will be performed. This is the message. correct? It is known as timestamp plus message is equal to log event. Clear? So assume that there is a one server, one event happen at the given time frame, it will going to capture as a log event. Clear? And log event might be multiple log event are there in the given time frame. Like if I say that 15 minute, 20 minute, whatever the log time frame, this is the log event is created. That is not log events. What is this log stream? Let me go back. What is this log stream? So there are two log streams are there. One, two. Let me open one log stream. So log stream is what? Multiple events. What is this, guys? There are multiple events. So first one log event created, message and time, and multiple log event combined together. Like from one server, there are multiple log event. It is going to be considered as a log stream. Time span is nothing, is just year, month, date, hour, minute, second. At what given time, what is the message you receive? Clear? Clear or not clear? Data point contain what? Time span plus message. At what given time span you receive this message, or the message will be generated at the your system level or any service level. At what given time frame? Whatever the time frame it is generated, it is known as time span. Okay. So multiple log event is going to be considered as a log stream, and multiple log stream is known as log group. I'm hoping it is clear, guys. Okay. As I may already mentioned that data centers, server running in this server, assume that there are two files, var log. What is the name I'm going to secure? There is a one file name secure. One file we can going to consider for var log. One more I can say that message or error log. I can message is better. Message. There are two files are there. Okay. When the agent I am going to configure, I'm going to show you the how we're going to configure the agent as well. These two log files I captured and say that you need to send the information. Via these two names, there are two log groups are created. One is the secure, one is the message. Whatever the name I'm going to define. So assume that I define message and secure. This is going to be two log group are created. Now in this log group, what going to be happen? Event will be going to start populated, and according to the date and time, there is a log streams will be going to created. There are multiple log streams will be going to create, and this log stream will be going to capture the logs. I'm hoping it is clear, guys. Okay. Before going ahead and performing the demo, let me talk about the dashboard. I'm going to show you the logs demo. Just hold on a moment. Before that, let me discuss about the dashboard. What does this dashboard mean? And why we require dashboard? As I already mentioned, that dashboard will be going to help you to capture and create a customized dashboard. Dashboard might be you're going to capture the 5 critical servers. You have total 10 server. Out of 10 server, the 5 is more critical. So only 5 servers you want to see on the screen. So you can create that. what information you need to capture. CPU. If somebody say no, I need to capture disk. Somebody say no, I need to also capture network. Somebody say no, I need to capture some other event metrics. So accordingly you can create it. So let me create the dashboard. So right, first of all, I'm going here, create a dashboard, name the dashboard. I'm going to put test, create a dashboard. Now, what is this, guys? How you wanted to represent your data in the dashboard? Are you going to looking for this line graph? Are you want to see this number like 75%, 60%? Correct? Or you wanted to see this type of information, or you wanted to look for the data table? So this how you want to represent your data on the screen. Accordingly, you can select. Okay, so I choose line. Click next. In this case, you need to choose the metrics because on the metrics basis you're going to monitor. So let me choose this EC2. And I have a 2 EC2. Let me choose the CPU utilization. But right now I don't have any server. Let me create it, then I'm going to discuss it. So I will say that CPU utilization of this server and CPU utilization of this server. Create a wizard. So here I capture what? CPU utilization, one dashboard I am creating, the test dashboard. So it will going to open into the what? Open into where, guys? It is going to open into the big screen. Okay. It is going to look like this, or you can create one more here. You can multiple see. But how it is going to represent the data? If you see here, there are two color represented, yellow color or blue color. Yellow is denoted this server, blue is denoted this server. So how it is going to capture the information? It will going to capture like this graph. Okay. And then it will going to capture other yellow, blue color, any data. The graph will be going to represent like this. Clear? I'm hoping you get that information, that how it's going to represent, because currently we don't have any server running. So I'm just going to show you how it is represent. Okay. So if you want to save this, you can save it. If you want to add another in the same graph, you can add it. Like I'm going to say that number next, and I'm going to say that same EC2 I'm going to check. But in this time, I'm going to check the percentage level. So percentage level of, I will say that same thing. Let me just give you some understanding. If there are 10 server running, all the 10 server you can select and create it. So now see, in the same dashboard, you just need to add here. Okay. And the new things is give you the what graph you required. So in the same dashboard, I chooses one CPU utilization. If you have a network utilization you need to add, you can add here. So accordingly, whatever the customization you need to do for your dashboard, you can create it. In this case, I choose the number percentage. So how the value will be going to represent? Value going to represent like this, 25%. And in this case, it will going to represent 70%, whatever the value actually. Okay. In this case, it is talk about the numbers. Clear, guys? If you want to add more other one, you can choose which type of data you wanted to see, bar chart, whatever the information, how you wanted to represent your data, you can select that, and accordingly it's going to represent your data. Nothing else. That is known as dashboard, nothing else. So in this case, it will going to talk about bar chart like this. Okay, I'm hoping you understand that. Dashboard is nothing, it's just a big screens are running on that, the dashboard, whatever the customization, custom dashboard you create, it will going to represent that. And you can create multiple dashboard. It is not like one dashboard is required. You can create other dashboard as well, because might be you have 2, 5, 6 screens. So accordingly, you can create it. So knock team. Let me open the Google and let me show you if I found it. Images. If you see, these are the screens are running. This is the pie chart running here. It is pie chart running here. There is some other information. So they customize their dashboard. These all are the dashboards. And there are 6 screens are installed. Similarly, there are different types of customization you can done according to your requirement. Okay. These are, if you see, these are all the graphs monitoring all are seeing here. When I'm working in different organization, when I'm not working as a cloud architect, at that time when I'm working in DC, there is a monitoring team are sitting who is monitoring the same thing via some tools and dashboards are installed. I'm opening this clear. Let me close it. Let me do one thing. Let me create one server quickly so that we can to perform one demo. Let me open the EC2 and start the EC2. Test server. So what we are going to do, guys? Now we are going to create one server and we have a CloudWatch. Okay. In this server, we are going to install the agent. This agent will be going to coordinate with the CloudWatch. So I'm going to tell you how you're going to install the agent. Server is up and running. Let me log into this server. So let me perform the demo. There are multiple ways. Nowadays, System Manager is also there, which help you to install directly and manage your system via the System Manager. So what we need to do, first of all, I need to install the agent. So this is the Linux machine. So what I need to do, I need to download it, or either I can use the yum command to install it. Okay, so I will use the link via which you can download it, and then I'm going to use the RPM command. So where I am right now, I am in root directory and no file is available. So I'm going to use wget command, and there is a predefined directories are given by the AWS from where you can use it. I pasted the link and the download of the agent is started. If you see here, it's a wget. Wget is going to help you to get the some data, whatever you're going to download. So I am going to download this RPM file. Which RPM file? Amazon CloudWatch agent. Okay, RPM. I'm going to download this software. So let me, is downloading is completed. See here, it is already downloaded, saved. Let me check it is saved or not saved. Are you able to see here? The agent is already installed. Not installed, download. Download is done. Once you download your RPM file or agent file, like for example, if you're going to use window thing. So first of all, what you're going to do, you're going to download some software. After download, what you're going to do, you're going to run that. So same thing, I'm going to execute or run this thing. So I'm going to use sudo I'm already on. So I'm going to use the RPM command. I'm going to use RPM command to install this. So let me press enter. And it will going to install the software. So we have to wait. So RPM is installed my software. So when you install the software, there are one file is created or folder is created in the OPTs directly. So let me go to the OPT directory, cd opt AWS, and then I'm going to search Amazon. Did you see CloudWatch agent is available now? Because we installed the agent, so it is going to install the OPT AWS, and just click double tap, it will going to appear it. So let me see here. It is not go. What happened? I done wrong command. See, I've come in under this folder and I find there are multiple folders and files are placed. I need to go in inside the bin, and inside the bin you're going to find that there are multiple files are available, which is executed files. If you see here, you can find that configuration wizard. I need to run this configuration wizard to install my and configure my agent. Basically, agent is already there, but I need to configure that agent. Okay, so how I'm going to do that? I'm going to just execute the this is a script. I need to execute it. So instead of I need to give the path. So let me copy this path. Let me run this path and paste this. Enter it. Once you enter it, the script start running, and script is going to ask you few questions, and that question answer you need to provide. If you read here, it say that welcome to the AWS agent configuration manager, which help you to configure your resources. So what is the first question it's asked? It's going to ask you, because whenever you're going to enter some information, it will going to create a JSON file. Okay, so it will going to create a JSON file, whatever the input you put. What is the first question? Read here. On which operating system you are planning to use this agent? So it is a Linux one, Windows one. So whatever the operating system you are using. So I'm going to say Linux. So I'm going to press 1, and by default value is 1. So no need to be press it. So let me enter it, because by default value is what which selected 1. So 1 it what? 1 is our Linux box. So I don't require to enter anything. If you want to overwrite this information by default value, you can write 1 and enter it. Now try to fetch the default region based on the EC2 metadata. Okay. So are you wanted to try to, or you wanted to give that it is a EC2 running on the AWS, or it is a on-prem server? So as I mentioned, this agent you can also install, same process you need to do, and this agent you also able to install at on-prem server data center. So our is EC2, so I need to select 1, correct? So by default value is also 1. I'm not going to change it. Enter. Which user are you planning to run the agent? Because if you see that there is a, when I install this agent, there is one user created. Where is that? See here, create a group, create a user. If you focus here, when I install this RM file, what going to be happen? It's created one user and created one group. Are you want to use this? Okay, are you want to use this user, or you want to use root user? According to you, I'm going to say 2. I wanted to use the root one. It's up to you. one to as per your configuration. Because normally when we talk about the monitoring system, a monitoring team created one different user which have the permission to capture this information, and via that user they are capturing and they are running their agent. Which port do you want to? It's going to run one SSD, means state D. State D is a daemon which is going to capture the state information from your system. So this state D daemon is going to run in some port number. So that port number you need to select. Not going to select anything. Whatever the by default value that will I'm going to present it. Now, what is the collection interval from the state D daemon? So how means 1 second? It's going to talk about 10 second, 30 seconds, 60 second, how you wanted to configure and the data will be captured. I will say 10 second, whatever the by default value, I'm going to keep it. Or you're going to change it, I will say every 30 second. Enter. So value I change from 1 to 2 I put. Now, again I'm going to put the 30 second or for 60 seconds. Same thing. Do you want to monitor the metrics collectivity? Or you want to metrics is, or you want to run some metrics like RAM utilization or another utilization you wanted to perform? So I will say yes. Do you want to monitor any host metrics, CPU memory, etc.? I say yes, I need to monitor it. Do you want to monitor CPU metrics per core? Yes, there are different cores are there and I need to monitor the per core value. So I will say yes. So it is going to ask you multiple questions. Accordingly, you need to answer it. And once you answer it, it will going to configure the system. I'm hoping you understanding what we are doing, correct? Now, what information you need to capture? Are it's going to information image ID, instant ID, or you wanted to capture that? I will say yes. Instant ID, I will say yes. What will the like to collect your metrics at the high resolution? Means what is the by default value you want to select? I select 4. Every 1 minute you can capture all the metrics which include CPU memory and other related metrics. It's going to collect the metrics every 60 seconds. If you want to increase the or reduce the time, the minimum time is 1 second. But if you're going to set the 1 second, you need to pay more because lots of data will be captured. Which default metrics configure do you want? Means basic, standard, or advanced. So how you wanted to capture the information? Done. So I will mention that it is going to create a JSON file. If you see, it is creating a JSON file and is asking us to please review is everything is correct or not correct. If you see here, we mentioned the user root. We mentioned the 60-second interval to collect the information. We mentioned that you need to collect the instant ID. So whatever we pass above, it will going to create a JSON format file. And this is the JSON format file. It will going to create a memory, CPU utilization, sorry. It will going to use the CPU utilization, idle IO user system. These are the metrics is going to measure. Similarly for the disk also it's going to monitor this one. Memory also is going to check that. Network information is also going to check it. Swap value is also going to check it. So by default, memory and swap is automatically not collected. So for that, you need to install the agent. And via that, you can enable the memory utilization as well. So if you find that above data is okay, then you need to press yes, data is correct. Do you want to execute CloudWatch log agent configuration file to import from migrate? I will say no, I don't have any cloud logs are already running. So I need to create new. So I will say no, I don't want to migrate any data. Do you want to monitor any log files? Now it's talk about the log files. So now whatever we discuss until now, we just configuring the metrics. Now it's talk about the log files. So if I'm going to select here log file, it will going to capture the log file into where? It will going to capture in the log section of the CloudWatch. It will going to create a log group. It will going to create a log stream. It will going to capture the log event if any event is there. So this is the portion which I'm talking about. Now, if I say yes, I need to monitoring my log file. Any file you can monitor. So I will say yes. So it's going to ask me and saying that, hey, could you please provide me the path? Because which file you want to monitor. So I need to provide the path where log, I think secure is one of the file which I remember. So I'm going to use this file. I think spelling is correct. The spelling need to be correct. If spelling is not going to be correct, it's not going to capture any information. So press enter. Now, what is the log group? I talk about now. You can put your log group name as well. So if you wanted to put any log group name, or by default it's saying that secure will be there. According, if I enter only press enter, it will going to use the secure is a by default. If you want to customize the name as well, you can provide here, and the log group will be created with the whatever the value you're going to put here. I'm going to say enter secure now. So log group class standard or infrequent access. Now you need to understand that, because log group is going to store your data, correct? Or this data will be standard means very frequently accessed, same concept, or infrequent access. So we recommend that if you're going to put the infrequent ones, the data is not going to be accessed for next 30 days or 60 days, then you're going to move to the infrequent. If you say that no data I'm going to read immediately, so always recommended to use the standard one. So I'm going to use the standard storage type. And what is the log stream name you wanted to put? After that, what is going to create, guys? First log group, correct? And then log stream. So you can put the log stream name as well. So I will put that what is the instant ID, create that. So I'm going to say enter. Now we created the log group, done. So log group will be going to capture my information, that is also done. We created a log group. Log group will be going to capture my log file, secure file, done. We created log stream, done. But what is this, Rohit? This is known as how long you need to keep this data stored in your CloudWatch logs. How long you want to keep this data to be stored in your logs, CloudWatch logs. So retention period. -0 means what? Never expire. Okay, data never going to be deleted. 1 day, 3 days, 5 days, 7 days, 14 days, 30 days, 60 days, 90 days. According to your use case, you can choose it. So right now I'm going to say 1, it is never expire. It will not going to expire anytime. Data will be going to remain. And according to your use case, you can customize it. But HTTP need to be there. If HTTP is not there, then it is not going to capture. We did install the HTTP, na? CD where log. Let me go inside and see. Secure is there? Yeah, secure is there. So we are not worried about it. Secure is there. What else? So let me capture this message as well. Correct. These two files I will create. So let me copy this message name as well. Nah? Spelling should be correct. If spelling mistake is there, then it is not going to work. I will say yes, I need to capture it. Now I need to give the path var log, and then I'm going to put, sorry, I'm going to put this message. Now it is going to ask you what is a log group. I'm going to say message. It will going to say standard, infrequent. I will say standard. What is the log stream? I'm going to keep by default value. One value I'm going to never expire it. Okay. So in this case, I'm going to say no, I don't require any other. No, I don't want it to X-ray. Yeah, I need to store this in SMS parameter store. So I will say yes, I need to store it in a parameter. I'm going to use the same name. I don't want to change it. It will going to create a parameter. And because what? Because right now I'm using one file. I'm going to create one file. Which file? This file I created. Okay. One agent file I created. Because JSON file I created, na, see here above. So there is a one JSON file is created. This JSON file. Okay. Are you want to store this JSON file locally or you want to store somewhere else, like parameter store? So I will say, no, I need to store this parameter store. Why I'm storing it? If I need to use the same configuration somewhere else, I can refer it as well. Okay. So I'm going to create this parameter same name. Okay. AP South 1. I think we are in AP South 1, correct? We are Mumbai, AP South 1, no? Correct? Okay, I forget to create this. Okay, so let me do one thing. Let me not create it because I need to create a AWS KMS key. That is the problem happen. Error happen. I need to run it again. My mistake because I didn't create access key. So I thought I will choose it. So I didn't create this. I need to do it again. So let me choose by default value, whatever the by default value is there. Let me keep it. Last time I done some configuration changes. This time let me keep whatever the value is there. I think spelling is correct. Great. Now done. Now, so there is one file is created. Okay. So let me create ll command. Run the ll command. Did you find here some JSON file? Guys, tell me, did you find some JSON file is created? So when it is modify, today it is modify, correct? So let me open this. This is the what we are talking about. Yes, this is the file which is just created for us. So this is the file, whatever the value we set, it is captured here and all the information will be stored here. Now, what we need to do now, we need to create, we need to execute this agent. Until now, what we done, we just configure the values, every value is there, everything is perfectly fine, but we need to run this command as well. Means I need to start this agent. Okay, and how I'm going to start this agent? I need to run the command. So let me, I think CTL is there. I need to long back I run it. Yeah. So this is the file. Okay, this is the file you need to run. So let me, first of all, let me go to this pwd, copy this. I need to start the agent. Now I need to pass the some parameters like a fetch the configuration. I think fetch the configuration. Sorry, I forget the commands. Let me try it. If it is not working, then I need to check. Let me check it is run on. If not, then I need to check. There is some mistake I done. I forget some step. Then I need to check what step I done. Let me check it is configured or not configured. So it will going to sync the file here if all is working good. but we need to wait for 1 minute or 2 minutes. Then the file log group will be appeared here. Okay, so we have to wait. So meanwhile, our configuration is done, and then I'm going to come back and see if some mistake I done. I think some technical issue I done. I had some command I run wrong. So if the command is I run wrong or some process change, let me search the new process. Just hold on. CloudWatch agent installation. So let me check some new process, might be some process change. Time to time, AWS will update the process. So we have to read that. Okay. So one as I mentioned that either you use the yum command. Okay. The same thing we can use it. After that, okay, command line, we use this command line version. So let me go to the command line version. Okay, command line configuration, download and configure the CloudWatch agent. So for downloading, if you see here, you go down, accordingly the path will be given. If you see, there are different paths are given from where you can download your latest version of RPM. Okay, there is a different path are given. Downloading links are given from where you can download your. You can download also. There are two way. Either you can download. If you see here, what is written, guys? It mentioned that either you use the wget command. Okay, same thing I done. I use the wget and the downloading link. Downloading link is available here. Either you use that path process, or either you can use this yum command process. Both will be going to install the this agent only. After that, you need to run the YAML file. Okay, same thing. It is talking about how you're going to install it. Like this command we use, correct? This command we use sudo rpm this command. So both way you can do that. There are both options are available. Okay, create and modify the agent file configuration. So that we need to do. So it will going to create a JSON file. Agent configuration file JSON will be specific. It will going to configure that we already done it. Okay. With the wizard, so it will going to tell you how you're going to run it. Okay, access key, and this one I didn't create it. So this portion is a new thing. Previously we don't required it. So this is the new thing added. So that this agent, the access key and the security key is there. So we didn't create it and we didn't apply it. If you remember, it's asked me to use the access key and this secret key, but I don't have it. So I didn't apply it. And it will going to ask the reason. So same thing we done, and the same thing, if you remember, the same command we use sudo, and we use the same command agent wizard we are running the same agent wizard we use in our command line. If I'm going, let me open my command line. So let me go to the ll, not here. Did you see this agent wizard? So AWS is also saying that use this. We are using the same thing, same agent wizard we are used. So they are talking about if you are in a Linux one, if you are in a Windows one, how you're going to run it. And it's going to talk about what was tab, what configuration you need to done. So these are the metrics which you need to select. They're talking about which thing. In the basic, this memory uses percentage, standard, these things are going to monitor, advanced, these things are be monitored. So we selected the basic standard. We have this option came. So if you're going to choose advanced, these many things are going to be monitored. It is very, very important to understand what thing will be going to configure and what parameter means what. Okay. Or you can create them manually or edit the CloudFront agent. Okay. So both you can do that. So let me go to the next topic. So it will going to say that. So there are multiple methods are giving. So I need to read it again because something is changed. So all the process is written. So it says the AWS SMS put parameter. So this is the parameter as we already using. If you remember in the first command, I'm using SMS parameter, but I didn't create access key. So if I have a access key, then I can use that, and I'm going to upload my parameter store. I'm using this parameter store, and I'm going to store that. Once it is done, the configuration is done, then you're going to find that folder will be created here. Okay, one folder is a secure folder and the one is the message one, and the log file, whatever we're going to create, it will going to be created here. So I don't created any key, so that is why we are not able to do that. I'm hoping you understand the concept. What is the CloudWatch, how the event happen, what the log files, what is the alarms, we already discussed it in the, and what is the dashboard.
Just a quick info guys, Intellipaat offers an AWS DevOps certification course. With this program, you'll get trained in AWS services, CI/CD pipelines, infrastructure as code, containerization with Docker and Kubernetes, monitoring with CloudWatch, and much more, all through real-world projects and case studies. The course is taught by certified trainers and industry leaders who guide you with hands-on labs and practical assignments, ensuring you're fully job ready. With this program, Intellipaat has already helped thousands of learners transition into high-paying DevOps roles, and you can check out their success stories on our Achievers channel. Link is given in the description below. So if you're looking to build a strong career in AWS DevOps, this course can be your perfect launchpad. Visit the course page link in the description below and take the first step towards becoming a certified AWS DevOps engineer.
Why do we combine AWS and DevOps? AWS and DevOps are combined because AWS provides the infrastructure that is required to run an application, and DevOps, on the other hand, focuses on making sure that the development and operations team are working together. This combination ensures that whenever an update is made to an application, it is deployed and updated across all servers quickly, which in turn minimizes the downtime and increases user satisfaction. Moving on to our next question. So now let's start with our second question, that is, name 3 popular AWS services and their purposes. So there are a lot of AWS services out there that you can name, but make sure that the services that you are naming, you're familiar with them, because I've said this before that whatever answer you're going to give, the interviewer is going to ask that the next question based on the previous answer that you gave. So the services that you're going to name, make sure that A, they're popular, B, you know about them. So the 3 that I'm going to choose here is EC2 instance, S3 bucket, and RDS or relational database, which again is very famous and very popular. So an EC2 instance is used for scalable virtual server hosting. That is, you can host a virtual network, or it's like a virtual PC that you have on the AWS cloud EC2 instance. S3 bucket is used for object storage to store and retrieve files. S3 buckets are where it's storage. It's not a computer like EC2 instance. It's where you can store both unstructured and structured data inside S3 buckets. Then there is RDS. RDS provides a lot of databases. There is SQL, MySQL, MariaDB, PostgreSQL, Amazon Azure is also there. So there are a lot of databases that you can find inside RDS and put them into use. So now let's move on to our next question. Obviously, what is an EC2 instance? You answered it, now it becomes a question. So, an EC2 instance, like I said before, it's a virtual server or a computer which is provided to you by AWS. The best part about EC2 instance is that it allows users to rent virtual computing resources. What is virtual computing resources? Virtual computing resources are the CPU, memory, storage, and network that you can get on or you can host on your EC2 instance. And based on the workload, it can be scaled up or down. What does this mean? Say you have CPU, RAM, and your database. These are the computational resources or the virtual computing resources that this EC2 instance is providing you. Now, based on the traffic on your website, say it's a Christmas season, and there is a lot of traffic coming on your website, and this computational resources will not be enough for you. You need to increase the number of databases, you need to improve the computing power and the RAM. So what you can do with an EC2 instance is that you can scale it up, meaning you can add more CPU or more RAM or more databases according to how much you want. And then you can decrease them just as easily as you increase them. That is the major benefit of using an EC2 instance. Moving on to our next question. What is an S3 bucket and what is it commonly used for? S3 bucket, as discussed previously, is a container in AWS that is used to store various objects. Like I said, S3 buckets can store both structured and unstructured data. Another interesting fact about S3 buckets is that you can even host your static websites on an S3 bucket. You can also store files like files, images, videos, etc. Like I said, structured and unstructured data. Now, what is it commonly used for? It's obviously used for storing and backing up data, huge amounts of data, hosting static website like I talked before, and storing large amounts of unstructured data like your videos, images, etc. Moving on to our next question. How does an availability zone differ from a region? Now, a region is a geographical area which is separate and independent physical location. Look at this example. Now we have two regions in this example. This is region 1 and this is region 2. Look at how they are independent of each other and they are different. There is no connection between the two of them. Availability zone, on the other hand, is located inside a region and is equipped with independent power and networking. How? Let me show you how. So we already talked about regions. Now availability zone is located inside a region where these are availability zones. This is how availability zones look like. This is your region, this is your region 2. Now in region 1, you have 4 different availability zones and look how they're all connected to each other and they all have enough independent power and networking to work on their own. Same goes for region 2. Here there are 3 availability zones and look at how they have their individual servers to keep them working. Now why do we need so many availability zones when we have regions? It is there to increase the fault tolerance. Say if this one availability zone fails, then the traffic can be rerouted to these 3. Meaning that this region will keep on working even if one of the availability zones fail. That's why you need so many availability zones inside the regions. So it ensures high availability and fault tolerance like I talked about. Moving on to our next question. What is DevOps in simple terms? DevOps, as the name suggests, it is a combination of development and operations. So DevOps combines the principles of development or dev and operations ops and becomes DevOps. So development part have your coding, planning, building and testing, and operations have your releasing, deploying, operating and monitoring. When you combine these two together, you get DevOps. It improves the collaboration, automate workflows and ensure faster delivery of high quality software. If you must have studied even a little bit about software engineering, you must have heard about the waterfall model, in which you cannot go back to the previous step. You only keep on going forward. So what DevOps essentially solves is when you're continuously developing and you're continuously testing it at the same time, if there were any changes or any adjustments, you will detect it at a very early stage. But if you're following the waterfall model, then once you have developed everything and then you're testing at the very end and then you realize ki, oh, this feature was supposed to be there but it's not. So that's like it gets too late. Even if you were to change anything, it would get too late. Another problem is that if you wanted to add any new features and your product has already developed now and now there is no going back. So the new feature that you thought about that you should add, you will never be able to add it. So all of these problems are solved with DevOps. When you're developing and your operations team is continuously testing it, so in that case, all of these adjustments become minute adjustments and they can be solved at a very early stage or they can be accommodated at a very early stage. So there are a lot of DevOps tools, very famous DevOps tools like Terraform and CloudFormation, which provides infrastructure as a code. We'll discuss more about what those are in the upcoming questions. But when you're giving an interview, don't talk too much. Don't talk about the terms you're not familiar with. But just so that when this topic comes in the later sections, you won't be surprised. That's why I just introduced it. Terraform and CloudFormation provides infrastructure as a code. I'll tell you what they are in the upcoming slides. So DevOps also focuses on continuous integration, continuous delivery, and automation. Continuous integration, as in whatever changes are being made, continuously they are getting integrated to your software. Continuous delivery, as soon as the changes are integrated into your application or software, it is delivered to the end users as well, like version 1, version 1.0, version 1.1 in such a way. And automation is tools like Terraform and CloudFormation. It can do this repetitive work for you, which saves a lot of time. Moving on, why is automation important in DevOps? Before you understand why it is important, you need to know what automation is. I already told you they are the tools. Automation refers to the tools and the scripts, like Terraform is there, CloudFormation is there, Jenkins is there, GitHub Actions. All of these are the famous tools which are used for automation in DevOps. What these tools do is that, Say I was building an application. I'll give you a very simple example. I'm building an application. I've uploaded the code into GitHub. Now, what these automation tools do is, as soon as I push new changes into my repository, the end users, the changes will immediately be reflected to the end user's system. I'm using the application. My user is using the application. As soon as I make any change, the change will be reflected in the user's system after testing and everything. This automation, I didn't make them see the application immediately on their screens. It was automated. It was done using these applications. So that is automation. Coming back to your question, why is it important? It reduces manual efforts a lot, speeds up processes like testing, deployment, and scaling. You don't have to manually write there, enter testing details. It will just do it for you. And as soon as the testing phase is done, it will push the changes into the main application, which is visible on the end user's devices. It ensures consistency across all environments. Since the manual errors have decreased, so the consistency will also increase. It frees up teams to focus on strategic tasks instead of repetitive work. Like I said, these automation tools makes your lives a lot more simpler by eradicating, sometimes you just have to do the repetitive work all over again. So that can take a huge part of your time and impact your productivity significantly. But if you use automation tools, they can perform these repetitive tasks at a much faster and efficient rate, which will free up your teams to focus on the strategic task, meaning your team is more likely to come up with better ideas and better ways if you use automation. Moving on to our next question, name 2 tools commonly used for version control in DevOps. The 2 tools most commonly used in DevOps is naturally Git and GitHub. They might seem a bit similar, especially for beginners, but they're not. Git is a distributed version control system to track code changes, and GitHub is a platform for managing Git repositories and collaboration among teams. I'll tell you one major difference which cleared the difference in my head. I hope it helps for you also. Git, you can use it offline. GitHub, you cannot use it offline. GitHub, you need internet connectivity to use because it's a whole platform. Git, you can just make your code changes locally as well, in your local server as well. That's why it can function offline also. But GitHub, since it's a whole platform, you need internet connection. So if you're pushing your code into a GitHub repository, you need internet connection. But if it's a Git repository, then you can do it offline as well. Next, Git is focused on version control and code management, whereas GitHub, although GitHub also does version control and code management, additionally, it provides a collaborative platform with features like project management, issue tracking, and code reviews, enhancing team collaboration. So if you're working with a team, obviously you need to go with GitHub. But if you're working individually, you can go with Git. Moving on to our next question, what is a CI/CD pipeline and why is it useful? What is a CI/CD pipeline? A CI/CD pipeline automates the process of integrating code changes and delivering them to the production. Integrating whatever changes have been made and delivering it to the end users. Or in the diagram format, it might look like this. CI/CD. Your continuous integration is your development part. Your continuous deployment is your operations part. Now, the integrating code changes is your continuous integration and delivering them to production is your continuous deployment. Now, to answer the part as why is it useful? It ensures faster and reliable code delivery, reduces integration issues by testing changes frequently because as soon as an update is made, firstly it gets tested and only then does it get released. Enables rapid feedback loop for developers because the integration and deployment is happening so fast that as soon as you make the change, you can see whatever has changed in the actual website. And then it streamlines the release process. Also, there is no halting anywhere. Everything is happening so rapidly that the entire deployment process becomes very smooth and efficient. Moving on to our next question. What does infrastructure as a code mean? It is the practice of managing and provisioning infrastructure using code instead of manual processes. So in very simple terms, it is when you have a certain amount of requirements. That's the same amount of requirement you want for, say, this PC, another PC, the third PC and everything. You need the same specs. You need the same CPU, the same RAM. So if you document it somewhere, then you don't have to remember it the whole time. That's exactly how infrastructure as a code works. When you document that I want the CPU to be of this much, I want CPU, this much RAM I need, this much storage I need, these many servers I need. If you write it in the form of code, then your infrastructure, that is your application, is being developed from a code. So that is infrastructure as a code. So your servers, networks, and databases, you can document all of this or you can type them out in the form of code. So that's your server, network, and database. And these together become your infrastructure. and those can be typed out in the form of code. That is infrastructure as a code. Now, there are popular tools like Terraform and CloudFormation. CloudFormation is AWS's tool, and there is Terraform also, which you can use where infrastructure as a code is provided. So there's a template in JSON and YAML format in CloudFormation, and you can write JSON format. You must know, if you've worked in full stack, you must know about JSON format. So you can just type it down in JSON format, ki CPU this much, RAM this much, and then you can just upload that file on your CloudFormation. And CloudFormation will automatically generate, like if I've written I need 2 EC2 instance in my code, as soon as I upload that JSON file into my CloudFormation, CloudFormation will automatically allocate me 2 EC2 instances because it was written in my code. That's how efficient infrastructure as a code is. Moving on to our next question. What is AWS CodePipeline and what problem does it solve? So AWS CodePipeline is basically, we talked about CI/CD. So that pipeline, that whole managing process is called as AWS CodePipeline. Let's see how it works. AWS CodePipeline enables you to build, test, and deploy code changes effectively. Focus on the words build, test, and deploy, because that is basically the whole definition of AWS CodePipeline. Now, what it does is, say, like we talked about, I was deploying my application on GitHub. So I pushed some changes into the source code. Now, what AWS CodePipeline does is that it downloads all the changes that I made in GitHub, all of that changes, it downloads it from the source file. Source file meaning the file in which I made the changes. Then it builds the file. This is again CodePipeline. So this is again the build stage where CodePipeline builds the application. Next, it tests the application just to make sure that everything is working smoothly and efficiently as it was expected. It tests the application based on the test cases that you provided or by default. And then CodeDeploy deploys this application to the end users who are using the application or to the servers. That is how AWS CodePipeline works. Now, what problem does it solve? It reduces manual intervention in deployment process workflow. If you look at the code here also, in none of the stages manual intervention was required, except the first stage in which you were updating the code. After that, everything was automated. CodePipeline downloaded the files, CodePipeline built it, it tested it, and then it deployed it, everything on its own. So the manual intervention is completely eradicated. Then it ensures faster and more reliable code releases because every test and everything is done in an automated environment, not manually. So the amount of manual errors are reduced a lot, which means the code releases or the code version updates which are being made, they are much more likely to be more reliable. Then it automates the movement of code through different stages like source, build, test, and production, as we saw before. Moving on to the next question. What is the role of AWS Elastic Beanstalk? We just looked at infrastructure as a code, where we're typing out the infrastructure in the form of code and then it was getting deployed on the servers. AWS Elastic Beanstalk is platform as a code, where a platform is given to you, meaning, say if I have my Node.js file, I can just upload that whole file into Elastic Beanstalk. I don't have to worry about the amount of CPUs required to host my application, my website, or the RAM required, or the storage required, the amount of S3 buckets need to be added. Every single thing will be taken care of by Elastic Beanstalk. All I have to do is just upload my code file. Whatever code I've written, CSS file, JS file, HTML file, React file, or whatever it is, all I need to do is just upload it to Elastic Beanstalk, and the underlying infrastructure such as the CPU, RAM, storage, everything, Beanstalk will take care of all of that. That is platform as a service, where it gives you a platform and all you need to do is put your code in it. To look at the proper definition, it is a platform as a service that simplifies the deployment and management of applications. It can automatically handle infrastructure provisioning, load balancing, scaling, and monitoring. Another feature, load balancing. So depending on the traffic, it can again either scale up the resources, as in add more resources, or scale down the resources, that is decrease the number of resources. Meaning you only pay for what you use. Amazon Web Services is key feature, pay-as-you-go model. So say I deployed my web application. Let me just show you in practice how it would look like. So say I just deployed my application on Elastic Beanstalk. It was just my Node.js file. I uploaded it on Elastic Beanstalk. And there are a couple of EC2 instances that I require. I don't have to worry about how many EC2 instances I require or my servers require. AWS Beanstalk will take care of all of it. Now, all of these EC2 instances are deployed or provisioned by Elastic Beanstalk on its own. And then another load balancer, which we talked about load balancing, there's a load balancer here installed again by Beanstalk itself, which makes sure that none of the servers are, they are not unhealthy, or all of them are functioning, and the traffic is getting distributed evenly so that none of these servers are under a lot of pressure. Then all of these EC2 instances, the temporary files or the cache files that they generate, will again be stored in S3 buckets, which is again provisioned on its own by your Elastic Beanstalk. Next, all of this, another additional feature, say I even want to add a CloudWatch in this, which will monitor the health of my application, the performance of my application, the CPU usage, memory. All of this will be provisioned on its own by Elastic Beanstalk. Moving on to our next question. Have you used AWS CloudFormation? Yes, we talked about IaaS. And if so, what does it do? CloudFormation. It provides infrastructure as a code, as we already discussed about. And then AWS resources are provisioned using JSON or YAML file. I haven't worked with YAML files, but I have worked in JSON files. So all you have to do is just write down whatever you need, whatever the functionality is, the amount of CPU you need, the amount of RAM, the amount of storage, and then upload that file to CloudFormation. It gives you an option to upload the file in either .json or .yaml format. You just have to upload that file, and every single provisioning stuff in the backend, AWS CloudFormation will take care of it. Moving on to our next question. What is the purpose of AWS CloudWatch? We just had a little bit of interaction with the AWS CloudFormation in the previous question, but what exactly does it do? Now, AWS CloudWatch is more like a guard dog, which monitors the performance of your resources. What resources? Your resources like EC2, RDS, and Lambda. How much resources are they consuming? Because obviously, your server should be in a particular limit that you have laid. It should not exceed that limit. So how do you make sure that your EC2 instance, RDS, Lambda, S3 buckets, and many more of your EC2 services like your CloudFormation, everything, how do you make sure that all of it stays in a limit? With the help of CloudWatch. You can set up CloudWatch and you can set up alarms, which is our next point. You can set alarms to trigger actions. But say if I'm putting an alarm in my CloudWatch that if my CPU usage exceeds over 80% in 5 minutes, then you have to trigger an alarm that your CPU usage is increasing, do something. So that is CloudWatch. Next, it analyzes logs for debugging and insights. There will be, it even have logs in which it writes down EC2 used this much, RDS used this much, CloudFormation used this much resources. So it logs everything down, and it can even analyze it and debug it on its own. Moving on to our next question. What are containers and why are they useful? Now, containers, the most effective or the most simplest ways I can explain is, you must have heard of that coder meme in which your code is working on your laptop, but as soon as you try to open it in your friend's laptop or in your teacher's laptop, it's not working. And then you are like, it's working in mine. I don't know why it isn't working in yours. So to solve this problem, you have containers, which is a lightweight, portable, and self-contained units that packages an application with everything, with its dependencies, all the source files required, and all the libraries required, so that it can work on both mine and my teacher's and everybody else's laptop the same way, and there is no partiality happening. So what does a container contain? They contain code, dependency, and configurations required to run an application. Now, there are a lot of famous containers that you can find, such as Docker, Podman, Kubernetes. Moving on to our next question. What is the difference between ECS and EKS? These are both container service applications. The main difference between them is that one of them is provided by AWS, Amazon, and one of them is provided by Kubernetes. Both of them are container orchestration service. This is a Kubernetes service and works natively with AWS services. It allows running Kubernetes workloads in the AWS cloud. So the difference is that EKS can run Kubernetes workload in your AWS cloud as well. When should you use which one? ECS is for the users who are familiar with AWS, and EKS is for the users who are familiar with Kubernetes. Moving on to our next question. What is AWS Fargate in very simple terms? In very simple terms, say I'm very lazy. I am, but say I am very lazy and I am supposed to deploy this much CPU power, this much memory for this app. I'm very lazy to provision everything on my own. So what I do, I just define a code infrastructure. It's not an infrastructure as a code, it's a compute engine. But say I'm just defining the code like in this way. I need CPU power this much, memory power this much for this particular name. And then I upload this code into Fargate, the whole code, not just this one. What Fargate does it can manage the underlying infrastructure, as in depending on the amount I've provided, that this much computing power I need. Depending on that, it can automatically provision EC2 instances or other resources to me based on what measurements I provided. AWS Fargate is a serverless compute engine for containers, and it provisions, scales, and maintains the servers automatically. All I have to do is say I want this much computing power, this much networking, and the provisioning of resources will be taken care of by Fargate. Moving on to our next question. Can you explain the concept of security groups in AWS? Security groups are basically a firewall, a virtual firewall that controls the access to your AWS resources. It can control the inbound, outbound traffic to your AWS resources. Meaning, say if you have a virtual server hosted on your EC2 instance, then you can control what kind of traffic will be allowed to your EC2 instance. And it defines rules for incoming and outgoing traffic. Let me just show you how it looks like. See, there's an inbound traffic, your HTTP traffic, port range is 80. You can see allow all web traffic. For SSH, allow SSH from a specific IP. All traffic, allow all outbound traffic. It's the same setting for inbound and outbound traffic. You don't have to change them separately. Moving on to the next question. What is IAM and why is it important in AWS? IAM is one of the most important features in AWS. IAM, or Identity and Access Management, it defines fine-grained permission. What does that mean? Say, if a group of users are accessing your web application, it's like, say, the difference between a friend and a best friend. So if a friend visits your house, they would just, in a hypothetical situation, so if it's just a friend or just a colleague, you will just let them stay in your living room. You won't let them come into the other parts of your houses. But if it's a best friend, if they're closer to you, you would allow them to roam around your whole house, and you won't even mind if they're wearing your same clothes or anything, right? That is how IAM can control this kind of permission for your resources. Such as if a user is entering, then they can make sure if a user has complete access over your website or if a user is just viewing your website. That kind of fine-grained control can be provided using IAM. Next, it manages access across all AWS services from a single place. You don't have to go around and look for everything else. It's like a whole dashboard. It's like say, imagine you have a tab in your hand, in which you can just manage all the access or manage all the doors or the locks in your doors from one single place. Then, it keeps track of everything with detailed logging and auditing features. Logging and auditing is, again, another very important feature in most of the cloud services in AWS. It was there in CloudWatch as well. IAM also, it's there. Next question, or our last question. How do you implement blue-green deployment on AWS? Now, this is another interesting concept. Say you have two areas, a blue area and a green area. Now, it's not color area. It's just the versions of your application. This is the version 1 and this is the updated version. This version, I made some changes. So, it's version 1.2. It's not actually blue and green. I'm just showing it so that you can see the difference clearly and you can understand why it's called blue-green. So this is my current version where the users, this is a version that's live right now. Everybody is using the application. And now I'm testing out the new version of this application where I've kept a couple of dummy users. These are not real users, just a couple of dummy users just to see if it's working or not. And if everything is working well and good, then what I do is I put a load balancer, like an elastic load balancer, and then I can transfer all of these users from this version into this version using my elastic load balancer. This is very simple, right? Now, the benefit of this is that in case something were to happen to this newer version, say something unexpected happened and it all went crashing down, I can just as easily send these users back to version 1 so that the downtime is significantly minimized. Meaning it maximizes the up downs, say for rollbacks, because you can just transfer them back using your ELB. Improved reliability, better user experience. You must have seen that 500 internal server error. If that is not happening, then obviously your user satisfaction will also be increased. So that is why you use blue-green deployment.
Just a quick info guys, Intellipaat offers an AWS DevOps certification course. With this program, you'll get trained in AWS services, CI/CD pipelines, infrastructure as code, containerization with Docker and Kubernetes, monitoring with CloudWatch, and much more, all through real-world projects and case studies. The course is taught by certified trainers and industry leaders who guide you with hands-on labs and practical assignments, ensuring you're fully job ready. With this program, Intellipaat has already helped thousands of learners transition into high-paying DevOps roles, and you can check out their success stories on our Achievers channel. Link is given in the description below. So if you're looking to build a strong career in AWS DevOps, this course can be your perfect launchpad. Visit the course page link in the description below and take the first step towards becoming a certified AWS DevOps engineer.